Hello, everyone, and we're back. Let's see. Remember uh, that we're doing this caterpillar puzzle, and so our goal today is at least to finish this thing, which is going to be a tough, I think, thing to do in the amount of time that we have. Uh, but I definitely am finishing within 8 hours because then Ranks starts streaming, and I do not want to cut into Ranks stream time. Yeah, camera. I'm already working on it as I do my intro. I'm multitasking, doing two things at once. But now I've completely forgotten what I was saying. There we go. How about that? I think that's good. Uh, so there we go. That's zoomed in a bit more for you. So we are about to do friend of the channel Glum Hippo's puzzle next in this string of 80-ish puzzles that Clover has made. Uh, so we have that coming. All right. So I did want to start before I jump in by just saying very much thank you to Clover for assembling this. This has been so much fun to do, and it's been really neat seeing these little bite-sized chunks from all of these setters who I know from the stream and I know from other places, and some by setters I do not know who now I have to go try and hunt down puzzles from to experience. So there's just a lot of cool stuff going on in here. All right, so I should not dilly-dally too much, though, and I should figure out what's going on with Glum Hippo's puzzle. So again, link in the description of where you can find this book. We're currently on puzzle whatever number Glum Hippos is. Where is it? There we go, 46. So I'm looking for the rules. One second. Where are the rules for number 46? I cannot find them. Uh, hey, Brian. Uh, okay, maybe I am blind somehow. This does have a red box, and a red box means I'm supposed to look up the rules. Okay, 47. I see the rules for. Where is 46? There's 45. Oh, I have no idea what the rules to this are. Uh, it was there. Where there? 46. There we go. Found it. Got it. It was at the very, very bottom. Okay. It was so small relative to the rules for 47, which boy am I looking forward to reading. There we go. Thermo Arrow Skyscraper. Yeah, so Thermo Arrow Skyscraper, and these arrows are placing skyscraper clues. So that is where this is. Okay, thank you, chat, for helping me locate that. So we have regular thermos, regular arrows, and these arrows are just effectively cloning a copy of a cell. And the outside grids are skyscraper clues for their columns. Okay. So let's start by the trick I learned yesterday, which is because we always have a 2x2 down here, we can always fill in two cells here. So these are going to be a 2 and a 6. Okay, so that means this number up here is at least 2, because I am going to see the 6. So if this is exactly a 5, this could be a 2. Sorry, this could be a 2. But let's see. Let's try some more sudoku first, just to get this started. So the 1 over in this box has to go in one of these two cells. So there's a 1 in one of these corners. So that means this digit here is at least a 2. Now, this digit can't be a 3 or a 4, so this digit's at least a 5. In fact, it has to be a 5, exactly. And that's a 6. That's a 2. That's a 6. Just by proper good lifting of the thermo, because it can't be a 3 or a 4. Okay, so this is a 2 or a... Oh, it's not a 2 anymore. This is now these are now a 3-4 pair. So this is a 3 or a 4. That's a 3 or a 4. These are a 1 and a... These are a 1-2 pair. Get rid of the corner mark. Okay, so let's see where that is going to bring us next. By the way, this 1 and the 14, they're leftovers from Panthera's lovely puzzle that was a camel. Spoiler. Last time. So we don't no longer need to look at the 1 and the 14. They're part of the previous puzzle. So if you are just joining us, that is worth noting. Okay. What could this arrow be? It can't be a 3 or a 4. It could be a 1 or a 2. Can't be 3 or 4 or 5. It could be a 6. So these are from 1 to 6. Let's see. Afraid Not says row 4, column 1 has to be a 3. Ah, right. It has to be a 3 because I can just read off the skyscraper. I see this cell, and that cell. Great point. Great point, Afraid Not. Hey, Jim, by the way. Welcome to the stream. Not sure if I've seen you around before, but welcome either way. And thank you, Shiking Chen, also, for pointing out where this was. I'm very glad chat helped me find these rules. This 3, that's a 4, that's a 3. So that is all good. Let's see. So that means there's a 3 up here in one of these 2 cells. The 5 in this box, actually the 5 in this box has to go here. Because if I put a 5 here, then I would need to put a 6 here and I can't. So this 5's actually placed, sort of weirdly, because the 5 can't go in either of these places. So that's really cute setting. So there's, oops, not D's. There's 5's over here in the corner. Let's see. Is there other stuff we can do? This digit has to be at least 3. This digit can't be 5 or 6. So this digit is 3 or 4. Because 5 and 6 both look at it. So this is 1 or 2. This is 2 or 3. This is 3 or 4. Spoiler, this isn't 3 because there's a 3 in the box. So in fact, this digit now is a 2 and that's a 1. That fixes that that's a 1 and that's a 2. Now this little arrow is looked at by both a 1 and a 2, so it's a 6 and that's a 6. Yes, please hit the like button. We greatly appreciate those of you who hit the like button. This is a 4. We appreciate you for watching no matter what you do, but if you watch and you also press the like button, that is extra appreciated. That's a 2. These digits are a 3, 4. So this is a 3 or a 4. Now if this is a 3 or a 4, that means this is a 4 or a 5, and this is a 5 or a 6, just by the magic of thermologic. Let's see. Can I do better than that? I mean, I'm presuming I probably can. Let's see. These are a 1 and a something. These are a 1 and a 5. Okay, I'm trying to figure out, do I know anything about the skyscraper in this column? So it has to be a 3 or a 4. But it looks to me like it could still be either of those, I think. Let's see. What are these digits? Maybe this is worth filling in. These are a 1, a 5, and a 6. So that one's not a 6. It's not a 1. That one's not a 5. These are a 3, 4, 2. It's not a 4. That one's not a 3. Oh, let's see. 4 breaks. Let's see. If I try and make this a 4. Oh, I see. Okay. If this is a 4, it makes this a 4, which makes this a 5 immediately. And so the key is this 4 actually forces this cell to be a 5 because of through the medium of the thermo. And if this is a 5, there's no way this can get to 4. So, right. So that's the key. The key is the effect. I really like that. The impact through the thermo of that. So that's a 3, that's a 4, which makes that a 5, which makes that a 1. Now this column still needs a 3. It has to go there. This column still needs a 4. It has to go there. Now that is satisfied. And now I think we're doing just regular Sudoku. That 5 looks over there and sees a 1 and a 5. That 5 looks over here and sees a 6 and a 5, and a 6, and a 2 and a 4. 1, 2, 3. And so now this row needs a 1. This row needs a 2. Nice puzzle. The sort of like penny drop moment of figuring out how this skyscraper clue connects with this thermo was really sweet. That was really nice. And I bet actually if you thought about that earlier, I bet you even could have made some deductions about how that was going to go. One thing I will say that I'm getting out of this is that 6x6s are really cool and have a lot of space to make a really cute puzzle with a simple idea that then sort of like solves and gets out of your way, so to speak. And I think that is something that I've not set a lot of 6x6s, but this is making me want to set more 6x6s. Perhaps I should make my next setting project like another pack of mean minis, as Sam Kappelman-Lyons likes to call them. Okay, so this next puzzle has a rule set that is a small novel. So let's read the novel. A digit in a blue square tells you how many of the surrounding digits, including the blue square itself, are odd. How many of the surrounding digits? That is up to 9 digits. Okay, so up to 9 digits total. Okay. Only count cells within its grid. Ignore the cells in grid 48 that are adjacent to a blue square, regardless of their parity. Okay, so yeah, again, nothing is allowed to see outside of its grid except that one Tirganus puzzle. A digit in a red circle is a watchtower. Oh, I'm terrible at watchtowers. It tells you the number of cells within grid 47 that it can see in all 4 directions, including itself. A watchtower sees all the cells in each direction up to but not including the first cell in that direction with a value greater than its own. Okay, so then we have an example. Let's see, let me make sure you can actually see the example, which you cannot. There we go. We have an example here, and this example shows a correctly filled watchtower. So the 5 sees everything up to but not including the first digit bigger than it in each direction. So it can't see the 6 because 6 is bigger than 5. It can see the 1 and the 3 and the 4, but not the 6 because 6 is bigger than 5. And then it can see the 1, and I count 1, 2, 3, 4, 5 cells. That is the value of the watchtower. Okay. And then a purple diamond is both a watchtower and an odd sweeper. Okay, so just to encapsulate, or just to summarize, we have red circles are watchtowers, which mean this county thing. Blue squares are odd sweeper clues. They just count the total number of odds in all 9 cells around them, including itself. And the purples are both. Okay, let's try this. I'm very bad at the watchtower constraint. I don't know why it does not click with my brain. I watched an entire video of Simon solving a watchtower puzzle, and by the end of the puzzle, I still could not tell you what the circles did. So hopefully, by the time I'm done this puzzle, I will know what a watchtower does. Thank you, David. Thank you. It was a lot of fun. I'm hoping that we can finish today. We'll see if we are successful. Okay, so this is a 4 and a 5. Okay, so I absolutely adore puzzles with grids that just have a bunch of colored shapes that mean things. That is like totally my motif. Okay, so this cell, yeah, we get a 3 skyscraper clue on the left. Wouldn't it be cool if that were true? I mean, it is cool that we had a skyscraper puzzle into a puzzle that's sort of like a fancy skyscraper. So this already sees these two cells plus this one. So this, even if this is a 4, it already sees these cells. And then needs to see this cell. If this is a 5, then it already sees these cells and needs to see either this cell or this cell, and then be done. Oh, that's a good way to think about it, Afraid Not, actually. That makes sense. That the watchtower itself is this height, and that's why it can see these things. I had not made that connection before. Let's see. What are the digits left in this this column? They are a 1, a 2, and a 5. Okay. So a 1 in a watchtower is always automatically satisfied. So we could do that. Now, here's the thing I know. This digit is at least a 3 because it sees all of the odd digits in this box. But then it sees also all the odd digits over here, of which there is either 1 or 2. So this cell I actually know is a 4 or a 5, just by counting and knowing how many odd digits there are in a box. Okay. Let's see. Could this possibly be a 5? I think this could be a 5. Oh, maybe the question is, could this possibly be a 5? Unfortunately, it could. I don't think it can be a 1, can it? This can't be a 1. If this were a 1, I would need all of these digits to be even. Is there any universe where all of these digits are even? No, because there's a 2 down here. There aren't enough even digits to put an even digit in every one of these. So this can't be a 1 because it's counting the number of odds. If this wanted to be a 5, I'd actually need all of these to be odd, and I can't do that either, actually, because if this wants to be a 5, I need all of these to be odd, and I don't have 3 odds left in the column either. So this is a 2. So these aren't 2. So that is a 1-5 pair. Okay, so that's one of the odds that this digit is going to see. Let's fill in candidates here. What are these cells? These cells are from... They're not 1 and 2. They could be 3, 4, and 6 is what these are from. Let's see. Russ says row 4, column 1 is not a 5 because it would require 4 odds in box 3. The circles aren't counting odds, right? The circles are watchtowers. Let's see. Okay, so if this is a 5, I think that does work because it would see 1, 2, 3, 4 in that direction, and then it would see, okay, this would need to not be a 6. Then that would need to be the 6. So if this is the 5, then that's the 6. Oh, actually, does this work either way? Do I actually know? I think I actually know the 6 is in neither of these cells. Because if this is the 5, I know I'm going to see all of these cells, and I need to see one more, so this can't be a 6. So if this is the 5, that's not the 6. But then I need to stop, so I need to see the 6 here. So actually, I think if I understand the rules here correctly, I think the 6 is definitely in these. So I think these are not 6. I think these are a 3, 4 pair, because whichever of these is going to be a 5, and one of them is, I need to... It's already seeing 4 cells in this column, and I need a 6 to stop it, because it's going to be a 5. So that means that these 2 cells are a 5 and a 6, which now means that this 2 sees a 1 and a 5 and a 5 over here. So that's already 2 odd digits. So that means that this is a 4 and that's a 3. All right. Andrew's pointing out, if this were a 6, then it would be saying that it sees 6 cells, except we actually can count. It would see 11 cells, and 6 is not the same number as 11. So actually the 6 can't go there. The 6 has to go there This is the last digit, which seems to be a 2. So this needs to see a 2. Okay, so it needs to see a 1 either in that cell or this cell. Those are the two options. One of these two cells has to be a 1. What are these digits? Let's go ahead and fill that in. These are 1 and 3. Okay, now. Oh, right. I now know this is the 5. This has to be the 5 because it's the one whose view is blocked by the 6. I just did not actually continue to put that together. That's a 5, that's a 1, that's a 4. Now this 2 needs to see a 1. The 1 has to be over there. So this digit now has to be bigger than 2, which is not a huge restriction, but it's true. Okay, which means that there's exactly one odd number in these 3 cells, owing to this 4, which sees all the odds in this box, which means that this number has to be a 5, and that's a 4, because I need to have my other 2 odds need to be hidden away in row 5 over here. Let's see. This number is already at least 2. Let's see. We've got a 1 and a 2 here, for whatever that's worth. These digits are a 3, 5, and 6. Neither of these can be a 6, because 6 can't go in a watchtower. And remember, both of these are watchtowers. Okay, we can count how many cells this 4 watchtower is seeing. Afraid Not saw this. It's seeing 3 currently. It needs to see 1 more. So this can't be the 6, or this can't be a 5 or a 6. And so if this can't be a 5 or a 6, it also can't be a 2, a 3, or a 4. So as Afraid Not points out, this has to be a 1, which makes that a 2 and makes that a 1. Okay. Now our story must end, because now the 4 is seeing... Now the 4 is seeing 4. Sorry, I highlighted this cell before and then did the math right anyway. The 4 is seeing 4, so this digit has to be bigger than 4, and it's not a 6, so it's a 5, and that's a 6. These 3 cells are a 2, 3, and 4. That one's not a 2, that one's not a 4. Okay, this 3 or 5... well, if it's a 5, it's right, for sure, because it'll see all of those and nothing else. If it's a 3, will this be correct? Oh, never mind. Easier question. Can this possibly see 5 odd digits? No, because it already sees 5 even digits. So this is definitely the 3, and this is the 5, and this clue is vacuous. It doesn't do anything. So these are both odd. So these are a 3 and a 5, and we know the order. Because this 3 needs to see... Nope, that's not how that works. Don't listen to me. This 3 needs to see 1 more odd, because the 3 counts itself. But that does tell me that that's a 4. That's not a 4. So that's a 2 or a 3. I eventually got there. I was just slow. 1, 2, 3, 4. These are 5 or 6. Okay, well, this can't possibly ever be a 6, because if it were a 6, it would be saying that it sees 6 odd digits, which include itself. So it's a 5, and that's a 6. These both have to be odd, which means they have to be 1 and 3 in that order. That time I did count correctly, right? Yes, this is 5 odd digits. That being a 5 makes that a 6, and that a 5. That being a 3 makes that a 2, and that a 3. 1, 2, 3, that's a 4, and that's a 2. Well, I didn't count correctly the first time, Tallcat, so don't get too excited. I do not believe there's an LMD link. I believe the wish of the constructor is that the only version of this that exists is the Google Doc version. So that is linked above. Yeah, that was very nice. This certainly, I think this could be a 9x9 puzzle. Like this is an awful lot. Like I think reading the rules took as long as doing the puzzle, but it was very smooth. So I applaud Polando. By the way, I did not actually say Polando is the person who set this. I applaud Polando for taking a somewhat complicated rule set and actually making it into a super smooth, super quick puzzle, which I appreciate in the context of this challenge. Okay, so next up we have a Ranksk puzzle. Friend of the stream, Ranksk, who will be streaming after me. So I am doing my very best to finish this puzzle before his stream. We'll see. Okay, so Ranksk puzzle is also special. That is 48. Hey, Ranksk. 48. Oh boy. Okay, so the between lines, in addition, the digits along each line have the same sum in each region that line passes through. Okay. And we have to keep in mind there's a red dot missing in the next grid I saw. Okay. So yeah, so this is both a region sum lines and a between line puzzle. So let's get started. So first of all, I know that these digits include a 1, and the 1 can't go on a between line, so that has to be a 1. And note circles are not on lines. Sorry, let me read that again. On each line have the same sum. Oh, for example, so I did not read the example of F1 column 2 3 must be equal to the sum of row 2 column 4. Okay, so literally it's only the line part. Sorry, I did not get that. I'm glad I had Ranksk here to correct me. It's only the line part that is a region sum line. This still has to be the 1 though. This is a 3. So this digit is a 4, 5, or 6. Yeah, I mean, I don't think it's that the rules are unclear. Like if you, I think the rules are very literally correct if you think of these as a line. But then sort of like my natural inclination to sort of shortcut it was to think, but I would make it so I would probably have thought to do it the other way, and then that made this trickier. Okay, so these digits are a 3, a 4, and a 6. These are a 1, a 2, and a 5. Okay, the 6 is over here in this box, just by Sudoku. So the 6 is down here in this box somewhere. Yeah, there's always a compromise in writing the rules when you have those things. And hey, Clover, by the way, everyone say hi to Clover. Thank you very much for showing up. I appreciate. It's hard to say just how much I appreciate this this compilation that you have put together. Even if this is the puzzle where I cannot solve anything more. Oh, awesome! Fixing a bicycle and listening to puzzle solving. That sounds great. Let's see. Okay, so yeah, the 1 in this box goes in one of those places. That's not super exciting. I'm trying to figure out, okay, if I were Ranksk, what would I do with the fact that these 2 digits had the same sum as these 2 digits? That would have been amusing. Yeah, I have done that before in Ranksk's stream where I've started chatting under my personal YouTube. For lack of better things to do, I'm going to fill in these digits. Oh, and that's useful, actually, because I'm realizing I have a 1-6 pair in this column that I had not appreciated before, because because I need to put 1 and 6 in this column. So I have a 1, 6 hidden pair in the column. And so that means these digits are a 3 and a 5. Let's see. These digits are a 2, 4, 5, 6. That one's not a 6. That one's not a 6. Okay, so we're very limited. So I guess the question is, can this be the same exact digits as that? And I think, unfortunately, the answer is yes, they could. I was hoping that they had to be different sets of digits with the same sum, which would be restrictive, but I don't think they do. Okay. Let's see. Okay. Could this ever be a 4? If this was a 4, I would need to have 2 digits. This would have to be a 2 and a 3. So if this were a 4, it would have to be a 2 and a 3 here and a 2 and a 3 here. Unfortunately, I think that's okay. Oh yeah, they actually, you're right. Chat is correct. Chat makes a good point. They have to be the same digits. Because if I look at where these 2 digits go in this box, well, they go in these 3 cells. But that means one of them is on the line, but because they have to have the same sum, as soon as one of them is on the line, the other is also on the line. Okay, so this is a great point by chat. So, yes, so these 2 digits are these 2 digits. I danced around that without meaningfully improving it. Okay, so okay, so the sum, yeah, the sum is at least 5. Although I guess this means I don't have to think about the sum at all. The sum is not what's relevant. Yeah, I agree. These 2 digits are the same. I can pencil mark that as 1, 2, 3, 4 if you like, and pencil mark that as 1, 2, 3, 4. But I can pull out my my coloring set. Those 2 are the same. Those 2 are the same. Try to get out of the coloring business, and chat is always pulling me back in. Yeah, so the 6 in this column has to go either here or one of these. I hope Jaleb's saying WXYZ wing is a joke. I fear it's not going to be, but this is going to be a long puzzle if I have to figure out what a WXYZ wing is. Though I now want to make it a hobby to just go into random Sudoku chats and just post WXYZ wing at random times, as that seems like a great way to terrify to terrify people. Okay, so yeah, so let's think back to, okay, if this circle is a 4, what has to happen? Then this has to be a 2 and a 3. That has to be a 2 and a 3. That has to be a 1. So this would be 1, 2, 3. Ah! Gorgeous, gorgeous. Okay. So yeah, I was 1 step away. This cell has no value in that instance. If this is a 4, these are a 2, 3. So then these are a 2, 3. this has to be a 1, and now this cell is looking at a 1, 2, 3, and a 4. So that doesn't work. So, oops, sorry. So neither of these, no, neither of these is a 4. Exactly the same logic applies up here. Okay, now that I know that this digit is low, does this digit have to be high? So now I have to think about, could this be 3 with a 4, 5, and a 6? So, okay, so if this is a 3, this would be a 4, 5, that would be a 4, 5, this would be a 6, and that also doesn't work for exactly the same reason, or almost exactly the same reason. This would be, that. Oh, and even in that instance, I was still making this high. But anyway, this can't be a 3. I was trying to disprove something completely different, but it was totally irrelevant. But this can't be a 3 because it would make this a 4, 5, that a 4, 5, and that a 6, which would break that cell. So this can't be a 3. This one probably can be a 3 and probably has to be a 3. I nailed it while trying to prove that this digit had to be bigger than that one. By putting in a digit that was bigger than that one, question mark? Okay. This digit has to be at least 2 more than this. Sorry, it has to be at least 3 more than this digit. So this digit has to be at least a 4. So this is a 4, 5, or a 6. This digit has to be a 4, 5, or 6. Yeah, it has to be at least 3 more. Okay, do I know anything about the world yet? Not quite. Oh, we already argued at great length that this can't be a 4, right? Because if this is a 4, that's a 1. Then these are a 2, 3, and that's a 2, 3. And I guess it's not exactly the same argument that we had before, but it's basically the same argument we had before. If it's a 4... then this digit has no value. It's just flipping these 2 cells from the previous thing we eliminated. So that's not a 4. And the same thing has to work with this. If this were a 4, that would be a 1. These would be a 2, 3. These would be a 2, 3. And now this cell would see 1, 2, 3, 4. So these are, in fact, a 5 or a 6. Now, Tallcat is seeing the favorite deduction of zetas around the world, which is that this bulb has to go in this box somewhere, and it can only go here now. So this digit has to be a 1 or a 2. Likewise, this digit has to... Nope, sorry. Can't make the same deduction over there. Okay. So, yeah, so if this is a 2, that's a 1, and that's a 1. Unfortunately, that works. Oh, yeah, 5, 6 pair in column 1. Thank you, SBQ. So that's not a 5. That's not a 6. This is just a 5, 6 pair, straight up. Okay, so that's a 1, 2. That's a 3 or a 4. Yeah, this one little between line is really doing its job. Okay, so was this the very last placed clue, Ranks? This between line? Okay, so someone asked where row 3 column 5 goes in box 3. Did I not do row 3 column 5 correctly? Because I feel like this could go literally any of these places, couldn't it? Oh, is the point... no, it can't, because this digit... Okay, so sorry. Let me color this just to make this clear, because I did not see this, because you need actually to color to see this. This digit we already said is that digit. So then we pick a different color. That digit, where does it now go? Down here. Well, it's not blue. So therefore, it has to go in one of these two circles. That's really cool. I like that a lot. So this goes in one of those two circles, and therefore is a 6. And that's therefore a 1. These, therefore, are not 1. Therefore, one of these two is 1. I don't know if that is useful to write down. Okay, so now that this is at least not a 1, that's not a 2 anymore, because I can't put a 2 on a between line with a 2 or a 3. Now there's only one place for a 6 in this box, so that's a 6. Or column, or whatever, take your pick. Let's see. If this cell is a 2, then that's a 3. It's a 5, and that's a 4. Okay, maybe that's not productive. Well, I can go ahead and fill in. I know these digits are from 3, 4, 5, I guess. Is that useful? Maybe that's not useful. Good point. Okay, so SPQ has I think, what's going to resolve everything, which is to ask where 2 goes in column 4. And the answer is 2 in column 4 only goes in one of these two cells, which in fact tells us that these are a 1 and that this now has to be a 3 or a 4. It's not a 1 or a 2. Because as soon as 2 is over here, it's not also there, which, remember, mirrors the 1 over to here. This digit is not a 1 or a 2 anymore. I now have to place the 2 in this box. It can only go horizontally on this line now, because it's ruled out of everywhere else by some sort of magic. So this is not the 2, or in the corner. So this now is the 2. So these digits are from 2, 3, 5. Now, yeah, if that's a 5, that's a 6. Okay. If this is a 5, this is a 3. So then this is 2, 3. Yeah, I don't quite see that. Okay, let's look at, why not 2 and row 3, column 1? Because these two are the same digit. Is the answer. Yeah, the puzzle effectively says these two cells are the same as these two cells, and these two cells are the same as these two cells, as sort of additional information. So that's not a 1. Now 1 is placed, thanks to us sneakily placing this 1 and then completely forgetting about it. The 1 is now placed here, so the 1 is now placed here. This is not a 1. Yeah, I somehow placed this 1 and then completely did not follow through with it at all. Yeah, one of these two's a 2. I know these are from 3, 4, 5. I'm going to go ahead and fill that in because it will make me feel like I'm doing something. I know one of these two is a 6. One of these is a 2. Oh, interesting. Okay, so... No, that doesn't work. I was about to say something that was wrong. 3, 4 pair. Yes, 3, 4 pair in column 1. Thank you, SPQ. And Andrew. So that's a 2, and that's a 2. So that's a 3. So this is a 4, 5. So that's the 5. That's the 4. That 5 looks over and sees that that's a 6, and that's a 5. That 5 looks over and sees that that's a 3. So that's a 4. That's a 4. That's a 5. We've got something left in this row, which is a 6. These aren't 5. Hello, Hippo. We're happy to have your kind here. 3. Did you miss your puzzle? If so, I'm sorry if you missed your puzzle that we did earlier. We enjoyed it. It was very nice setting the way that you combined it. Combined the skyscraper with stuff. I'm not being maximally articulate at the moment. That is a 5. That's a 2. This 3, 6 looks down and sees that that's a 4. That 4 gives me that that's a 3. That's a 6. That 5 looks up and sees that that's a 4, and that's a 5. In space, no one can hear you impersonate a hippo. That's probably true. Very nice puzzle. Yeah, I liked the way that immediately what you got with the givens was that this cell had to be a 4, 5, or a 6. And then this cell being a 4, 5, or a 6 ruled out one of the possibilities for this line, which then pushed that possibility up to this line. That was very cool. And so here's a thing you can think about if you want. If you removed this clue, then this set of 2 rows and this set of 2 rows would be completely indistinguishable. And so the puzzle would have at least 2 solutions, because you could always swap these 12 cells and these 12 cells. So there needed to be a clue that touched this, and this did the absolute minimum amount of touching by doing just this one cell, which did a tiny bit of restriction, and then that broke everything else open in order to make this unique. That's very cool. Big thumbs up for that one. All right, this next one, I know I need to keep in mind that is missing a red dot somewhere. So let's look at the rules and the red dotitude. So this is 49. Okay. Oh, sorry, maybe this is saying if you opened the link before 5 p.m. So, or if you're using the section links at any point. Okay, so yeah, so there is a red dot in the image at the right. Okay, where am I adding the red dot? Let's, I am going to use the red dot only for the reason, the red dot is here, only for the reason that I want to get this done today, and I don't want to be pushing too much against Rank's stream. So we're going to imagine the existence of a red dot right here. And then we're also going to learn what a red dot means. A red dot, because I just completely skipped that. If a red dot appears at the intersection of 4 cells, then call those cells A, B, C, and D as shown. The 2-digit number CD, read as one number, must be divisible by at least one of A, B, or the 2-digit number. No negative constraint applies. Note that all 2-digit numbers are divisible by 1. Okay. So there's a red dot here, for example. And that red dot there tells us that, sorry, did I not move my camera? I don't remember moving my camera. I absolutely did not move my camera. Let's move the zeta. We have moved the zeta. The zeta has been moved. So this 13, sorry, wait, is it the other direction? I've now forgotten already. Then the 2-digit, no, it is CD. Okay, so it is the useful direction. Okay, so because of this red dot here, what we're saying is either this 2-digit number, or that number divides 13. Well, 13 happens to be quite prime, above averagely so, you could say. And so it's only divisible by 1. So one of these 2 digits has to be a 1, and that has to be the 1. And so now we no longer have to think about this constraint, if I understood that right. It's not multiple, right? It's has to be Divisible by. Yep. So it's divisible by. So we get to place this 1 right away, owing to the red dot that we were told we were allowed to place here. And then we did this. Yeah, it's very confusing to keep straight which is a multiple of and is divisible by and divides. All of these different ways of saying the same thing flip around which digit is which. But in this case, we're saying the high digits, either the number itself or the one of the two, divides the lower number. Okay, these two digits, let's go ahead and fill in while we remember that we're supposed to fill these in. So this is 1, 2, these are 4 and 6. Oh, I am somehow not, I'm not actually in this window. These are 4, 6. Okay, so I was about to say 24 and 26 are both divisible by 3, but spoiler, that's not actually true. 26 is not divisible by 30 anything, and in fact, the only divisors of 26 are 2 and 13 and 26. So this can't be a 6. This is a 4. And that's a 6. And this actually works both ways. Both 3 and 6 divide 24. That's fine. Now, let's write down more digits. These digits are a 4, 5, and a 6. Let's see. 6, 4. Okay, so these are a 2, a 3, and a 5. Oh yeah, that's probably good. I should probably write. I should probably follow chat's advice and actually write in the candidates here, because the candidates are 1, 3, and 6. And 41 and 43 are both problematic because both 41 and 43 are prime. Now, 40, and I can't put a 1 up here because the 1's already taken. So this has to be a 6. And so the divisors of 46 are 2 and 23, so this has to be a 2. Now, 62 is actually 31 times 2, so this... And this can't be 31, so that has to be a 2. Do people like that? Did I do that correctly? I think I did that correctly. Is there a 4 and a 5 in some order? Let's see. Okay, so yeah, so that's a 2. This can be anything. This is not a 2 anymore. Let's see. These are 3, 4, and 6. But proving things that aren't true is like my specialty as a mathematician. Okay. Okay, so... I was wondering if this number could possibly be a 4, but I think it can if this is a 6. Oh, okay. I'm being told that I should fill in the candidates in this box. Oh, by the way, I'm bad at this. This is by Punching Kato, by the way, who did among other things, the wonderful Secret Santa thing, which I hope you participated in. 2, 3, 4, 5. So this is another familiar face to folks around the Sudoku scene. 61 won't work because 61 is prime. It sounds prime at least. And I couldn't put a 1 here anymore. Any of 63, 64, or 65 would be fine though. Now, if I used 63, I would need this to be a 1. If I used 65, I would need this to be a 1. Why doesn't 63 work? Why can't I make this a 1? Yeah, I mean, unless I'm using the 1, there's no reason this can't be a 1 unless I'm seeing something something down here. So I'm curious if there's any way this digit isn't a 1. And so I think this digit's always a 1, isn't it? 63 is divisible by 1, Russ. Unfortunately. 6432 works. That's right, because we are allowed to use double-digit numbers. I was forgetting about the double-digit numbers. Okay, so there's a couple possibilities here. 64 is already divisible by 2. Even better. Sorry. Okay, so yeah, that is not actually helpful. Okay, so where is 2 in something someone asked? Where is 2 in box 4? Good question. 2 in box 4 definitely goes here. Just by Sudoku, that I was apparently hesitating to do. Can row 3, column 2, ever be a 5? So yeah, the fact that there's no 1s up here is very interesting. So yeah, if this is a 5, then the only numbers... Let's see, yeah, so I should write these in. What are these digits? 2, 3, 4, 6. That one's not a 6. That one's not a 2. Oh, 2 in this column is placed. 2 is placed in this column right here. I should go ahead and do that. That's probably helpful. Okay, so so if this is a 5, this is the hippo's point. If this is a 5, then what things divide this number? So if it's 35, the answers are 5 and 7, which isn't going to work. If it's a 4, then the answers are 3 and 5, which isn't going to work because I can't put a 3 up here. And if it's a 6 and a 5, 65, that's a 13, and I could put... Oh, I can't put a 26 up here because it wouldn't be even. Okay, so yeah, so it can't be 5 anymore. We have now run out of options for this cell to be 5. Not 5 anymore. So one of these two cells is a 5, which means this cell's a 5. While we are at filling in digits of places. These two digits are a 1 and a 3. So that digit's not a 3. Let's see. Yeah, 25 is problematic to be the bottom number of one of these because of it being a perfect square and all. So if I try to put 25 here, because of these 1s down here, I now actually am forced to use interesting numbers up here. So this can't be a 5 either. So this is a 5. These aren't 5. So I now have a 1, 3, 4 triple. So this is now a 6. So that's a 4. And the 24 is satisfied by the 6. That's a 6. So these aren't 6. Okay, so I need either this to be... this needs to either be... Oh, this is automatically going to work because there's a 2 there. And as soon as there's a 2 there, anything works down here. Let's see. These aren't 4 anymore. / they weren't 4 as soon as I did that up there, but whatever. Yeah, the always being a multiple of 2 is a little sad. Okay, so let me fill in the rest of this row. The rest of this row is 1, 3, and 4. Okay, if this were 21, that could be a 3. That's fine. If this were 23, this is broken immediately, so that's not a 3. If this is 24, then it works automatically because that's a 6. So that's all good. Okay, I am being told that 6 is placed in the something something. 6 is placed in box 4. 6 is there. People like placing a 6 there. 21 doesn't work. Right, 21 doesn't work because 21 is divisible by 3, but that would break the 1, 3 down here. So this is not 21. This is always 24. But 24 is automatically satisfied, so it's boring. Sorry, I did not mean to insult you, but it is what it is. Now 1 is placed up here. So that's a 3, that's a 1, that's a 4. This is not a 1. This is a 3-5 pair. This has been a 4 for some amount of time. Let's see. That 1 means that's a 3. That's a 1. That 3 means that's a 5. That's a 4. That's a 5. That's a 3. That's a 5. That's a 3. And then the puzzle's done. Yeah, I worry that in a 9x9 this would end up being a little bit tedious, but it was very nice in a 6x6. I mean, I think that's one of the nicest things about 6x6s is if you have an idea, but then it turns out that like in a 9x9 it ends up having a little bit of stuff. So we've seen a few examples of this. So I think this is one puzzle. We've seen some stuff with negative constraints where I think negative constraints work really well in a 6x6 because then there's not so much scanning to do. So I think that 6x6 might have been perfect for this rule set. Okay. So next up, we have a puzzle by a familiar to you setter named Zetamath, of all people. Signpost? What are we talking about? Alrighty. Yeah, let's see if I can do this one. Okay, so this is a Whisper Arrow Renbon. Everything is standard. Whispers, by the way, remember, whispers in 6x6s mean the difference of the adjacent digits is at least 3. So these digits are a 1 and a 3. So the thing that I entirely based this puzzle around was the fact that if this digit was a 3, it breaks this Renbon immediately. Because if this is a 3, the only thing this length 3 Renbon can be is 4, 5, 6, and it can't be because of the given 5 and the 6. So I tried really hard to sort of like use my givens, and that was my sort of like thing was, okay, this length 3 Renbon immediately tells me that that has to be a 1 and that has to be a 3. And so now if I look across, the things that are left in this row are a 2, 3, and a 4. Now, this Renbon, well, what can this digit be? This digit can be a... it has to go on a Renbon with a 2, 3, or a 4. It can't be a 1, so it could be a 2, it can't be a 3, it could be a 4 or a 5. Those are the only options for this digit here. The artist formerly known as Zetamath, is that what we're going with now? So that's all I remember. That was my recollection, was that I set this up so that this little bit would work around that digit. Let's see. If this was a 3, then this Renbon wouldn't have a 3 on it, so this can't be a 3, because this Renbon would then be ruled out of having a 3 on it anywhere. So one of these two digits is definitely a 3. which means that, in fact, there is a 4 on this Renbon somewhere, but I don't know where yet. Jaleb has a good point, which is absolutely not how I set the puzzle, but it is true. This digit can't be 1 or 2 because of the arrow, and then can't be 3 or 4 because of this Renbon, because this arrow is in a place that sees the entire Renbon. So this has to be a 5 or a 6. I know that the arrow was the last added clue. So in my path, I was intending to use. I was not intending to use it, but that is fine. I don't need to follow whatever path I happen to dream up. So we do need to alternate between high and low on this whisper line, and it is probably worth thinking about what digits this could be. So if this is low, it would have to be a 2. And that's probably a problem. Maybe not. I intended the Whisper parody to get resolved by... Oh, sorry, I know what I'm supposed to do. Okay, so I remember what my intended path was. This digit definitely goes here. That was the intended point. So if this digit was a 4, then I would rule 4 off of this entire Renbon, which would break. So this digit can't be a 4. That was my intended point when I set this. So this digit, just by the Renbon math, it has to go in one of these 2 cells because it can't repeat on the Renbon. So this digit can't possibly go here, and so this digit can't be a 4. It has to be a 2. Which says that these aren't 2. These are a 3-4 pair, which says that's not 4. It's 2 or 5. But also it's not 2, because 2 needs to go in one of these 2 cells by the thing we just noted, so that's a 5. So now this Renbon, if I look at it, needs to either be... So these cells are... Yeah, so these cells can't include a 6, I guess is the point. Could these be 1, 2, 4? I think they could be 1, 2, 4. But let's see. Let's fill in the candidates for this cell now. Oh, no. Here's the correct question. Where does 2 go in row 3? This was the way I again designed this, I remember now. I'm just trying to remember how I actually intended this to be done. 2 in row 3 now can only go in one of these 2 cells, which fixes the orientation of the whisper. So 2 has to go in one of these 2 places, because this 2 rules it out of that cell, and this Renbon rules out of all of those. So one of these is the 2. So, in fact, that means this cell is low, and it's not a 1 or a 3, so it is the 2. This is now a 1 or a 3. So this is now a 4 or a 5. And it can't be a 4, in fact, actually, because it needs to be at least 3 away from 2, and 4 isn't, so that's a 5. This is now a 5 or a 6. This can't be a 3 anymore, because if this were a 3, it would not be far enough away, so that's a 1. So now we look at what the rest of the cells in this thing are. There needs to be a 6 here, just for the box reasons. So yeah, we got to rediscover it together because I certainly did not remember remember it originally. 2, 3, 4, 5, 6. Although I certainly very deliberately set it up so that there would not be so tight of a path that you couldn't solve it without discovering this. That 5 sees that that's a 6. These aren't a 1, so that is a 1. These 2 digits are now a 2 and a 3. These 2 digits are a 4 and a 6, and I know the order. So now my line, well, my line can't have a 6 on it. Sorry, my Renbon over here I know can't have a 6 on it, so we've now actually placed the 6 here. So that's now a 6. So my line, though, does have a 5 on it now. So these digits are a 3, 4, 5. This one's not the 5, of course. So these digits are a 1 and a 2 by that. Let's see. So what are these digits? It would be funny if I broke my own puzzle. I mean, it's entirely within the realm of possibility. The 6 is placed down here in this box. So these digits are a 1 and a 5. Yes, those are a 1 and a 5. Let's see. Now, these are either a 2, 4 or a 1, 5. That one's not a 1, so that one's not a 5. This one's not a 4, so that one's not a 2. So this is a 1 or a 2. That's a 4 or a 5. That gives me a 3, 4, 5 triple in the column. I remember being very happy with that. So this 3, 4, 5 triple in the column gives me that's a 1, that's a 2, that's a 1. Yeah, I was just pencil marking based on high-lowity, and then I went and resolved the whisper business. So that's a 1, which makes that a 2 now, which makes that a 4. That 2 makes that a 3, makes that a 2. That's a 1. That's a 5. We now have over here a 3 and a 5. So that's a 3, that's a 5. That 3 looks down here and says that that's a 4, so that's a 3, that's a 4. That 4 looks down here and sees that that's a 3 and that's a 4. That 3 and 4 look there and see that that's a 5. And that's a 3. And that is my puzzle with... I'm pretty sure that was basically the intended path that I did there, including the finding the hidden single 2. The arrow was just there to sort of resolve stuff at the very end, but it also gave you enough restriction that the arrow I knew would let you get through the puzzle if you didn't see the stuff that I had sort of designed. And I did not want my puzzle to be too difficult, as I have a reputation for that. Hey, great tool, by the way. Ooh, nice. Nice, Playmaker. Playmaker's making another 6x6 pack. The last one was much appreciated. Okay, so next up, we have Christoph Seeliger's puzzle. Christoph is a regular featuree on the channel in terms of his puzzles. Usually with X sums, but this time it looks like we're doing a regular Kropke puzzle with a lot of crappy dust. In fact, just take a second to just admire the fact that this is a puzzle. Like the elegance of this as the grid is amazing. I did set it up so you can actually see, right? Yep. So 1, 2, 3, 4, 6 go here. Alrighty, so we're going to go ahead and we're going to color this in odd and even. So just because along a dot, everything has to alternate odd, even. So we're going to color it Oh, I guess I shouldn't use that. Maybe I should use yellow. That's not yellow. That's yellow. We'll do it in orange and yellow like that, just to color odd and even. Add nice looking dots until the solver says it's unique. Don't tell everyone your secrets, Christoph. Okay, so we actually know, oddly, we know these two digits have to be odd. So these are from 1, 3, 5, because I know one of these two is even, and it's the last even for the column. Why yellow? If anyone wants a different color, I'm happy to consider different colors. I could make, actually, maybe I should do yellow, but also do purple instead of orange. Oh, sorry. Yeah, we'll do purple and yellow. I think that's better. Okay, this 1, 5, that actually doesn't tell me anything. I was trying to stay away from red and blue because red and blue are the colors people usually use for odd and even, and I don't know which is which. That was the only reason why. So I actually know this digit's even. Because I know I have an odd and 2 more odds, so this digit's even. Maybe I should have started by coloring the things I knew instead of the things that I didn't. You know the odd on the dot in column 2. Ah, that's very clever. Okay, so that is genius, Ambrose. So there needs to be an odd on this. It's not a 3. Could it be a 1? No, because if it was a 1, I'd need to put 2 2s around it, and I can't because there's a 2 in the column. So actually, I know that one of these two digits is a 5. That is very clever. So that means that that is not a 5. And it actually means that these digits are from 4, 5, 6. And actually, it means this is a 4, 5 pair, because neither of these digits can be a 6 for the same reason they can't be a 1. So these are a 4, 5 pair. So that means that these two digits are a 1, 6 pair. So that's not a 1. So that is good. This isn't a 4 anymore. Oops. I added a digit instead of taking one away. This isn't a 4 anymore. Oh, I need to put a 6. Yeah, I need to put a 6 somewhere in this box. The only place I can put a 6 in this box... Oh, I guess it's in one of these two cells. Never mind. Ignore that claim. Let's see. Got my 2 odds here. What are these digits? Right. I should do the same thing. I've used 4 and 6, so one of these two is a 2. Well, 2 neither works with 4 or 5, so 2 can't go there. So therefore, this is 2. And therefore, that's 4, that's 3, that's 5. Gorgeous. This is a really nice break into this. So now I need to put a 2. I can't put the 2 there, so that's going to be a 6. That's going to be a 2. So yeah, all of that just fills in. That 3 looks down and sees that that's a 5. So now this is a 1 or a 3. Oh, I said the right thing out loud. Doesn't that count? I feel like saying the right thing out loud should be close enough, especially when it's only the 4 squares that go into the next puzzle. I don't think it's that big a deal if we put them in the wrong order. Let's see. Okay, so these two digits are a 3 and a 4, so this is a 5. This digit here is a 1 or a 3, so this digit is a 2 or a 4. So this digit is a 1, 3, or 5. It's not a 5. It's a 1 or a 3. So this digit is a 2 or a 4, and it's not a 2. So it's a 4. just because of the row. So that's a 6. That's a 4. That 4 connects to a 3, which makes that a 1, which means that has to be a 2. That 1 comes over here and says that's a 6, and that's a 1. That 3 comes over here and says that's a 4, and that's a 3. So now 1, 2, 3, 4, 5, 6. I'm hoping the wrong order is referring to the previous thing and not to the fact that I did that again, which would be very believable. 4 in this box now goes here. 5 goes here. Let's see. These two digits are a 3 and a 5. I don't know the order, actually. These digits are a 1, a 2, and a 6. Well, I know which one that is. That's the 6. So these are not 6. They're 1 or 2. Let's see. These digits are a 2, 3, 4. That one's not a 4. That one's actually, this one just is a 2. So that's a 3. That's a 5. That's a 3. That's a 4. That 2 gives me that's a 1, and that's a 2. Let's see. 1, 2, 3, 4, 5. Let's see. That's a 6, and that's a 1. That is a really nice puzzle. Actually, despite Christoph's joke that you just add dots in nice places until it comes out unique, actually the solve path here was really nice. Again, with the using the givens here and thinking about, okay, well, I know that there's a 2 on this dot, and I also know that there's a 5 on this dot, and that combination giving you this whole line, that was really cool. I really liked that one. That one was really, really smooth and nice. Thumbs up. Okay, next we have Prasanna Sasadri. Prasanna Sashadri. Sorry. Okay, puzzle. Did we already do a Prasanna puzzle as part of this? I don't remember. I no longer remember anything from before doing this. Hey, Anne, welcome. Okay, so this is a puzzle where I need to go read the rules. So this is 52. Oh, Clover confirms, and I am certain if anyone in the world knows that Clover knows, that there's only one. Oh, I remember. Last night when I finished, I looked ahead to see what setters I was going to do next, and I saw that there was a Prasanna puzzle. That's what I'm thinking of when I think of this. So I knew there was a Prasanna puzzle. Okay. Okay, so this is a rank Sudoku. Digits may not repeat in a cage. Also, some cells in each cage contain a small circled value. Those values tell you the rank of the digit in that cell compared to the other digits in the cage from lowest to highest. For example, a cell with a circled 2 contains the second lowest digit. Oh, that's awesome. I actually was trying to set a puzzle with almost exactly these rules the other day. Except I didn't think of doing it with the ranks. I was only doing it with circling the highest digit. But this is a cool rule set. I am already excited to do this puzzle. Okay. Plus it's a Prasanna puzzle, so you know it's going to be good. So these are a 1 and a 3. Why are you not telling me that these are a 1 and a 3? Oh, there we go. These are a 1 and a 3. Now 1 cannot be the second lowest digit. So because 1 can't be the second lowest digit, this is a 3 and that's a 1. And that means there's no 2 anywhere in this cage. So these digits have to be a 4, 5, 6. The fifth highest digit out of 1, 3. So in other words, the highest digit is a 6. So these aren't 6. They are a 4 and a 5. These two digits are a 1 and a 5, which means that that's not a 5, that's a 4, and that's a 5. These two digits are a 2 and a 3 in some order. Now, with the, yes, again, very cute with the givens. Yeah, I think so much of this for me, and this is probably just because I was tasked with the same question, is in seeing how different setters used their givens that they got. Now, Russ is pointing out, I think, that the fifth digit in rank order can only ever be a 5 or a 6. So there's actually a 5-6 pair given in row 3. And I already have a 5 in this box, so I actually know the order. That's a 6 and that's a 5. Likewise, the second digit can only ever be a 2 or a 3 in a cage with 5 digits in it. This one I actually don't immediately get to disambiguate the order on. But this being a 5 actually tells me there's no 6 anywhere in this cage. Oh, I guess I already knew there's no 6 anywhere in this cage. Whatever, we're going to take it and be happy with it. But because there's no 6 anywhere in this cage, that means the second digit from the bottom is a 2. And that's a 3. And so these digits are a 1, a 3, and a 4. And that one's not a 3. These two digits are, well, they're not 2 5s. So these two digits are a 1, a 3, a 4, and a 6. This one's not a 1 or a 3. In fact, that one's not a 1 either. So that's even better. That's a 4. That's a 6. These aren't 4. This is not a 4 or a 6. It's a 1 or a 3. So these two digits are actually the same. But I can place the last digit in this column, which is going to be a 4. So 1 now can only go here in this box just by sudoku. So 1 goes here, which means that's a 5 and that's a 1. Okay, so these two digits are a 2. Oh, but there's not a 2 in this cage because 2 is the second digit from the bottom, and I have a 1 now. So there's no 2 in this cage either, so the 2 goes there. So that's a 2, that's a 3, that's a 2. This digit now is known to be a 4. Let's see, and this needs the remaining none 2 digit. The remaining none 2 digit is a 5, so that's a 5. This is just a delightful little puzzle. I really like this. This is a 3. I would really like a 9x9 version of this. Not because I think that this puzzle is... not because I think this 6x6 isn't doing it justice, but just because I'm enjoying this logic, and I have not done it before, and I want to do more of it. So that's a 4 and a 6. These are a 1 and a 2 in some order. These are a 2 and a 5 in some order, and I know the order, in fact. So that's a 2, that's a 5, that's a 1, that's a 2. A 2. That 1 looks over and sees that that's a 3, which sees down that that's a 1 and that's a 3. And now I just need to finish this row. That's a 6, and that's a 1. Yeah, I would be happy to see more with this rule set. Yeah, I've done Sudoku puzzles before where I had cages where I circled the biggest digit. And so, like, I think one of my very first puzzles was killer cages where the highest digit is circled and cages can't have consecutive digits adjacent to each other. But I'd like to see more sort of riffing on this idea. Like the less math involved in killer puzzles, the better, is my general philosophy in terms of not like general goodness, but just in terms of my enjoyment. So I really like these sort of mathless takes on killer cages because killer cages set up really awesome geometry. Anyway, very, very cool puzzle. Okay, and now we go into this multicolor madness puzzle. I'm actually going to have to zoom out in order to fit all of this puzzle on the screen at once. Not that much necessarily. Okay, so let's get Zeta shrunk and moved. Move the Zeta. Zeta's going to hide out over here. This is by the Asylum, who I should know, but I don't. I think I've seen them around the Discord, I want to say. Okay, so now let's go read the rules of what is happening with the Asylum's puzzle. Okay. This is a multicolor Japanese sums. That's how I know the Asylum. The Asylum was the one who did the the Japanese sums pack with Panthera, right? Okay, so I think that's true, and if that's true, then I've definitely done some Asylum puzzles before. Hey, Panthera. The Asylum is the one who did the pack with you, right? I think that's true. Uh, Paint by Number Institute, was that what it was called? Uh, Interestingly, I thought that pack was even the easiest puzzle in that pack was way harder than the camel puzzle we did yesterday. Uh, let's see how this one goes. Okay, so is this just colored Japanese sums? Uh, Pink and gray are the two colors. Two runs of colors with the same color must be separated by at least one uncolored cell. Two runs of colored cells with different colors are not necessarily separated. Okay. All right. So the way this works, and I only know this because I've watched Ranks do a lot of these. I don't think I've done many colored or many multicolored Japanese sums. I have to color some things in gray and some things in purple and some things not colored at all. So we're going to do gray and purple, and then we're going to use green to say that something is not shaded at all. And then the sum of the shaded cells in that color is given in the row by this. So for example, in this row, I am told that there is there's a string of purple cells that sum to 1 that are shaded. So I can go ahead and say, I know where the 1 is. The 1 is here. It's shaded. And then I can go ahead and unshade the cells around it. Okay, so that is how that works. And so there's going to be some string of shaded cells here that sum to 5. And it will either be a single 5, or it will be a 2 and a 3. Those are the options. Okay. Now, if I go back to my shading and I look up, I need a string of purple cells that sum to 12. Even if I took this cell, I'd still need to shade this cell. And I can never shade 5 total cells in a row. So this cell is never going to be shaded. Likewise, if I look at column 1, did I do something wrong? Oh, sorry, no. The sadness is about what's happening in chat. I'm sorry there is sadness in chat, but I don't think I can do anything about it. This 8 is telling me I have a string that sums to 8 in pink, so this can't be shaded because of that. Okay. 16 is also a very big number. I need cells that sum to 16, and I can't do that without also shading this cell. And I can't even actually make all 3 of these cells sum to 16, because the maximum I could make 3 cells sum to is 15. So actually that's also shaded. So I'm getting some shading there going on. Now, the 8 could be in 3 cells or in 2 cells, because it could be either 1, 2, 5, or it could be 2, 6. But that's not immediately helpful. Okay, so let's look at this column. Oh, I could fill in the missing digits. Thank you. I don't know why. I don't know if everyone experiences this or it's literally just me, Clover, but somehow, as you see, I'm on the 53rd of these puzzles, and you think by the 53rd I would remember that I should fill in what the digits are over here, but I didn't. These are a 2 and a 5. Okay, so this digit can never be shaded because of that. So this is now green because it would need to be part of the 6 clue, and it can't be. So this purple cell is part of a 6 clue. Just makes it a little more exciting. Thank you for your very optimistic take on this. I appreciate the glass half full way of looking at the world. Okay. it's interesting that this being a 2 or a 5 is going to tell me which way the 5 in this row is composed. Let's see. If this cell were shaded purple, it would mean that this cell had to be a 6. No, it would mean that this cell had to be a 5, but that seems okay. Okay. And so, it does tell me that in this column there's a single 3. So there's either a single purple or sorry, even better. The 6 clue. The 6 clue has to be a single cell now. That's the point. Oops. Because this 2 and 5 break both ways of making 6 in 2 cells, which would be 2, 4, and 1, 5. And it can't be 1, 2, 3 either. So in fact, this cell is a 6. That's the point. Okay. Now, this cell now is either a gray 3 or it's green. But there is a gray 3 in this column somewhere, or perhaps a purple 3 in the column. Oh, is an unclued row just all green? Is that... Did I not read the rules carefully? Let's see. 2 runs because... 2 runs... Right. Okay, so this puzzle, black means both colors are used. And if there are no clues, okay, the last sentence, if there are no clues, that means they're all shaded or unshaded. Okay, reading the rules explains the rules, or something. So these are all unshaded because there's no clue. These are all unshaded because there's no clue. Thank you, chat. So now that means... Yes, Jay, that's true. However, black clues also mean that both colors show up. So because this was a purple 6, now it does mean there's a gray 3 in this row. Okay, now the 12 clue needs another cell because I can't put an 11 in this cell. In fact, actually, now these 2 cells can't sum to 11 because of this 6 here. So I actually need yet another cell here. And then I can do math to figure out what this cell is, because I need to get to 21 overall. So this is 12 plus 6 is 18, so this digit's a 3. To do that. I also missed it. The only reason I knew about it, Jay, is because chat told me. And then when chat told me, I was confused, so I went and read the rules again. Which is a common theme on this stream, that Zeta doesn't read rules good. 6 plus 8 plus 7, I should have clued into right away. That is 21, so every clue in this row is shaded. So I have to decide if this cell could possibly be a 6 gray on its own, and it can't be, because this cell can't be a 6. So this cell has to be purple. Is the punchline. Now, could I put 1, 2, 3 here? No. Wait, why not? Okay, sorry. If I tried to make my 6 out of 1, 2, 3 in the row, then I would need to make 8 and 7, but I'd need to make one of 8 and 7 in one cell, and I can't make either 8 or 7 in one cell. So this cell now is gray. I was trying to figure out how that worked. That seemed weird, but okay. Yeah, it breaks the 8 cell. I'm just confused as to how that works, but whatever. Okay, so I definitely agree with it. I'm just confused how it works out mathematically, because I'm used to it being the case. There we go. We'll go with the darker gray today. Okay, and so that's going to have to be at least 2, and so now the purple is going to have to go like that. And so we've now done this row's coloring. Okay, so now this column The bottom cell is a 3, so that means that this digit is a 1, 2, or a 3. I don't know which one. Actually, I know that this digit isn't a 2, because if this digit was a 2, it would put a 1 here, and there's already a 1 here. Now, this column, I know that the 3 is gray, or the gray is a 3, whatever way you want to say that. So this is a 3. So that's a 5 by maths, because it needs to add to 8. And I also know that this digit is green. Now, because this column's now done, I should fill in what these digits actually are. These digits are a 1 and a 4. I should fill in what these digits are actually as well. These are a 2, 4, and a 5. That one's not a 5. Let's see. This being a 2 or a 4 actually means this is also a 2 or 4. That's really, really clever, actually. So this sixth clue, now with that being a 2 or a 4, tells me that this is a 2-4 pair, in fact. So actually, that cell's a 5. That is super classy. Oh, also, other things. This 4 here tells me that this is a 2, and that's a 4. So that's a 2. I guess there were a million different ways of getting that, but whatever. I liked the way I did it. I thought it was cool. Hopefully these digits add to 7. They look like 1 and 6, which do in fact add to 7. So this digit's a 3. Now 5, 6, and 3 add to 14. So the last purple clue in this row is a 2. It can't go there. So this is a 2 and is purple. That's purple, and the rest of these cells are green. Now that means this cell has to be purple and be a 6 in order to make the column work. Let's see. Okay, so we're doing pretty well, I think. So this digit now is given. It's a 5. So this digit now is given. It's a 1. So this digit now is given. It's a 4. Now, if this were a 1, then this would have to be a 5, which I guess looks technically okay. Let's see. The bottom clue in this column was a 3. So that 3 is done. So that means that this cell is not shaded. Let's see. The bottom clue here is an 8. So this is probably going to end up being a 5 with that being a 1, but I don't think I know that yet. Oh, I need a gray 4 or a gray 1, 3 in this row. Don't think I know which yet. Okay, in this column, I needed to get to a 6 with a gray. So this is my gray. That's my gray. That's my gray. And this is a 1 in order to get to 6. So that's a 4, and that's a 1. So now I'm trying to get to 4. So this has to be a 3 and be gray. So now this digit's given. It's a 5. Yeah, this is the backpack on the camel, I'm pretty sure. I don't think there's anything else it could be. So go ahead and green that cell because that row's done. And now once this cell turns green, I now know that this cell's a 6 and this cell's a 1. I also know that this cell is green. So therefore this cell is purple and contains a 5 as predicted. And now we're done our coloring. So that's a 2 and that's a 5. And now we just get to do some Sudoku and figure out what the numbers that the camel is carrying are. Are you absolutely sure it's not a camel? Because I really think that this is the saddle on the back of the camel. It could also be some sort of hedgehog. Clover confirms it's a pig with wings. Wow, it actually even looks like a pig with wings. Canonically, it is now a pig with wings. I am sorry, the asylum, if that was not the intended one, but it definitely looks like a pig with wings. Okay, so these two cells, I have hedgehog riding a camel. I could go with hedgehog riding a camel. Uh, oh, the asylum is in chat. Oh, I'm sorry, the asylum. I would have said hi much sooner if I had realized that you were in chat. I realize now I've seen you in chat before, but welcome. And this is a very cute puzzle. Uh, uh, I mean, as soon as someone said pig with wings, it really does evoke pig with wings. Although I think I probably, if it was going to be a pig with wings, I think I probably should have used the other gray. I think I should have used that gray. I think that looks more pig with wings. Uh, oops. And then I went to the wrong mode. Uh, very cute. I liked this a lot, especially the thing with the 2-4 over here. It was really clever. Let's see. Uh-oh, we've got a spam bot in chat. Do I have a mod laying around? I don't know that I actually have any mods laying around. If I have any volunteers who want to become a mod so they can delete the link, or I can just delete the link for now. But if I have any... I hit remove. Why didn't it remove it? Oh, there we go. Okay, it was removed. Oh. Tristan did. I tried to remove it. I did not succeed, apparently. This column... A jackal. It's a jackal. Jackal. Yes, that. I need a 2 in this column, and I need a 4 in this column, and I don't know anything about either of them. I need a 4 in this column and a 6 in this column, and I know the 6 has to go there and the 4 has to go there. So now we're turning to this column. This column needs a 4, which has to go there, and a 2, which goes there. So that has to be a 1. That has to be a 2, and we are done. Is that Family Guy? It's Family Guy, isn't it? I think it's Family Guy. Okay. Excellent puzzle, the asylum. I really liked the I like the multicolor Japanese sums puzzles. I think my birthday puzzle was actually a multicolor Japanese sums puzzle that was really cool that Panthera and Tristan made for me. Okay, so now for the complicated part of the most complicated part of the entire thing. We now have to figure out how to transfer the digits from the asylum's puzzle into yes, the one you made, Panthera, into the next string of puzzles. And so that just involves figuring out, okay, if I look at this picture, the upper right of the asylum's puzzle is the lower left of Liz Tesch's puzzle. Okay. Upper right is lower left. Let's repeat. Upper right is 6235, is lower left over here. So 6235. Oh, that was in the wrong mode. One moment. We're going to redo that in the right mode. 6235. Okay. Did I do that correctly? 6235? 6235. Okay, I think I did that correctly. This is the part that scares me every time. Okay, so we're going to move myself over. And next up, we have a puzzle by Liz Tesch. And you get to see a gigantic... Oh, I don't need to have this so zoomed out anymore, because I now can zoom in again. So let me zoom in. You can have a bigger zeta, but you don't need to have that big of a zeta. Because I zoomed out, which is why suddenly there was so much room for a bigger zeta. Okay. So this puzzle is by regular channel attendee and featuree Liz Tesch. So let's read the rules to Liz Tesch's puzzle. I bet I know what they are, just based on how many Liz Tesch puzzles I've done on the channel. I have a guess, but we're going to read them just to be double sure. Liz Tesch is puzzle number 54. 2 diagonals in the grid are indicated by arrows. Note that the diagonals stop when they reach the edge and don't continue into the grid. The 2 diagonals contain 5 and 6 digits, respectively. The sum of the digits along the diagonals are the 2-digit numbers which appear in the cages in column 3 and row 6, read top to bottom or left to right. Which cages match is up to you to determine. Have you done Listesh's 9x9s with this rule set, Clover? I think those are very cool and a lot easier than you would think if you were told that they were Listesh puzzles. You should definitely. Listesh has a whole series of these, and I think you would love them. I think they're right in that like the sweet spot of being easier, but yeah, I recommend it. Okay, so I'm just highlighting these just so I know what I'm looking at. So these digits are a 1 and a 4. Okay, so now I've got to ask myself, okay, like what is the largest one of these could sum to? And so this could be like 5 plus 11 would be 16, plus 11 would be 27. So at least for this diagonal, the largest possible sum has a 2 in this cell. And for this diagonal, it would be 11 plus 6 is 17, plus 11 is 28. Right, okay, so these two digits, the moral of the story is, are always 1 or 2. And this one is not a 1, so it's a 2. And we have digits. Okay, well, we have a digit. Let's not get ahead of ourselves. Okay, so one of these digits sums to a 20-something number. Can this diagonal, now that this digit actually is a 2, can this diagonal possibly sum to a 20-something number? So this could be 11, 17, plus 7, be 24. Okay, yeah, so this could sum to 24, which would actually work really nicely. With that being that. I am noting the 3 is placed here by good old Sudoku. Let's see. So, yep, 3 in box 3 was very generous. It was very kindly given to us by Listesh. Okay, so I know one of these two digits is a 2. So this is either a 20-something number as well, or it's a 12. Okay. Those are the only two options. Let's see. I'm cautious about the possibility of them both being 20-something numbers, although I don't see any super easy way to prove that they can't both be 20-something numbers. Yeah, I doubt it, but I'm trying to figure out a convenient way to maximize the sum of both of them. So this could be a 6 plus 5 and 6. So I'm adding both of them together now. 6 plus 5 and 6 is 17. Plus 5 and 6 is 28. Plus double 2 is 32. Plus 2 is 34. Plus 6 is 40. Plus 3 is 43. Plus 6 would be 49 is the maximum sum of both. Hey, Grackles. I think I can get these as high as 49, albeit this one being a 6 would be tricky. But even if you make this smaller, that still gives you just enough space to make it work. Oh, that was making both of these a 6, and I can't make both of these a 6, so I can get slightly smaller. So I got to 49, but actually I need to take 1 off because this could be a 5. So that would be 48 if I made those a 5 and a 6. And maybe I can get a little lower, but I think the point is I'm not getting anywhere near low enough to rule out the possibility that these are both 20-something. Now, there's a really smart point, Jay. I can remove this last digit and just count it as a 0. And if I count this digit as a 0, then I can ask if I can get to I can just count this as 20, and then see, could I get to 41 without this digit being anything at all? Yeah, that's a smart way to think about this. Okay, so 6 plus 5 and 6 is 17, plus 5 and 6 is 28, plus double 2 is 32, plus 2 is 34, plus 5 is... Sorry, am I at 39? I forgot again. Okay, 6 plus 5 and 6 is 17, plus 5 and 6 is 28, plus double 2 is 32, plus 2 is 34, plus 5 is 39, plus 3 is 42. Okay, so if this is saying if this is a 20-something number, this has to be 21. I wasn't even looking at this number anymore, Garion. I excluded this number completely. So I think it just works. This can get there. But Purple Sidewalk, I may have been doubling 5s, but I need to lose a lot more degrees of freedom than that in order to get this done, because I got to 43. I need to lose 3 degrees of freedom to break the possibility that these are both 20-something. Hello?
Can you go to be right back?
1 second. I'll be right back. hello again. I think this is actually harder than the 9x9 list test puzzles with this same rule set. Uh, let's see. Okay, so people are talking about what the maximum is for this diagonal, which is 7 plus 11 plus 7 plus 11 is 18 plus 6 is 24. So the most this one could get to is 24. What's the most this one could get to? Let's see. The negative diagonal is max 23. So I think the moral is we're probably not supposed to be looking at maximizing these. We're probably supposed to be doing Sudoku or something. Let's see. Look at 6 in box 3. Yeah, the 6 in box 3 is definitely in one of these places. So this digit is at most 5. So let's see. Does that improve things any? That would be 11. That would be 18. Still 23 for that diagonal. Can this one... So this one can't get to 24 anymore. Can this one get to 24 ever? This would be at most 5. 6 would be 11. 13. Oh no, this can't... Okay, so this can't be a 5-6 pair. Because I need to put a 6 here in order to get this to 24. And this can't be a 6, because we just argued this one can't get to 26. So, in fact, actually, what we've argued is this has to be a 1. So this is a 21. Oh, row 6, column 6 could be 16. Yeah, you're right. Sorry. Sorry, we're not right. Yep, Jay is right. Let's see. Ranks is saying if it's 12, then the other cages... Oh, no, this can't be 16 because there's a 2 in it. And 16 does not have a 2 in it. So, yeah, I think I believe my argument that has to be, in fact, one of these diagonals has to sum to 21. Because 24 is too high. Now, I would really bet on it being 21 and 12, but I can't quite figure it out. Let's see. Yeah. So have you considered that if the cage isn't 20-something, then it has to be 12? Yeah. So we have contemplated that this has to be either 12 or 20-something. So maybe here's the point. If this is 20-something, what's the something? So what if this was 21? Yeah, okay. So is 6 placed in the row? Is it true that I can't place 6? Is it true that I can't place 6 here? Yeah, is it true I can't get to 26? Have we proven that enough? Okay, this is 7, and 5. 7 and 5 is 12, and 11 is 23. Generously, this would be 13, and 12 is 25. Yeah, I can never get to 26, even without any real additional option. So this is always a 6. So the 6 over here is in one of these two cells, for what it's worth. Uh, yeah, it's 12. Yeah, so this is always 12 or 21. That's really cute the way this works out. I enjoy this. So now what's the absolute max of this diagonal? Uh, hey, Listesh. Uh, I think you actually made your 6x6 version of this puzzle the hardest of these. I don't know if you agree with that assessment, but I have found this one much harder to conceptualize than the others. Let's see. So this would be 4, say. 5 would be 9. 6 would be 15. 5 would be 20. This diagonal now sums to at most 20. And because this diagonal sums to at most 20, that means it can't actually sum to 20. So actually, the mystery number is a 12. Gloriously. So that is a 12. Yeah, maybe it just feels harder because I went into your other puzzles like this assuming they would be very difficult, and then they were easier than I expected. So then I remembered that and assumed this would be easier, and then it's now harder than I expected. It's possible it is purely my my expectations. I think yours was definitely in the upper quartile. Maybe the upper decile, but I doubt it was. I doubt yours was in the top 5 for difficulty. So yeah, so this one now has to be 12 because we said it can't get up to 20. So this is 12. This one's 21. So that means I need these 3 digits to add to 21 minus 7, which is 14. So these 3 digits add to 14, whatever that tells us. These digits add to 8. So let's see. So this can't possibly be a 6. Yeah, this can't possibly be a 6 anymore because I need these 3 digits to add to 8. And if this were a 6, I'd need these to be double 1, and they can't be. So that's not a 6. Carl notices exactly as I am pointing this out, I see. So that's the 6. Let's see. We can start aggressively good-lifting things per Rank's suggestion. So 1, 2, 3, 4, 5 go in there. This is a 4 or 5 just by Sudoku. Let's see. This is a... Oh, it's probably not a 1. So this is at most 5. So these two need to sum to at least 9. So if they need to sum to at least 9... I can't have either of them be 1. So these can't be 1 or 2. I know they couldn't be 2 already by Sudoku, but don't ruin my party. They can't be 1 or 2. And they could be 3 and 6 in that order. So these are from 3, 4, 5, 6. That one's not 3. That one's not 6. But that doesn't immediately help. Yeah, I'm trying to make these numbers sum to 14. I agree with that assessment, Nicholas. And I'm trying to make these numbers add to 8. This can't be a 5 either, because if this is a 5, I need these to add to 3, and this one can actually neither be 1 nor 2. This is actually 3, 4, 5 as a cell. So this can't be a 5. Could it be a 4? This could be a 4 exactly if that cell's a 1. Except if this is a 4, this cell can't be a 1. So actually this cell has to be a 1. That's really clever. So let me go over that real quick. So I need these to add to 8. If this was a 4, how am I adding to 8? Well, that would have to be a 3, and that would have to be a 1. Except if I make this a 4, I put the 1 in one of those 2 cells, so that can't be a 1. So in fact, this digit is a 1. These aren't 1. So these are a 1-2 pair. That is very cool. Okay, so now I know these add to 5. So in order to get to 12, I need these to add to 7. So it is either 5 and 2 or nothing else. So it has to be 5 and 2. So that's a 4. I now need these to add to 10, so they have to be 4 and 6, and I know the order. That was very cool. The 1's now placed over here. It has to be Sudoku now because there's nothing else in the puzzle. That was very cool. Let's see. That's a 5. That's a 3. That's a 6. Let's see. I need a 1 in this box. It has to go here. That's a 5. It's a 3. It's a 4. Uh-oh, what did I do? Wrong digit in box 2. Oh, no. Oh, I typed 3 and then it covered it with a 2, didn't it? Okay, because I then somehow typed over it. Whatever. So that is a 3, yes. So still, that's a 6. Okay, I still need a 1 in this box. I think I just hit 2 keys and it wrote over the key that I meant it to be. That's a 5. That's a 3. That's a 4. Let's see. I need a 4 in these cells. It has to go there. That needs to be a 5. It needs to be a 6. It needs to be a 3. Very nice puzzle, Listesh. A worthy contributor to the series, actually. This one definitely had a lot of teeth to it. But in a very nice way. Like, nothing was out of bounds or anything, like especially being in a 6x6. And I think this is another instance of it being a 6x6 makes accessing slightly harder logic more fair because there's only so many places to look. Like in this case, it was literally about 2 lines, so you got to really press those 2 lines for all it was worth. Very nice puzzle. Your first 6x6. Oh, cool. Well, hopefully you'll make more 6x6s in the future. Because I think if we all learn nothing else from this experience, it should be that 6x6s are awesome. Okay, Pietato. We have some arrows, but not that kind of arrow. So this is puzzle number 55. Coordinate some arrows. The digits on each arrow represent a coordinate in the grid. For instance, an arrow with a 2 on its line and a 1 on its tip refers to row 2, column 1. The value at that coordinate must be the sum of the 2 digits on the arrow. In this example, row 2, column 1 would be a 3 because 2 plus 1 equals 3. Additionally, all arrows must refer to different coordinates within the grid. Okay. So let's start by filling in these digits while I'm thinking about it. Did I successfully reorient my screen? Yep, looks like it. I can block the digits for you a little bit better. And it is collaboration in a technical sense. Clover did all the hard work, I feel like, for this thing. But it's really awesome that so many people, when Clover asked them to, said, yeah, sure, I'll do that. So one thing I'm noticing is that these things have to sum to a digit that's at most 6. And they can't use a 1. So these are only from 2, 3, 4. Now this arrow actually, because they have to sum to a digit that's at most 6, I have to use a 1 on this arrow. I don't know any such thing about this arrow. Okay, so it's row then column, right? So if it were So 2, 4. Ah, okay, I see the point. So imagine there's not a 3 on this arrow. Then it's a 2 and a 4, which would place a 6 in one of these two cells. However, conveniently, because of the given, and again, this is just Pietato using the givens in a very, like, this is almost showing off how cute this way of using the given is. Neither of those could be 6. So this needs to have a 3. And so it's a 2, 3 in some order. And so one of these two cells is a 5, is what this is saying. And which is a 5 will tell us the order of this 2 and this 3. Okay. Now this is 1 with 3, 4, or 5. If it were 1 with 3, it would be referring to one of these two cells and saying that one of those two cells is a 4. Again, this feels magical to me. Neither of those is possible because of the given 4. So, not a 3 here. If this were a 1 with a 4, it would be saying one of these two cells is a 5. That's plausible. And if this were a 1 with a 5, it would be saying one of these two cells is a 6. And that's also plausible. Okay, so this is all... this is all on the up and up so far. I'm noticing that by Sudoku, one of these two cells has to be a 2. I've got this 2, 3 here. I do know that one of these two cells has to be a 2. Do I learn something from the fact that one of these two cells is a 5 that I should be appreciating that I'm not appreciating? I don't think so. Yeah, the arrows in box 4 I only haven't pencil marked because I think it can be anything. Like, it has to have a 1 or a 2 on it, but there are lots of options for combinations that have 1 or 2 on them, or both. So I think this is only going to get resolved by the fact that I can't repeat whatever I've used over here. Oh, no, this can't have a 2 on it. Right, this can't have a 2 on it, because if it had a 2 on it, what's it going to be? Well, it's going to have to be 2, 3, or 2, 4, but we already established I can't have an arrow with 2, 4. So actually, this arrow has a 1 and no 2. So this is a 1, and so this is a 1, 4, 5, just like this arrow. So we actually get a triple. And so, yeah. Oh, no, it could be 1, 2. Darn it, you're right. Sorry, I got overexcited. It could be 1, 2, because 1, 2 could put a 3 right there. Never mind. But if this does have a 2 on it, it needs to have a 1 on it. So the correct conclusion is this always has a 1 on it, because if it has a 2, it needs to have a 1. And so there's always a 1, so this isn't a 1. And so this is a 1. And so this is referring to column 1, row 4 or 5, and saying that either this digit is a 5 or this digit's a 6. Okay. Oh, actually, it's also possible. No, I don't think that was right. I think I was wrong. Because I think these could be 2, 3, but in opposite directions. Oh, no, they can't be 2, 3, but in opposite directions. I didn't justify it, but if they were 2, 3 in opposite directions, these two digits would be the same digit. So that wouldn't work. So actually, this is harder to justify than I made it out to be, but I do think this arrow needs to have a 1 on it. So this is not a 1, not a 1. This is a 1. And this is now referring to one of these two cells. So we'll go ahead and we'll... I'm going to unyellow that cell, and I'm going to highlight those two cells. Those two cells, one of those is getting targeted by this arrow. One of these two cells is getting targeted by this arrow, and is in fact going to be a 5. This arrow, who knows, could be anything, as far as I am able to determine. Let's see. I can go ahead and fill in. What's left in this column is a 4 and a 6. That did not seem to help immediately. And I can say things like, I know the 6 in this column is in one of these two places. I don't know that that does me any good, but... what's wrong if this is 1, 4? Ah, right. Okay, that's right. Okay, so Nicholas has a good point. This can't be 1, 4 for a really complicated reason. Which is that if this was 1, 4, it would put a 5 here, and now we've broken this cell. Okay, so this can be 1, 2. Could it be 1, 3? If it were 1, 3 in some order, that would not work. So it can't be 1, 3, and it can't be 2, 3. We already said. Can it be 1, 4? No. And so it's either 1, 2 or it's 1, 5. And let's see, if it's 1, 5, does that do anything interesting? If it's 1, 5, then it puts a 6 in one of these two cells, so that is also fine, I think. Could it be 4, 1? Oh, maybe you're right. I bet it could be 4, 1, because if this is 4, 1, then we would place we'd place a 5 here. And then this would be a 5, but that would be okay, because then this would be placing a 6 there. Okay. I think it is not possible to brute force all of the options for this arrow, because Carl is completely right. We missed one there. It is true it can't have a 3 on it, though. So we do know the 3 in the column is in one of these two cells, but I don't really want to pencil mark that. See, Ambrose says it's a bit gnarly to show, but there is a 4 in either row 5, column 4, or row 5, column 6, by considering the options in row 5, column 4. Okay, so if this is a 4, then of course there's a 4 in one of these two cells. If this is a 5, then this is a 5, 1, putting a 6 here. Which eliminates 4 from this cell. That's really clever, actually. Which then says that the 4 in the row has to go here. Okay, I buy that. So one of these two cells is a 4. Which means one of these two cells is a 4. Uh, of course, the question is then, does that bias anything? Well, I can write out what digits these cells can be. They can't be 1, 2, or 4, but they could be 3, 5, or 6. Let's see. Afraid Not says either row 5, column 4 is a 4, or row 3, column 3 is a 4. Eliminating 4 from row 3, column 4. Oh god, am I pencil marking row 3, column 4? I thought we had abandoned that, but maybe we have not yet abandoned that. Okay, so let's try and argue that this does not work. Okay, so what have we already argued? We've already argued that this arrow can't have a 3 on it, because then it would be 1, 3, and it would correspond to putting a 4 in one of those places. So there's no 3 in either place. We've argued it can't be 4, 1. No, sorry. We've argued it can't be 1, 4, because if it was 1, 4, then it would place a 5 here and break this cell. So that's not a 4. Sorry, so that's not a 4. Now, Afraid Not's argument is going to let us say that this can't be a 4, because Afraid Not's point, and I admit that this is incredibly complicated, is that either this cell is a 4, in which case this cell isn't a 4, or this cell's a 4, in which case this cell is a 6. Sorry, either this or this cell's a 5, in which case this cell's a 6. In which case... No. I lost it. This cell's a 5, which makes this cell a 6. No. This cell's a 5, makes this cell a 6. There we go. Which makes this a 4, which makes this a 6. I think it's backwards. I think Afraid Not is backwards. But I could be wrong. But I think this being a 6 makes this a 4, makes this a 6, which does not then mean this can't be a 4. Let's look at it the other direction. If this cell is a 4, then that means this is a 6, that's a 4, that's a 5, and that's a 6, which all seems fine. Unfortunately, I really liked the point until it didn't work. I was convinced it was going to, but it did not quite. I know there's a 1 up in one of these two cells. We can mark that just recreationally. Yeah, I am not a good visualize multiple steps ahead puzzle solver. That is not my strength, I admit. And, like, there's nothing that knowing one of these two cells is a 5 tells me. I don't believe. Yeah, so this being a 4 would make... This is the confusing thing. This being a 4 would make this cell a 5, or this being a 5 would make this cell a 6. That way madness lies. I agree, Ambrose, but also when we're trying to get through 80 puzzles, I'm more willing to say, okay, I accept this than I normally would be. I'm not encouraging full madness, but I mean, it does feel like this puzzle is asking us to appreciate something that I'm not appreciating about the relationship between this cluster of cells. Okay. Um, okay, should I ask what this cell can be? This cell can be... Can't be a 1. Could be a 2. Oops. Can't be a 3 or a 4. Sorry, could be a 2. Can't be a 3 or 4. Could be a 5 or a 6. That's a lot. Okay. Trying to figure out if this is a 4. Is there any chance that is going to break this? Oh, no, it's not true. I was going to say there has to be a 4 or a 5 in here, but that's not even true. This could still be a 1-2 pair. Pointing at this 3. Or are we saying this is a 3 or this is always a 3 or a 6? Let's see. So it's not a 1, it's not a 2. Could be a 3, it's not a 4. Could be a 5. And it could definitely be a 6. Let's see. Row 3, column 4 cannot be a 2. Ah, right. Because if this were a 2, then I'd need to combine it with 2, 1. And that would end up looking at this cell. That's the wrong cell. So that's not a 2. Ah, this can't be a 5. That's a good point. Because if this were a 5, then that's saying that this is a 4, which is saying this is a 5. So that's not right. So this is only a 3 or a 6. I had not appreciated that. But good point, Garion. So yeah, 2 in this column actually only goes in one of these two places for whatever it's worth. Oh, the thermophilamino came out? I've always wanted to find cool variants. Filamino seems ripe for combining with other Sudoku variants. See, if this is a 1-2, you say we can't place a 2 in box 3. I would be happy to find that. Okay, if this is a... Wait. If this is a 1-2, then we've of course ruled 2 out of all of these cells. So this cell would have to be a 2. But with this being a 2, we've made this a 3 and that a 2. So if this is a 2, then we place a 5 here, which then eliminates 2 from the entire box. That is really clever and very smart. Great spot to Carl on that one. Oh, sorry, that's not supposed to be a 2. So through the medium of this arrow, if this is a 2, it places a 5 here and then rules 2 out from the entire box. Good spot. Okay, so now there is a virtual 4-5 pair in column 4. So this is never a 5. That's never a 5. Because this definitely now involves a 4 or a 5. This is a 2, 3, or a 6, and it's not a 2 or a 6. So this is now a 3, thanks to our triple. This is now a 3, thanks to our triple. And it's even the right kind of 3. Welcome, Logan. You have come just as we are placing a digit into the grid, which is a delightful feeling after a bit. And that now resolves that down here that's a 6 and that's a 2. But why would you use real triples when you could use virtual triples or virtual pairs? So this is a 3, a 4, or a 5. One of those options assuredly does not work, right? Maybe it does. Have a good day, Playmaker. The 6 looks left. The 6 does look left. So that's a 4 and that's a 6. So these are a 1, 3, 5. That one's not a 3. I know one of these is a 2. The 3 in the row is in all kinds of places. Oh yeah, the 4 is in one of those 2 places. The 5 is in... Can this digit be a 5? Does something break if this digit's a 5? If this digit's a 5, then that digit's a 5. And so then that digit had better be a 5. Oh, let's do this the easier way. 6 in box 5 needs to go here. Thank you, Leo. And Nicholas. Unfortunately, that still doesn't tell me what digit this is, but it at least makes life better in some regards. It tells me this could be a 5 without breaking the puzzle. Oh, this digit can never be a 5. If this digit is a 5, it makes this a 4 and puts a 5 here. That's huge. Okay. This digit is the key. This digit being a 5 places a 5 there. And that's not going to work. So this digit's a 1. No, not both of them. Only this digit's a 1. So that's not a 1. So this arrow is going to get the color blue. And so it is referring to column 1. Oh, I guess it's referring to column 1 and one of these 2, but I can't do the double coloring. So we're just going to try and remember that it's referring to one of these 2 cells. And this is a pair. Gorgeous. Okay. So regardless of which of these is the 4 and which of these is the 5, this cell is referred to. And so, in fact, yeah, okay, the point is, I was not really carrying this out correctly. These 2 arrows always refer to these 2 cells, and so this is always a 5. That's super cute. And so this is not a 5. This is a 1 or a 3. A 1 or a 3. That's super cool. I really like that setup. That is very nice. So now this isn't a 5, and because this isn't a 5, green can no longer index this cell. So now green has to be a 2 and a 3, indexing a 5 there. So now that's a 1. Now the 1 is placed in this box over here. Okay, so now this cell is a 4. These 2 are a 5 and a 6 in some order. I don't know what order. This is the 3 just by Sudoku over here. So that's a 1. That's a 5. That's a 2. That's a 3. So that's a 4-5 pair. Now that 3 places a 3 in box 2, which places the 6. No, there's already a 3 in box 2. Don't listen to me. 3 in box 3 we got. Let's see. What are these digits? These digits... Well, I need a 1, so that's a 1. That's a 4. Yeah, it's no longer possible to mess up the arrows. which is appreciated. Okay, so I need a 3 in this row. It can only go there. So that's the 6. I need a 5 and a 6 in this column. So that's the 5 and that's the 6, which is also, that's the 4 and that's the 5. So now that's a 5, that's a 4, and that's a 2. That was really nice. Very difficult. I'm very glad that this was not a 9 by 9, because I think if this were a 9 by 9 and I had to appreciate this connection, I would never have. Even at a 6 by 6, this was a really difficult puzzle to sort of appreciate the connections. But 6 by 6, I think, was the right size to set this up so that you got this sort of intricate interaction between these. Yes, very, very nice puzzle. Very tricky, but very nice. Okay, next we have a puzzle by Mitchell Lee. So Mitchell Lee is, you may know, as the setter of the original Miracle Sudoku, which I think made Cracking the Cryptic famous. So there is a reasonable chance that if you are here because Mitchell Lee set a puzzle that then made a Simon Solve video go viral, which then resulted in us discovering this hobby. Not true for everyone, but I think for a lot of people, that is how things happened. So this is cool to see. Okay, so these cells are a 5, 6, just to start out. So this thermo starts with a 5 or a 6. That's not super helpful. So there are a 2 and a 3 over here in this collection of things, and the 2 can't be here. So the 2 is, sorry, the 2 can't be here. I said that wrong. The 2 can't be there because there's nothing lower than 2. In fact, let me just fill these in rather than trying to corner mark this. Oh, maybe I don't want to do that. Yeah, one of these 2 is a 6. Yeah, so there is a 2 and a 3 up here. And a 5 or a 6. Oh, that's a good question. Where does 1 go in column 3? Let's look for the easy wins. 1 in column 3 needs to go there, which means that one of these 2 is a 1. Neither of these can be a 6, so neither of these can be a 5 or a 6, which means that this is a 5, 6 hidden pair, actually. Okay, so let me say that again, but I think it's right. So neither of these 2 can be a 6 because of the 5, 6 pair in the column. So neither of these 2 can be a 5 or a 6, so we get a 5, 6 hidden pair, which actually places the 1 like that, and gives us actually a digit here. This is actually a 2. So we have to make sure we put a digit that's bigger than 2 in this cell, which is not going to be that hard, I suspect. Now we need another 5, 6 in this box that has to go in one of these 2 places, and it can't go there, because if I put a 5 or a 6 here, I need a 7 here. So this is a 5 or a 6. This is a very classy puzzle so far. Now I have a 5, 6 hidden pair over here, because if I put a 5, 6 here, I would need a 5 or 6 here, and I can't have one. So there's a 5, 6 hidden pair over here. Right, okay. So now 1 is just placed in this box. I don't even have to think about it. That's a 1. So now 1 in this box has to go in one of these 2 cells. No, 1 in this box now has to go here because it can't go there. So that's a 1. So 1 is now going, in fact, exactly in this spot. That's the last 1. So these are a 3, 4. Uh, these are a 2, 3, 4. These are a 2, 3, 4. Now, this can't be the 2 because there's not something to be lower than it. This can't be the 4 because there's not something to be higher than it. Where is 6, Barbie asks in column 4. 6 in column 4 is now placed here, because if I try and put a 6 here, it's not going to work. So that's a 6, that's a 5, that's a 6, that's a 5. You'd think that they would be able to solve the technical issue of people falling 30, 45 seconds behind. It does not seem like, relative to the technical problems that have been solved by humanity, that does not seem like that should be a particularly difficult one. But it is. So now I can ask where 4 goes in row 2, and row 2's 4 can only go here because there's nothing lower than a 4 left to give. So that's a 5 or a 6. That's not a 4. And so now the 4 has to go here by whichever method you want. So we have that. Nicholas points out we now have a 6 in box 5, just waiting for us to see it. So this is a 3 or a 4. No. So, oh, yeah. Now, this cell can't be a 4, so it's a 2 or a 3, just for the row. And so the 4 in this row is in one of these 2 cells. So this cell's not a 4. It's a 2 or a 3. 4 is just placed in box 6 just by Sudoku and nothing else. This is a 4. So this cell is a 2 or a 3, which gives us a 2-3 pair in the column, which gives us that this cell is a 5. So that's a 6, and that's a 5, and that's a 6. And that's a 5, and that's a 6. That's gorgeous. I mean, no big surprise, but this puzzle's great. Let's see. I can probably figure out what order these 2 go in, because these are a 2 and a 3. So that's the 2, that's the 3, that's the 3. That's the 2, that's the 3. That 3 looks over and says that's a 4, and that's a 2. That 3 looks up and says that's a 4, and that's a 3. That 2 looks up and says that's a 3, and that's a 2. And 1, 2, 3, 4, 5. Sweet. How do you set something like this? This is just a gorgeous little puzzle that just has all of this sort of bouncing around going on in it. It's very neat. You know, I've basically never set with thermos. I think Wreath might be my only puzzle with thermos. Oh, ambiguity. I guess my original ambiguity puzzle had thermos, but I've not. But I love solving stuff with thermos. I should find some way to incorporate thermos more in my setting. That was super fun. I highly doubt that of all people, Mitchell will ever watch this, but if he does, great puzzle. I really loved the opening with the fact that there was this 5-6 pair here that gave us a hidden 5-6 pair over here. I really like hidden pairs and hidden triples when they're sort of like well advertised. I think it's a cool mechanic to find, and so it's neat finding. And this is another thing where I think it's a lot easier to see hidden pairs in 6x6s because there's less grid. Yeah, Brian reading out the time like a couple times a minute, like say 4 times a minute. I think that would be pretty good. As long as you stopped talking whenever Brian was reading the time, I think it would be fine. You could just pause. Uh, all right. Next up, we have a puzzle by F Jam, who I think I've seen around the Discord, but I do not. I cannot say I know F Jam's puzzles very well. But it's a between lines puzzle, so I'm always happy to see a between lines puzzle because between lines are cool. Uh, Now, note there are colors here, but because this is in a black border, and this is another genius thing that Clover did, by the way. I can't stop gushing about how many smart things that were done here, but it is so solver friendly to have this black box tell you, yes, everything is what you think it is. Don't think about it. Uh, so that I know that these are between lines, and they're just colored between lines to make sure I can differentiate between the red ones and the blue ones. Um, and by the way, if you are a setter out there and you are attempting to set puzzles where arrows or between lines or whatever cross each other, using color like this is a great way to make that happen in a way that still looks good as long as you're careful about how you use the color. So I think this is a very attractive looking grid, even though I quite often, and in fact, if you watch, I think there's a VOD going up not too far from now on this channel of Ranksk and Jessica and I setting a puzzle, and a lot of the time was spent talking about how you should absolutely never ever have clues cross each other before we put clues crossing each other in the puzzle. But if you're gonna do something with color like this, that actually makes it work, in my opinion. Yeah, unless of course you're doing it in F puzzles, in which case you can't use color. But alas, F puzzles is designed to emphasize utility above all else, which is great and has lots of bonuses. Penpa is designed uh, to emphasize looks above all else and making things look good, and that has lots of bonuses and drawbacks as well. And I think you can understand the bonuses and drawbacks of both Penpa and F puzzles very well by understanding the focuses of each from that point of view. Okay, so this digit needs to be a 1, because if I try and make this digit higher than the 4, it's not going to work. Because I need to have 2 whole digits between 4 and whatever the other digit is, and the only way that's going to work is if this is a 1. So this is a 2-3 pair, and that's a 2-3. So these 2 digits are a 4-5. Let's see. See, I really like Penpa. There are just some things in Penpa that Penpa does not do very nicely for me. But I love that Penpa lets you set things that are so attractive looking. Yeah, I certainly did not say this with the intention of turning this into a everybody hates Penpa thing. Like, I think Penpa really does emphasize aesthetics, and I think aesthetics are really important. I will admit that solving Penpa on stream is tricky at times because of the scrolling, although I think I've done reasonably well with making this a coherent viewing experience. You can correct me if I'm wrong, but I was very afraid of doing 80 consecutive puzzles in Penpa, but I think it's actually worked out okay. The lack of multicolor is unideal, but also I think it's unfair to credit F puzzles with having multicolor, as F puzzles definitely does not have multicolor unless you have a ranks put it in for you. So these digits are a 1, 2, 3, 4, 5, 6. This is not a 1. So this is a 4, 5, or a 6. Let's see. Yeah, the CTC app having multicolor is very cool. the blue line in box 1 is resolved. It has to be a 2-3 between a 1 and a 4. Oh, right, because this is actually a 1-6 hidden pair. I can't put 1 or 6 on the between line, so this is a 1 or a 6. So now this is a 2 or a 3. And so the question is, how do I make this work? I notice, for example, that there's already a 1 in this column, so that's a 6, that's a 1, and now this has to be a 2, and that has to be a 3, and that has to be a 2, and that has to be a 3. Maybe not my best work to not see that, but whatever. I'll give myself credit today. For what, I don't know. This is not a 6 anymore. So now there's a 2-3 down here. That's not a 1. Okay, the 6 in this box is definitely in one of these two cells. So the 6 in this box is definitely in one of these two cells. The 1 in this box is definitely in one of those two cells, for whatever it's worth. You were confused by how I resolved that 2-3 pair, and then you remembered that 2 is in fact between 1 and 3, but 3 is not between 1 and 2. Yeah, I get that. I totally get that. Oh, yeah, okay, so what is the... Yeah, so this is a good question that I should have asked and didn't. What is the minimum this could be? 4 is the minimum this digit could be, so this is a 4, 5, or a 6. It's minimum 4 because at minimum these two cells would be 2 and 3, which would then require this be at least a 4. And then that gives me a 4, 5, 6 triple in column 2, as is being pointed out by a few people in chat. So that makes that cell a 2 or a 3, which makes this a 4, 5, or a 6. And now that's very interesting, because as soon as this is a 4, 5, or a 6, this can't be a 4 anymore. In fact, this is never a 6. But this can no longer be a 4, because if this were a 4, I could not put a 5 or a 6 on this line anymore. So now, actually, we get this, like that. One of these two is the 6. Should I color these 2 3s? I kind of want to color these 2 3s. Is that ridiculous? Maybe that's ridiculous. Yeah, it might be ridiculous. Right. So, good point from Afraid Not, that we have a locked candidate of the 4 here. The 4 in this box has to go in one of those two cells. So neither of those can be 4. Find the XYZ wing. This looks suspicious. What can go in row 5, column 4? Asks Nicholas. Good point. Not 1, 2, or 3, so it can only be 4 or 5. Yeah, that was a good spot, that this was being looked at by a million different things. Oh, and these two are the same digit. Yeah, these two have to be the same digit, because this can't repeat anywhere else, so these two are the same. I agree it's the kind of thing that sounds nice but is unlikely to be helpful. Okay, so what can this be? It can't be 1, it can't be 2. It could be 3 or 4. It can't be 5, and it can't be 6. So this cell's actually only from 3 or 4. Um, now, uh, Penpal lets you select multiple cells at once. So yeah, one of these digits has to be larger than 3, 4, and one of them has to be smaller than 3, 4. So if this were a 3, one of these two would have to be a 2. If this were a 4, one of these two would have to be a 6. In fact, it would be that one. Okay, so let's see. So Garion says this is either a 5 or a 6, and both options force this cell to be a 6. So let's see this. So if this is a 6, it definitely forces this to be a 6. If this is a 5, it makes both of those 4. No, if this is a 5, it places a 6 there, which makes that a 6. Did I misread it? I think I misread Garion's point. Oh, but it has now been deleted. It sounded good. Let's see. If this is a 5, then does that break? So then these are both 4. And so that's a 4, because it's now become the only place to put a 4 in this box. I don't see... I like the idea of thinking about what happens if this is a 5. Well, if this is a 5, then that cell becomes a 5. So then this cell becomes a 2 or 3. Am I supposed to be high-low coloring this? I don't know. Okay. Just write in candidates for this column, as silly as that seems. So they are 2, 3, 4, 6. This one is never a 6. Row 5, column 6 can never be a 3. Yeah, if this were a 3, then this would be 2 or 4, and that's not going to work. Agree. So this is 2, 4, or 6. So if this is a 4, then it goes 4, 3, 2. If this is a 3, then it goes 3, 4, 6. And if this is a 2, then it could go 2, 3, 4, or 2, 3, 6, or 2, 4, 6, whichever of those you want. It's between lines SPQ, yes. Okay, let's see. Logan is saying if both of these are 4, that causes a problem somewhere. Let's read this carefully. So, if these are both 4, then one of the blue bulbs is 6. Hey, Ishoots. These are both 4. I'm guessing you're saying if these are both 4, then this is 6, right? Let's see. Row 3, column 6 is not a 4, says Carl. Because row 4, column 1 is equal to row 5, column 2. Agree. And that would break the line in column 6. Okay, so let me color and say this. Okay, so and make those purple. Those are the same digit. Where is that digit going in column 6, I think is what Carl is saying. And so that digit in column 6 has to go either here or here. If this is a 4, then it goes there. And so then this would be a 4. So this would be a 3. But this could not be the purple digit. So the 2, 3 would have to go there, and this would be a 6, and we'd be putting a 3 between a 4 and a 6, which does not work. That is a great spot, Carl. Very, very nice. Okay, so this is not a 4. That is a 2 or a 3. And it's purple. We can go ahead and add, because this 2, 3 is the other one. This is the orange one. That's the orange one. I've really just been wanting to color these. I should have done it, but I was too much of a coward to color the 2 3s, but it turns out it would have been useful. Okay, so now purple 2 3 in row 6 has to be here. There's nowhere else for purple 2 3 to go. Oops, wrong color. Right? We agree with that? Can't be there because there's a 2 and a 3 looking at it. Can't be there because there's a purple in the column. Which means that that's the 1. That's not a 1. This is a 2 or a 3, recall. This is not a 2 or a 3 because it's now, it sees both 2 3s. Or we have a 2 3 pair in the row, or whatever form of recreation you want to decolor that. So now, of course, what we'd like to show is that orange actually shows up on this line. Or something, or that line, or something like that. But no idea how we're supposed to do that. Well, I guess I know one of these two is orange. Oh, wait. I know one of those two is orange. That's huge. Okay. Where does orange go in column 6? Well, the only places just by Sudoku it can possibly go are here. I can't possibly put orange here, because if I put orange here, then I've now made the opposite ends of a between line consecutive. So the point is, orange has to go here, which is now going to resolve everything. Because now, this is a 2 or a 3, so it's a 3. That's a 2, that's a 3, that's a 2, that's a 2, that's a 2, that's a 3. This is, of course, not a 2 anymore. This is a 4, 6 pair, which makes that a 5. And as soon as this is a 5, that makes that a 6, because I need to accommodate the between line. So that's a 4 and that's a 6. That that 4 looks over here and says that's a 5, that's a 4. Beautiful, beautiful setting with the coloring. I even talked about coloring, and then for some reason today I'm resisting coloring, and I could have gotten there sooner. But yeah, that was really cool. The looking at where orange went in the column, that chef's kiss, awesome. Really nice setting in this puzzle. So we need a 1 in this column. It can only go here. So there needs to be a 5 that needs to go there. This row now needs a 5, or sorry, this box needs a 5, which can only now go there thanks to Sudoku. So that's a 4, that's a 5. So this is neither a 5 nor a 6, so it's a 4. This is not 5 or 1, so it's a 6. That's a 1. That's a 4, and that's a 6. Really nice puzzle, FJam. The appreciating, the coloring the 2 3s was really interesting and led to sort of a deduction that I'd not really appreciated before about where the orange and purple could go relative to each other in this column. That was neat. Okay, so next up, we have this puzzle by Garford. I have to look at the rules for this one. So this is puzzle 58. We are chugging through these now. 58. Remainder arrows. For each arrow outside the grid, let x be the sum of all the digits along the path indicated by that arrow. For instance, the arrow next to row 1 points to the diagonal running from these. Let y be the value in the cell immediately pointed to by the arrow. The value next to the arrow is the remainder when x is divided by y. Okay. So when I look at this, this is telling me, for example, this diagonal, if I sum these 5 cells, it's telling me the sum here is divisible by this number. Okay, now here's a gimme. This row's sum is divisible by, is 1 more. Oh, sorry, this is not quite a gimme, but this is saying the row's sum is 1 mod this digit. So what numbers is 1? What numbers is 21 1 mod? And so the answer is it's the divisors of 20. 2 and 4 are both divisors of 20 that we can't use. And so the only divisor of 20 we actually can use is 5, which places a 5 there and a 1 there. Okay, so these digits are a 3 and a 6. Just to confirm, neither 3 nor 6 would work here because 21 is not 1 mod 3 or mod 6. These digits are 1, 2, 4, just for the record. Okay. This number, now this sum needs to be 1 mod 5. The only way for this sum to be 1 mod 5 is for that to be a 1. By the way, you can just ignore the first number when you're looking at the sum if you want, because the first number is, of course, 0 mod itself. Okay, so we've got that there. Okay. These 4 numbers, so I'm just saying 0 mod 5, but... the remainder upon dividing by 1... Excuse me. The remainder upon dividing by 1 is 0, not 1, is the way that they got around this. So I shorthanded the rules as they were written to talking about mods, but they were framed in terms of remainder. So you're completely correct. 21 is 1 mod 1, but it's not the remainder. So yeah, this is a forever divide between how mathematicians talk about mod and how computer scientists talk about mod. Oh no, not you're bad at all. I think you're 100% right to point it out. And it suggests that you think about mod in a more mathematician-y way rather than a rather than a computer sciencey sort of way. Let's see. Okay, so this again is one of these things saying that this number, that 21 has to be 1 mod this number. And so we went through 2, 4, and 5 before as being the numbers that 21 is 1 mod, and this isn't 5. So this is in fact a 2-4 pair. So this is 1, 2, 3, 4, 5, 6. These are from 1, 3, 6. Let's see. So this can't be a 1 because of that. So one of these two is a 1. One of these two is a 1. Let's see. This is going to end up being divisible by this. This is going to end up being divisible by this, although, of course, if this is a 1, that's not going to be saying anything. Okay, so if this was a 6, could I make this diagonal work? If this were a 6, I would need these 3 numbers to sum to something divisible by 6. I guess I could do 3, 6, 3. No, that doesn't work. Maybe it is not immediately clear to me. Okay, what about this one? Here about this one. This is the easy one. These two numbers are going to sum to a number which is divisible by this number. Well, this number is even, so this can't possibly be a 3. So this is a 6. It's a 3. Let's look for the low-hanging deductions first. Now, this could be a 2, and then it's automatically fulfilled, or it could be a 4, in which case that's a 2. Oh, but that doesn't work. Okay, that's gorgeous. That's really cute. So if this was a 4, I need these two numbers to sum to something divisible by a 4, which means I could make this 6 and this 2, except now I've put a 2 and a 4 looking at this 2, 4 cell. So this is not a 4, it's a 2. Okay. So now we can ask better, could this be a 6? These two sum to 8, which is 2 mod 6. So I'd need this number to be 4 mod 6. So I'd need it to be 4. Now, actually, I know that I'm going to need to be 0 mod 3 regardless, because this diagonal sum's always divisible by 3. And so this number always needs to be 1 mod 3 in order to make that work with the 5. And 1 is already taken, so the only digit this can possibly be is 4. Regardless of whether this is a 3 or a 6. But then as it happens, both 3 and 6 work. Any number mod 1 is 0. Oh, sorry, I can't say it out loud because he just said that he doesn't have audio. Okay, so these numbers are 2, 3, 5. That one's not a 2. Oh, 2. No, sorry. There's a 4 down here for sure. Okay, let's write this down. Okay, so these are going to be 1, 4, 5, 6. These aren't 4. This can never be a 6. Because if this cell were a 6, we'd be saying that this number is 0 mod 6, which is not possible. This can't be a 3 either, because if this were a 3, we'd be saying this number is 0 mod 3, but we don't even have any options. So in fact, that's a 1. So that is not a 1. So these aren't 1. I should fill in. Okay, so if this were a 6, I would need the sum of these two digits to be 6. So I'd need that to be 2 and 4 exactly. Uh, that's plausible. Uh, uh, oh, one more than 6. Sorry, I was looking at the wrong cell. I was not. I was looking at the 0. I was sorry. If this were 6, I would need these to sum to 7. Is in fact what I would need. Uh, sorry, I looked at the wrong clue. Yeah, I'd need these to sum to 7, which they can do, unfortunately, in a lot of ways. Uh, Now, I do know the sum of these digits is 1 mod 3, so I know these digits sum to something that's 2 mod 3. And so since 21 is 0 mod 3, I know that these 3 digits sum to something that's 1 mod 3. This is 0 mod 3. So these 2 digits I know always sum to something that's 1 mod 3. Which is interesting, because the fact that these need to sum to something that's 1 mod 3 means this digit can't be a 6. Because if this digit were a 6, neither of those things would work. So that digit's not a 6. Can I do better than that? These two need to sum to something that's 1 mod 3. Yeah, so this could be 4 would go with 3. 5 would go with 2. 2 over here would go with 4. 3 over here would go with 4. Wait. That can't be right. These two need to sum to something that's 1 mod 3. Let me go over that again. Okay, so 3... Yeah, 3 would go with 4. 2 would go with... Sorry, 2 would go with 5. 3 would go with 4. 5 would go with nothing. 5 doesn't go with anything, right? Because 5 is 2 more than a multiple of 3. I'd need to add a thing that's... Yeah, I'd need to add 5 to it, and I can't put 5 with 5. So this cell's never a 5. That is the punchline. So Ambrose agrees. This is not 5. So we've got this is a 2 or 3, which has to, remember, be divisible by 1. Okay, so so we're going back to this and looking at these two things being 1 more than a multiple of 6. This cell, okay, this cell can't be 5. Wait, is that right? Okay, so these need to sum to something that's 1 more than a multiple of 3. That's the point. These two sum to something that's 1 more than a multiple of 3. So if this were a 5, what could I add to it? 5 plus 4 wouldn't work, and 5 plus 6 also would not work. And I can't add 5 and 5. So right, this cell can't be a 5, which gives us a 2-3 pair, which gives us a 5. I agree. So this is a 1-6 pair, so that's a 3. So that's a 6. So then we can look at these two cells again, where we need to be 1 more than a multiple of 3. So we could be 2 with a 5, or we could be 3 with a 4. This can never be a 6, because if this were a 6, I don't have a 1 mod 3 option. So these are a 4-5. I suspect I had a 2-3 pair, and I just argued that my 2-3 pair removed something from over here, but whatever. This is a 4-5 pair. We're just going to call it good. Let's see. So... Oh boy, and our only remaining clue is this one. We've filled every other clue. I guess technically we know these two are entangled, but other than that, we have no other clues. Okay, so Sudoku it is then, I suppose. Uh, uh, I'm not quite ready for more tea yet, but I should have more tea soon. Uh, oh, cute. Okay, good point, Ambrose. I was really, I was just abandoning hope immediately, but Ambrose actually looked at this and said, ah, 1 and 6 are both 1 mod 5. So actually, these are 0 mod 5. So all we're saying is the sum of these two cells is a multiple of 5. That is really cute. Great spot, Ambrose, and great setting to Garford for this. Now, these two need to sum to a number that's 0 mod 5. That number's not 10, because the only way to sum to 10 is with 4 and 6, and conveniently the givens rule that out. Again, very nice use of the givens. So these are either 1, 4, or 2, 3. Of course, that's not a 1, so that's not a 4. But I don't know that I can immediately say more than that. But actually, that does let me place the 6 over here in this box, so that's going to give me some progress. At least a little bit. Let's see, I'm going to get a 6 over in one of these two places. I'm just really quickly running through and seeing if either this being 2, 3 or this being 4, 1 immediately breaks, but not that I see. We're going to go ahead and fill this in. So these are 1, 2, 3, 4, 5. That one's not a 4. As these things go. So these two add to 5. And let's remember, while those two are adding to 5, these two are adding to 7. So this is either a 2 and a 5 or a 3 and a 4. Yeah, beats me. Let's see. Oh. And I just know one of these two is a 1, but that's not super helpful. I was momentarily excited, but let's see. This is not a 1. Could be a 2 or a 3. It's not a 4. It could be a 5. This is a 2, 3, 5 for whatever that's worth. Trying to manufacture a tuple out of nothing. What am I supposed to see here? Let's see. I'm going to color the two diagonals that are relevant. There's that one, and then there's those two cells. The rest of this is just automatically taken care of. So these sum to 5. These sum to 7. I really don't need to have this highlighted, I suppose. Row 6, column 1 and 2. Should add to 10. Sorry, row 6, column 1 and 2, and row 5, column 3. Should add to 10. Uh-oh, we've got another spam bot. I'm not sure I see how that works. Let's see, these add to 5 and 11. Oh, because these add to 11, so these add to 10. Okay, I think I agree with that. So could row 5, column 2 be a 5? See, if this was a 5, what's wrong with this being a 5? I don't see how this being a 5 breaks anything. I could be wrong. Yeah, we could employ the now well recognized technique of coloring 2s and 3s. Uh, Although I'm not sure I see how to even get started with coloring them, unfortunately. Uh, yeah, so if these are a 2 3, that's a 5. This is a 1 4. That being a 5 makes that a 4, makes that a 5. Which all seems on the up and up. Let's see. Okay, so we have a vote for filling in the entire grid. Sold. So this can be a 2 3 or a 4. These can be 2 3 2 3 4 6. This one's not a 2 or a 4. This one's not a 3. Just not a 3. These can be 1 2 3 5. That one's not a 2. This one's not a 3 or a 5. Okay. So we have now good lift the grid. Now let us quickly pray to pencil mark that we discover a triple out of that. I am noticing, for whatever reason, I have 5 pencil marked as being able to be here, even though it obviously can't. Let's see. There were more restricted cells than I was expecting. Let's see. Row 6, column 2. Can't be a 3. Okay, let's see. If this is a 3, that's a 2. If that's a 3, that's a 2. That's a 2. That's a 3. Let's see. Okay, I don't see that right away. Okay, so for example, this can't be a 2. I don't see it. Let's see. Jay says if row 6, column 1 is a 1, then... Sorry, is a 4, then there's no place for 1 in box 5. That's a good point. Right. If I make this a 4, then I don't have any place for 1, because the only place for 1 I could then use it has disappeared. Because once this is a 4, I can't make this add to 5 anymore. So this is not a 4. Okay, so I think Jay has found the secret. So this is 1 5, so that's a 4. We'll see if that does us a lot of good. This is not a 4. So One of these two is a 4. Hey, it got us progress, so I'm happy about it. Okay. It's never a question whether to good lift or not to good lift. You just good lift everything, and then the solution falls in your lap. That is how it works, right? Uh, okay, 2 in row 5, column 2, forces a 1 above it. Says afraid not, and then the column 3, box 5 domino is broken. Okay, so if this is a 2, that's a 1, that's a 3, and then that would need to be a 2, and that doesn't work. Beautiful. Okay, so agree with afraid not. I think this is really hard to see. But if this is a 2, it makes that a 1, which makes this a 3, which also needs to make that a 2, but we started this whole shenaniganery with that being a 2, so that's not a 2. So, okay, now Garion is saying if this is a 3, it forces a 4. Oh, okay, that's the point. Okay. So I can never have a 3 next to a 4. And if I put the 3 here, then I end up putting a 2 there, a 5 there, a 1 there, and a 4 there. So a 3 here puts a 4 next to it. And that's not going to work because either this is 3, 4 or this is 3, 4. Over here, this is 2 dominoes that sum to 7. And so one of them is 2, 5, and one of them is 3, 4. So I can't put 3 and 4 in the same row. And if I put a 3 here, as Garion points out, that forces a 4 here. So this is never a 3. So that gives us a 1-2 pair, which removes a 1 as a candidate from that cell for whatever that is worth. So let's see. If this is a 2, that's a 3, that's a 5, that's a 1. Right. And because this couldn't be a 3, this can't be a 2. Which gives us a 3, 4, 5 triple. Beautiful, beautiful. So, good spot. 3, 4, 5 triple means that's a 2, that's a 3, that's a 5, that's a 4, that's a 3, that's a 2, that's a 4, that's a 1, that's a 5, that's a 1, that's a 5, that's a 3, that's a 6, that's a 2, that's a 1, that's a 6. And there we go. Yeah, this bottom part here was quite stubborn. I think that is a good word for it. I really liked this rule set. I think I'd have liked this puzzle more with a given, so that once we got through all the cool stuff, we didn't have to think about this stuff down here. But the opening logic and the mechanic of the puzzle is very cool. I really like the idea of this sort of rule set. And the use of the ones in rows with the fact that you know what a row sums to is very cute. Okay. Moving right along, next up we have a friend of the channel, Stefan Bura, whose puzzles we've often featured, including he has this wonderful series of compass sudokus that I just absolutely adore, since compass is my favorite pencil puzzle genre, and it's a series of puzzles that use that. But we've done some other stuff on Bura puzzles as well, and Stefan Bura is often in chat as well. So let's read the rules. 2 hidden slingshots. A slingshot is an arrow bent at a 90-degree angle and located within a cell in the grid. It indicates that the digit in the cell behind it is repeated at a distance of n steps from the slingshot cell in the direction of the arrow, where n is the value in the slingshot itself. Okay, and then we have an example. Let me make sure you can see the example. You can see the example. So in this example, the digit 2 appears behind the slingshot, and then the 2 is repeated 3 steps away over here. In this puzzle, each red cell contains a slingshot, but its orientation is unknown and must be determined by the solver. Each slingshot in the grid has a different orientation, and each red slingshot cell contains a different digit. Okay, so all 4 orientations of slingshot show up. All 4 of these contain different digits, but it's not the slingshotty digits that are different. It's not the slingshotted digits that are different. It's how far the slingshot digits are slingshotted that is different. Okay, so we can start here with the fact that these are a 3 or a 4. Okay, so I'm taking a look at this to think about. This could be the 6 getting shot in this direction. I should probably uncolor this just so that there's no confusion, as I think Nicholas was seeing this. Okay, so this one can only either slingshot something that direction or slingshot something this direction. Oh, sorry. 5 of 8 orientations show up. Sorry, there's actually 8. Never mind. I don't understand, but I'd like to. What's going on with this 3-4, Afraid Not? Five slingshot only in row 5, column 2. Row 6, column 2. So couldn't we sling this digit 4 spaces in this direction? Or for that matter, this digit 4 spaces in this direction? Why does this one have to go down? Why couldn't this be a 5 or a 6 that's placing the 5 or the 6 over here? Well, this could never be a 6. Oh, is that the point? That this... Okay. So... this either shoots... So I think chat is claiming that it is obvious that this is not a slingshot slingshotting this digit over to here. And that is definitely not obvious to me. But this digit is a 3, 4... Sorry, it is a 3, 4, 5, or 6. Yeah, this digit itself can't be 6. So now if this were a 6, then this would need to go 1, 2, 3, 4 spots. So I think this could be a 6 with this being a 4. And I think that would work fine. Correct. The red digit is the distance it gets shot. So I think this could be a 6. I think if this is a 5, it doesn't work. Because if this is a 5, and I try and shoot it over here, then this would need to itself be a 5, and then we'd have repeated 5s all over the place. But of course, that doesn't disprove that actually this is a slingshot that goes this way. Right, you can't sling something 6 cells, I agree. So, okay, so I think chat is looking to use the fact that these are a 1, 2, 3, 4, 5 triple. That was given in the rules. All of these are different. So this is not a 2 or a 5. This is not a 1. This is not a 5. This actually can't be a 5 because it doesn't have any direction it can go 5s. So this is the 5. Okay, so chat wants us to use this. And so we know that this is slinging this digit here. So let's give that a color. This digit, whatever it is, actually I don't like that color. We're going to make it yellow. This digit, whatever it is going to get slung. Oh, I don't know which one. Sorry. It's one of these two digits. That digit or that digit appears here. So this digit is one of the sides of this slingshot. Yeah, it could be row 6, column 1. I was missing it. Okay. What red cell can be 1? Asks Carl. This one can certainly be 1 if it goes like that. This one can't be 1 because it's in the corner. That's very clever. Okay, this can't be 1 because it would be shooting one of these two digits into the same box. And so this one has to be a 1. And so now this has to cross boxes, so it doesn't look like that in either order. And so what this one is saying is that these two are the same, those two are the same digit. And so that digit is a 3 or a 4, we know. I don't know whether it is a 3 or a 4, but it is a 3 or a 4. And these two are the same. So, and again, I don't know if this is... Yeah, I don't know which direction this is shooting, because it's a 1, and the 1 ones have an ambiguous direction. So it's either that 90-degree angle or that 90-degree angle. Yeah, so this has an undetermined orientation. Listesh with a good point. 5 in column 5 is placed. It can only go there. And now 5 is placed here. Okay, these digits, let's fill in, are a 3, 4, and a 6. These digits are a 2, 3, and a 4. But that gives us a 2, 3, 4 triple in the box. So this is actually a 6. So this is the other 3, 4. So these are a 2 and a 6. And so this is a 1. Just by sudokuing. So these are a 2, 3, 4. Okay. So beautiful, beautiful. Ambrose has a beautiful point. I know that this is slinging a digit here. I don't know which of these two digits it is, but I do know that this is a 2, 3, or 4 because it's slinging one of these two, which gives us a 2, 3, 4 triple, which means that this is a 1. I see Tom Hartley had a similar deduction at a similar time. Let's see. Mustn't row 1, column 4 sling a 2 downwards now? So I think this only has 2 options, which I think are to sling a 6 downward, and it could sling a 1 downward, but it can't because it would need a 5, and it can't be a 5. So I think the orientation of this slingshot is actually that it's going to go that 90-degree angle. And so it's going to be referring to the location of the 6. And so this is going to be... so I think this is going to need to be a 3, right? Do we agree? I think I understand the rules. I don't 100% promise I do. But I think the only way this one works is if this is a 3, placing a 6 here. Does anyone in chat agree or disagree with that assessment? The lack of ability to draw on this is very... very concerning. Oh, it could sling the 4. I was not looking at this. Yeah, it can sling the 4 left over to here. Never mind. Darn. Okay, so... But this is still a 3 in that case. Does that mean this is still always a 3? Can this ever be a 4? If this is a 4... the only direction I can go for cells is this way, and I'd need to have a 5 in one of the cells where I can't. This is always a 3. So that's a 3, that's a 4. These aren't 3, that's not 4. Okay, now... I was being told by someone some time ago that this digit could never be a 2, I believe. So this is not a 3 at least, because I now need to have this be a 2-4 pair. So can this be a 2? So if this were a 2, it would be slinging something into one of these 2 cells. So if it were slinging here, I would need a 5 in one of these 2 cells, but I do have one. So this could be a 5 with that being a 2 and that being a 5. That's fine, right? Okay, now, if this is a 4, it is pointing at either that cell or that cell. So if it was pointing at that one, I'd need that to be a 6. I really wish there was a nice way to indicate the orientations of these slingshots, because I feel like we're going to need to use the fact that I can't repeat the direction of a slingshot, and I do not have any good way of keeping track of the directions of the slingshots. Okay, here's an idea. What is this cell? I think this is the smart thing to do, because this cell sees a 2-4 pair, and it sees a 5 and a 6. So this cell can only ever be a 1 and a 3. Drawing on my screen with a marker is a good option. I think I will consider that as I move forward. But now... if this is a 2, okay, if this is a 2, it slings in that direction or that direction. It can't sling the 1 because I don't have a 1 that it could sling. So that would not be it. So it would sling the 4 here. So that would be a 4, 2, 4. Okay. While forcing a 4 into the other red. That forces a 4 into row 3. Okay. So this is a long journey. Ishutes, this is a 2-4 pair by the rules. The rules tell us that the red cells are a 1, 2, 3, 4, 5 quintuple. And this cell sees the 2-4 pair, which is why it cannot be a 2. Okay. Now I want to go over Jay's... this is a really long forcing chain that I would prefer not to do, but we're going to do it because we want to get through the puzzles. So if this is a 2, then that's now a 4, putting a 4 here, because the 1 doesn't work. So this is a 4. However, Now in this universe, this is also a 4, which makes that a 4 for the box, and I've now put 2 different 4s in row 3. So this isn't a 2, it's a 4. Don't like that, but I'll take it. So that's a 4, that's a 2, that's a 2. So now we can't now. Oh yeah, we could be slinging a 2 4 spaces. No, we can't be slinging a 2 4 spaces. 2 3 4, because if we were slinging a 2 4 spaces, we'd end up putting a 2 here where we cannot. So we must, in this instance, be slinging in that direction. The thing that is 4 spaces in that direction is a 6, so therefore that's a 6. That's a 5. That's a 3. Okay. So can we do more? This is not a 4 anymore. Let's see. This is not a 2, 3. This could be a 4. It's not a 5 or a 6. It could be a 1 as well. Yeah, so that's a 1, 3, 4 triple. Okay, if row 5, column 5... Oh, I think Carl is saying there was a nicer way to see it by speculating what happened if this was a 4. So if this was a 4, it was going to need to fling... it couldn't fling the yellow digit, because flinging the yellow digit would always put the yellow digit in a row or column with the yellow digit. So it was going to have to fling one of these 2 digits. It wasn't going to be able to fling the 5. And so it was going to have to fling this digit over to here, and that was going to cause a problem of some sort. Okay, so remove 2 from row 6, column 5. Yes, let's remove 6 from row 2, column 5. That is a good idea. I like this idea. Yeah, so I think I like Carl's I think Carl's direction feels a little cleaner to me. But it's all a matter of preference of what you like. Okay, so this could be a 5 flinging the 5 up here. That could be the direction of this slingshot. Do we know what this 3 is doing yet? This 3 can be slinging the 4 over here. This 5 is slinging a 2 up here. Oh, that's why Ambrose was telling me to remove a 2 from there, not because there was a 2 right there. Row 6, column 3 must now be the 2. Are we assuming this slingshot goes this direction? Do we know it doesn't go a different direction as well? Let's double check. So can't take this digit there. It can't be the same slingshot as the 2. I'm just worried that, does this 2 have to be this slingshot, or is it possible there's some other orientation of the slingshot that works? And I think the answer is actually no, because this 2 can only be putting digits in those 2 places, and there's nowhere this can be flinging a 6. So yes, so this 2 is flinging the 5. So this one can't be flinging the 2 from that side, so it has to be flinging the 2 from that side. Okay, I agree. So that's a 3, that's a 4. It's a 1, that's a 4. That 4 makes that a 3 and that a 3. That makes that a 4. This puzzle made me very badly wish that I had done the actual slingshot puzzle that Stefan made first, because it is in my bucket to do Stefan's, and I definitely intend to do Stefan's slingshot puzzle. I just had never done it, or I have not done it yet. So trying to conceptualize this without having done the easier one was difficult. Okay. Yeah, that was not too bad. I wish that it was not a pain to switch into the pen mode so that I could have drawn the direction that things were going. But yeah, that was not too bad. I liked I liked the way that Carl explained why this couldn't be 4, because it didn't feel like look ahead in the way that the other did. But good puzzle. Ooh, a 1-star slingshot puzzle. After this exchange, I may be in the mood for a 1-star slingshot puzzle. But yeah, definitely now even more looking forward to doing Stefan's slingshot puzzle when I get there. Yeah, Stefan's slingshot puzzles are 9x9. Oh, and perfect. As Ashutz points out, Ashutz is next. Let's see. So let's clean out the coloring of these two cells. Hello. Oh, no, I can't clean out the coloring of this cell because this cell is given colored. So we're just going to do a nice clean killer puzzle from Ashutz. So remember, no digits can repeat in these cages. And Ashutz is famous for killer puzzles, which I usually don't do killer puzzles on stream, not because I don't like them, but just because they make very difficult stream puzzles because there's so much talking about cage math and stuff. But I am looking forward to doing this. This can't be the 1-5, so in fact, this is a 1-5 pair. That's because this 1-5 pair rules itself out of all of those. So this is a 1-5 right there. Oh, move the zeta. Oh, sorry. I started doing the puzzle without moving the zeta. Apologies. We have placed some 1s and 5s. That is it. Thank you for letting me know, chat. Appreciation for letting me know that I did not move the zeta successfully or at all, as the case may be. So let's see. Zeta's in the way, yes, as is so often the case. Okay, where are the 1 and 5 going down here? So I know I need a 1 and a 5 here. Well, I'm certainly not putting the 1 there. I can't put both the 1 and the 5 on here. Could I put the 5 here? Oh, interesting. I can never put the 5 here. Because if I put the 5 here, I'd need a 2-3 or a 1-4. And again, through the magic of givens, that does not work. So this cell's never actually a 5. So because both of these can't be 1-5, this cell is always a 1-5. Now because this can't be a 5, we're now running out of options. So it's not a 6, it's not a 5, it could be a 4, it can't be a 3, and now we're out of options. So the arrow actually has to be a 4, which means that in fact, these are a 1-3 pair, which means that that's a 5, that's a 1, that's a 5. This digit is now known. This is gorgeous so far. So this digit only has 2 options. What are the 2 options for this digit? Okay, actually, both of these only have 2 options. Let's fill them in at the same time. These are 3 and 4. Alrighty. Yeah, Verg has the smart point, which is that you can't ever put 5 on this arrow because the circle couldn't have been 6. So I could have placed the 5 here right away before even going into all of the other shenaniganery that I went into. But what are you going to do? These are a 2 and a 6. Okay, so the 1 and the 5... No, that's not going to work. Okay, so I can do a similar thing where I know that there's a 2 and a 6 in here. So I know there's a 2 and a 6 down here. I know this is never a 2. I know I'm never putting a 6 along here. And so because now the 6 is locked into here, I actually get to resolve. That's the 2 and that's the 6. So that 2 is telling me that that's not a 2. So now there's definitely a 2 on this arrow, which tells me that the arrow is not a 6, because if this were a 6, I'd need a 2, 4, and there's already a 4 in the row. So that's a 6. So if this is a 5, then it's a 2, 3. If this is a 4, then it's a 2, 2. Well, it's not that. Oh, it's not 5, 6, or 4. So it has to be 3. 3 is the only option now. So this is a 3, that's a 1, that's a 3. This is a 1-2 pair. And so now this is a 1, 2, 3, 4. This is a 5. That's a 4. Gorgeous. This is a very fun, snappy little puzzle. So now I actually know the contents of this. This is now a 1, 4, 5 because all of 1, 4, and 5 have gotten pushed into this collection. These cells can't be a 4, 5, or 1. So these are a 1, 4, 5, which does a bunch of things. So one thing it does is to make this a 3 and that a 4, just by virtue of sudokuing. But another it does is that these 3 cells sum to an even total. I need these to sum to an odd total. So there is an odd up here and an even up here. I guess I don't quite know yet. Oh, I do know that this is a 1, by the way, while we're doing Sudokuology. Let's fill in what these are while we're doing Sudokology. These are 2, 3, and 6. That one's not a 3. That one's not a 6. Let's see. The 6 is placed up in this box. So this is a 6. Because 6 can't go on the arrow. So that's not a 6. So that's a 6. And so now I know that these digits sum to 7 plus 9 is 16. That's even. So this digit has to be odd, and it's not 1 or 5. So therefore it's 3. So that's 2. That's 3. Let's see. And now hopefully everything will clean up. This has been a really nice little puzzle so far. I say so far. I'm hoping it's not going to be too difficult from here. Hopefully. These are a 1, 2, 4, 5. These aren't 2. These aren't 4. Let's see. Okay, this is certainly not a 1. How about that? I cannot make the arrow sum to 1. Okay, now I have a 4, 5 pair in the column, so that's not a 5. Oh, now that this is a 4 or a 5 and not a 6, there's never a 5 on the arrow. And so now, if there's not a 5 on the arrow, now there's only one place for the 5 to go, which is there. And now I have a 1, 2 pair, which means that's a 4. And so that's got to be a 1 and that's a 2. The 1 goes down there. That's a 2. That's a 1. Now that 5 looks down and says that's a 4 and that's a 5. And that 4 looks over and says that's a 5. That 1 looks over and says that's a 5 and that's a 1. That's a better way to do it. Very nice, snappy little puzzle there. I liked that one. I liked that one a lot. That was a very brisk 6x6 that used the logic of these really nice, nicely designed regions that are in this nice geometric shape that you can really only do in 6x6. Lovely as always. Shoots has some of my favorite Simon video solves. Okay, so next up, we have an arrow puzzle by Florian, who's also very often hanging around these parts, I believe. So this is just a straight arrow puzzle. So we're going to put 2 6s in the thing to start. Okay, so 2 and 6. Okay, so this is... So let's do the parody the first time. I didn't even notice. Wow, Ambrose with the cool spot. That this arrow is incredibly useful for us. Okay, so we're going to use parity right away this time, which is to say I know the sum of all of these things is even. So therefore this digit must be odd. We're not going to get fooled by it this time. So this is a 1, 3, or a 5. It's not a 5. In fact, it has to be a 1, 2, 3. Adding to 6. That's the only way to make this arrow work. Now I need a 5 in this column. The only place it can go now is here. which means that this is either 2, 3, which it's not, or it's 1, 4, which it is. So that's a 1, 4. That's a 3. These are a 1, 2. Let's see. Now, the 5 now has to go in one of these two cells for whatever good that is going to do us. These 3 cells are going to be a 3, 4, 5. That one's not the 3. This arrow here could be a 3, a 4, not a 5, or a 6, I believe. 6 in row 6 placed. Can't 6 in row 6 go in either of these two places? I am probably missing something with givens that I'm supposed to be doing. Oh, there is a 4, 5 hidden pair in row 6, because I need to put both 4 and 5 in row 6, and the only two places I can put either of them are there. So this is a 4, 5. And so now that I've found the 4, 5 hidden pair, we now get a 6 here. So same outcome, slightly different ways of thinking about it. So these are 1, 2, 3. Oh, but the 3 in box 4 is definitely over here. So there's a 3 over there. So this is not a 3. I will not hear any suggestions that there was an easier way to deduce that this was not a 3 than the way I deduced it. The way I deduced it was perfect and as simple as it is possible to achieve. Let's see. There's a 1 and a 5 over here. Just by sudoku. Now that means this cell can't be a 5, because if this cell was a 5, then I'd need to put a 1 here, and I can't. So in fact, the 5 is actually in one of these two cells. So now the 5 for the column is bunched up down here somewhere. Let's see. One of these two is a 6 for whatever that is. For whatever that is worth. Row 4, column 3 has to be a 4 or a 5. Let's see. Okay, so it's at least a 3, 4, 5, or 6. And now let's argue that it's not 6. So if this were 6, this would need to be 2, 4. Wow, that breaks in a really complicated way. Okay, if this were 6, this would be 2, 4. Wait. Oh, easier way to see this. Where is 6 in column 1? 6 in column 1 is only in one of these two cells, which makes that not a 6. Thank you, Carl and many others, Barbie, etc., who were noticing this. Okay, and then the claim is this is not a 3, because if this was a 3, this would be a 1, 2. That would be a 3. I don't see that yet. Row 2, column 1 is a 1 or a 2. Right. It's not a 5 or a 6. It's not a 3 or a 4. So this is always a 1 or a 2. Good spot. Oh, this 1, 2 pair down here. Got it. Okay, that's really cute. Okay, so if this is a 3, this is a 1, 2 pair. And the key observation is that that gives us an X-wing on 1s and 2s, which pushes a 1 and 2 up here, which then would make this a second 3 in the box. That's really clever. Okay, I definitely did not appreciate that, but that is very nice. Okay, so this is not the 3. Uh, I don't think I've seen a deduction like that before. Okay, so we need a 1 or a 2 on here. And then we need a 3 or a 4 on here. So this is a 1 or a 2 and a 3 or a 4. Good point from Barbie. If this is a 4, then I've now got my allotment of 3, 4, 5s, but then how am I making 4? Only as double 2, which I can't do. So this is not a 4. Okay, so if this is a 4, that breaks something. Let's see. If this is a 4, then this is a 1, 3, which makes that a 2, that a 1, that a 3. This is way too far down the line. So someone can explain this to me in a way that I can see that does not involve. I don't want to chase this far down this. There's always a 2 on the arrow in column 1. Okay, so if this cell is a 1, this cell is a 2 because it can't be a 5. If this cell is a 2, then this cell is either a 1 or a 4, is I think what chat is telling me, except this is never a 1. So this cell is always a 2 or a 4. So it's either a 2 with a 1 or a 4 with a 2. Those are the options. Let's see. Carl wrote it. Okay, so 1 plus 3 in box 3 also breaks. Makes the row 3 column 1, makes that a 6. And pushes 1 onto the arrow in box 1. And pushes 1 onto the arrow in box... right. And now this can't work. Okay, got it. Okay, so let me try and explain that. So in terms of what we just said about this 6 arrow, what we said about this arrow. If this arrow has a 1 on it, then it is a 1, 2 arrow. And so if there's a 1 on this arrow at all, then this is a 3. Well, if I put a 1 in either of these two cells, then because of the X-wing on 1s, we're going to put a 1 up here and make this a 3. Well, that means that I can't possibly make this a 4, because then this would need to be 1 and 3, and then that's going to put 2 3s here. Okay, so that is fairly complicated, but I think it comes down to understanding sort of the way that this X-wing is interacting in the world. Okay, so that's going to place a 5 here, just by virtue of sudoku. This is not a 5 anymore. This is not a 5 anymore. So now this could be 2 3, in which case if this is a 2 3, then we would need this to be a 6 2 4. Or this is a 1 4, in which case then this is a 3. So always one of these digits is a 3. Because either this is a 2 3 or this is a 1 4, in which case we still push a 1 up here and make this a 3. So there's always a 3 in one of these cells. This cell's never a 3. Therefore, this cell is a 3. That is the punchline of that, I believe. Oh, let's see. Empress is saying the 2-3 breaks. If I put a 2-3 here, then now I have made... let's see. Row 3, column 6 is always a 2. If this is a 1, what does that do? If this is a 1, that's the 1. I don't see it yet. Where does row 4, column 4 go in box 3? So if this digit's a 4, I need to put a 4 on here. Along with a 1. Okay, that's a really clever way to say it. Okay, so I really like Carl's way of saying this. If this digit goes on this arrow, which means that this arrow is always 1, 4. Because, well, if you have a 1 or a 4 on your arrow summing to 5, you always have both a 1 and a 4. And so the point is, as soon as I know that this digit has to go on this arrow is a 1, 4, which then resolves the rest of the stuff, as chat has been saying. That was very slick, Carl. I really like that. I know chat sometimes gets driven nuts by my wanting to find the slick way to do something, but it is my tendency when I'm doing puzzles to want to do that. So once this is a 4, that's a 2, this is a 1, this is a 3, this is a 6. This digit, I probably know what it is if I count carefully. It looks like it's a 2, and that's a 1, and that's a 2, and that's a 4, and that's a 1. That's not a 1 anymore. I probably know what this digit is, 2. It looks like it's a 3. That's a 6, and that's a 2. That's a 4. That's a 6. It's a 6. And that's a 4. Really nice little arrow puzzle. Again, I'm really impressed by how much logic some of these setters are putting into their 6x6 puzzles. Like you usually think, oh, it's going to be a small puzzle. It's going to not require that many steps. There are a lot of steps in that puzzle. That was really nice. Okay, moving right along. We're going to come up on Shark Angel's puzzle. So let's look at Shark Angel's puzzle. So let's pull up the rules for Shark Angel's puzzle. Okay, so this is puzzle number 62. Every pair of digits along a blue line must differ by the same amount. This difference may be different for each blue line and must be determined by the solver. For purposes of this constraint, 6 and 1 are considered to be consecutive. Also, boxes 2 and 5 contain the same digits in the same orientation. Okay, so boxes 2 and 5 are clones. I'm assuming when it says every pair of digits along the line must differ by the same amount, I'm assuming it means pair of adjacent digits along the line. And I'm wrapping my head around what 1 and 6 being consecutive means. So does that mean, that means 1 and 6 are 1 apart. Does that mean 2 and 6 are now 2 apart? I'm guessing it means 2 and 6 are now 2 apart. This is definitely the most confused I have been by a rule set. I'm going to just try and fake it and see if we can succeed in figuring out what's going on. So these are a 3-4 pair. So if I need to put 6 digits so that they're all the same apart, let's ask how far apart that could be. Well, it has to be an amount apart that is relatively prime to 6. Because if I say try and put them 3 apart, then I would go 3, 6, 3, 6, and that's not going to work. Or I could go 4, 1, 4, 1. That's not going to work. Or if I try an even distance apart, you're going to end up with the same thing. And so the only numbers that are different, that are relatively prime to 6, are 1 and 5. And so 1 and 5 are the same. They're a difference of 1. And so these are the digits 1 through 6, either clockwise or counterclockwise around the loop. Now, the 3 and the 4 have to be consecutive with each other along this loop. And remember, this loop and this loop are the same loop. So where can I put the 3, 4? Well, I can't put the 3, 4 there at all. So that's saying neither of those is 3, 4. And now if I look at this, I can't put the 3 and the 4 horizontally in either of these two slots. So the only place for the 3, 4 is actually there. So these are 3, 4. So 3 and 4 are adjacent to 2 and 5, which are adjacent to 1 and 6. And so these are 2, 5. And I actually now know, because of the given 2, that this is actually a 5 and that's a 2. So that's a 6 and that's a 1. And that's a 4 and that's a 3. That's a 4, 5, 6, 1, 2, 3. Okay, so I think if I've understood the world correctly, and if anyone has done this and can confirm that I understood the world correctly, I think that is the correct way to do this opening. These are a 1, 6. These are a 3, 4. These are a 2, 5. I'm going to get myself a drink real quick. I'll be right back. Returned with grape crystal light, so all is right with the world. Let's look at box 6, some people suggest. So, for example, these digits are 4, 5, 6. These digits are 1, 2, 3. That one's not a 1, that one's not a 6. That one's not a 2, that one's not a 5. That one's not a 3, that one's not a 4. Okay, so one of these two is a 4. Uh, no. Try again. One of these two is a 4. So, uh, just the difference just has to be 2. Why did I even look at this? The difference has to be 2 because it's length 3 and it's a cycle. So the only way this is going to work is if it's 4, 6, 2 is the point. There's definitely a 4 on it. And if I tried to go, say, 4 here, then 5 here, then I'd need to put a 6 here, and that's not going to work. So that needs to be 4, 6, 2, and that satisfies the rules. So 1, and that's a 3. That's a 5. Okay, let's fill in the rest of these. Let's see. This is a 3 and a 5. This is a 1 and a 4. And this is a 2 and a 6. A difference of 4 is the same as a difference of 2. So this is a difference of 4 and a difference of 2 are the same, just forwards and backwards of each other. So now we have to make some clever deduction about what's going on with this line. This line is not a circle, so I don't get to use the fact that I know the divisors of 6 anymore. Okay. Interesting. If this was a 1, this would be consecutive with 1 no matter what. Because this is either 1, 2 or 1, 6. 1, 2 would not work. 1, 6, 5, 4 actually would work. Okay. If this is a 4, then actually the difference is 2 regardless. So we would go 4, 2, 4, 2, 6 doesn't work. Oh yeah, if this is a 4, everything on this line needs to be even. So we'd have to go 4, 6, 2, 4. Does one of those not work? Both of those sounded good to me. Both 1, 6, 5, 4 and 4. Okay. One of the ways was 1, 6, 5, 4. One of them was 4, 6, 2, 4. So this is always a 4, I guess is the point. Which means that's a 1, which means that's a 4. Oh, I see. Okay. So just to explain the thing that was not at all clear to me, if this is a 1, it makes this a 4, and the reason that breaks is because this cell has to be a 1 or a 4, and suddenly it sees both. So I figured out what the solution was, but I then was confused as to why it was the solution, or like what exactly broke about the 1, but that's what happens. If I start this with a 1, I end up breaking this cell in a somewhat convoluted way. So that's a 4, that's a 1, that's a 4. And so then this is a 6 and a 2, and a 5 and a 2 and a 3. Sorry. A 5 and a 3. 3 there, 6 there, 1 there. Alrighty. Nice puzzle. I like this idea. I've thought a lot about ways to try and use this idea of sort of tying the numbers together into a ring so that there was nothing special about 1, but I could not. But I've never been able to quite make it feel not fiddly. And as I've said many times before, putting something in a 6x6 is a great way to take an idea that might otherwise feel a little fiddly and make it feel not fiddly. Alrighty, next up we've got Friar, who is also often to be spotted around these parts. So let's move the zeta out of Friar's way and do my job of hiding the digits that aren't part of the puzzle. I'm going to scroll this just a smidge so it's a little more centered. And then we're going to look real quick at what the rules are. These are pointing sum blocks. the sum of the digits along the path indicated by an arrow, not including the arrow itself, is equal to the sum of the digits along the gold-colored line attached to that arrow. When summing digits, note the path indicated by an arrow stops when it hits the border of grid 63 and does not continue into grid 62 or 64. Let me read that again. So the sum of the digits along the path indicated by an arrow, not including the arrow cell itself, is equal to the sum of the digits along the gold-colored line attached to that arrow. Okay, so I understand now why I did not understand this. So in this case, the yellow things are not the paths, which was, when I first read this, I thought the yellow things were the paths. But no, the paths here are the straight lines along this. And so this is saying, for example, if I sum these two cells, the sum of these is equal to the sum of these three cells. Or if I sum these four cells, the sum of those four cells is equal to the sum of these two cells. Okay. And we have Friar in the house. Great to have you, Friar. I am looking forward to this. Let's see. Okay, so these two digits are a 1 and a 6. Now, this digit can't be a 6. Because if this digit was a 6, now these two digits need to add up to something that is at least 12 at the very minimum. And in order to get to 12, I need both of these to be 6. But remember, we made this 6. So this isn't a 6. It's a 1. So that's a 1. That's a 6. Now, along this line, again, the absolute minimum this could possibly be is that this is a 4 or a 5. Yeah, the arrow goes to the end of the grid. That's right, SPQ. So, in fact, actually, you can write out these are 4, 5, 6. This can't be the 6 because of the same exact reason. This can't be a 4, because if this was a 4, the maximum I could make this is 10, but this being a 4 has already made this sum to 11. So this is not a 4. So this is a 5 or a 6. And so now this cell now has to be a 4, 5, or a 6, because the sum here is now 10 or 11. And so I need to make sure these numbers sum to 10 or 11. Actually, does this being 5 work? If this is a 5, could be a 6, that can be a 5. I think that's fine. Okay. Let's look at other lines, because we have other lines. So we might as well use the fact that there are other lines. These two digits need to collectively sum to something that is at least 5. I guess at least 5 is not the most restrictive thing that has ever happened. Let's see. Row 3, column 1 is never a 6, says Listesh. If this was a 3... Sorry. If this was a 6... yeah, if this was a 6, what am I going to make this? Well, if I make it also a 6, I need these to add to 12, and they can't. If I make it a 5, then I need these to add to 11, except I've just removed their ability to because of this. So this is never a 6, I agree. I missed a cell on the gold L shape. I don't think so. I mean, I guess I could do better at bounding these below. I could have said this has to be at least a 7, because this could be 2, 1, 4. Okay. Now, if this is a 4, it breaks in an interesting way. I mean, 7 is more than 5. I wasn't trying to really bound it in a good way, but okay. So if this is a 4, then that makes this a 4, except now wait, no, if this is a 4, that makes that a 4, makes this a 6, makes that a 5. That all works out, actually. I think this can be a 4. Let's see. Okay, we're going to gratuitously pencil mark these things. Again, the absolute minimum that these digits can sum to is if they sum to 7. So if there's a 1 here, there's also a 6 here. And then that would have to be 2, 1, 4. It seems suspicious. Let's see. The row 4, column 3 arrow. 4, column 3 arrow. Sums to 10 or more. Oh, that's a smart observation. Okay. Very smart. Okay. I somehow had not appreciated this. Look at this one. This one goes up here, and so it grabs a 3 and a 5 and a 2. That's 10 already at absolute minimum. And so if I need to sum to 10 in 2 digits, I can't ever use a number that's smaller than 4. So that's 4 or 5, and this is 4, 5, or 6. In fact, this one can't be 4, actually, because if this were 4, I couldn't get this high enough. So this is 5 or 6. That's 4 or 5. And actually, now this side needs to sum to at least 10. And so these are 4, 5, or 6, just to sum to at least 10. That actually gives us a 4, 5, 6 triple in column 1. That's really cute. These are 1, 2, 3. I suppose, know that these are 1, 2, 3 as well. While I'm gratuitously pencil marking everything, might as well pencil mark that too. So people are pointing out the absolute maximum that these two cells can sum to is 11. So because the maximum of these two cells is 11, I now know that the maximum this cell can be is a 3, so it's never 4 or 5. It's always 2 or 3. Casey is also noting that. By the way, hello, Casey. Let's see. Thank you, honey. Have I pencil marked enough in this row to get me anything yet? I fear I have not yet. Okay. I'm actually running into an interesting thing now with this diagonal, which is that these digits are actually not that big. I guess this one could be as high as a 6. If this were a 1, the maximum this could be is 1 plus 3 plus 5 plus 3. That's too many. I can't add that many. Anyway, the point is I'm suspicious that this line is going to become useful. I do know that one of these two is a 6, because if I don't use a 6, then I am going to be out of luck as far as getting to at least 10. Can I rule out the possibility that these are both 5 somehow? If these were both 5, would that break anything that anyone sees? Let's see. Row 4, column 3. must go in row 3, columns 5 and 6. Sorry, row 4, column 3. Must go in row 3, column 5 and 6. Which intersects with the gold L. Okay, good point. So this 5 or 6 is in this sum. So this sum includes a 5 or a 6. Unfortunately, it could still just barely also include, say, the 4. Because the maximum this line can sum to now is 9. But 4 and 5, unfortunately, do add to 9. Okay, Carl answers my question before and says, I don't think this can be 5, because if this was 5, this would have to be 5. Okay, why is that bad? That's what I wanted. Why is this bad? Okay, so if these are both 5, then that's a 4, and that's a 6, and that's a 4, that's a 5. Unfortunately, I don't think we've broken yet. Oh, it makes row 2, column 3 a 4. Okay, so yeah, this would be a 5. That would be a 4. This would be a 4. That would be a 6. I still am not seeing why that's a problem immediately. Row 2, column 2, and row 4, column 3 have to be different. If not, they go in row 6, column 1. Okay, row 2, column 3 plus row 2, column 4 equals 5. Okay. Carl is seeing a connection I have not yet figured out between how this being 4 or 5 affects what's going on maybe over here. I'm not even sure exactly where Carl is looking. I'm certain Carl is right. Carl has a very, very good track record. I just don't see it yet. Oh, wow, that's genius. Okay, now I get what Carl is saying. Okay. Wow, okay, this is beautiful. So if this is a 5, these two cells add to 5, but we said this cell is a one of these two. So what's the other one? Well, this is a 5, those two sum to 5, the other one is this same cell. That doesn't work. Wow, okay. I don't know if that's the intended path, but that's gorgeous. I really like that. We'd repeat this digit immediately. Okay, so that's this. So this is a 6, in fact. So these are not 6. Okay, now, by that same argument, this no longer can be a 5. Because if this were a 5, we would now end up repeating the same thing. So this is a 4. That's not a 4. Now, this is 5. We know we've got a 6 over here. Hey, Franco, welcome. So the digit that's here has to be one less. The digit that's here with the 6 has to be one less than this digit. So in particular, it's never a 5 or a 4 or a 3 for that matter. So we can actually rule all of this down to this possibility, I believe, in order to make that add up correctly. Okay. Yeah, only 17 more to go. We're getting there. Bit by bit by bit. Yeah, so if that's a 3, that's a 2. What now? I thought that was going to help. Okay. Maybe I should max out this again and look at this line that I've been sort of afraid to look at. Let's see. Okay, let's see. J40 has something. Row 6, column 1 can't be a 6 because it would make row 5, column 2. Sorry, row 5, column 2 equal to row 5, column 4. Okay, if this is the 6, yep. Perfect. Okay, yes, this is actually pretty straightforward. It's much more straightforward than the application over here. This is a very good spot, though. These two digits sum to the same as these two digits. So actually, because there's a 6 in these two digits, and there's therefore a 6 in these two digits, I actually know that this digit actually shows up here. So this digit's not a 6. So this digit is a 6. And we can actually pull out the color not that color, though. Those two digits are the same digit. So that is a worthwhile observation. So that being a 6 means neither of these are 6. Now, is it possible that the 6 actually goes on this yellow line? I'm very skeptical. Oh, I have a 4-5 pair. Let's look at the 4-5 pair first. The 4-5 pair is going to make my life much easier. Because the 4-5 pair is going to make that a 5, which then makes this a 5. Because these need to sum to 10, remember? So orange is 4. So now these cells need to sum to 10, so that needs to be a 2. So that's not a 2. So that's a 1-6 pair, so these aren't 1s. Let's see. That's not a 2 anymore. Actually, this isn't a 2 anymore, so it's a 5. Let's see. So these are not 2 or 4. That one is not a 5 either, so that one's a 3. That's a 4. That's a 5. This is not a 5. This isn't a 4. This is a 5 just by playing Where Does the 5 Go? A long favorite game of the channel. This is not a 3, so in fact this is a 1-2 pair. This is a 4-5 pair. No, wrong. I didn't do that right. This is a 3-4 pair, but I do know the order. So that is a 3. That's a 4. Now, this is not a 3 anymore. This could be a 3. That could be a 3. Okay. So now, yes, where does the 5 go when it's in the puzzle? The 5 goes in the garbage bin. We all know it. Okay. 11. This is at most 14 for these digits. Notice they already summed to 9, so these need to sum to at most 5. And so in particular, this is never a 5 or a 6. It's a 1 or 2. So that gives us a 1-2 pair, which gives us that's a 3. This is not a 1 or a 3. It is a 4 or a 6. And spoiler, it is not a 4. It's a 6. So that's a 1, and that's a 6. It was a weird-looking 6. Let's see, this 3 comes over here, so that's not a 3. These digits are, well, that's a 1 or a 2, just by the column. So that has to be the 3. Wrong type, that's the 3. So that places a 3 up here. That's not a 3. And now, presumably, we have to color 1s and 2s to figure out what way this works out. So I'm down. So we're going to make this the purple 1-2, and this the blue 1-2, the blue 1-2. So that's the purple 1-2. So that's the blue 1-2. That's the purple 1-2. That's the blue 1-2. That's the purple 1-2. That's the blue 1-2. So now we've got to figure out, okay, so this is 3, 4, 5 is 12. And now I look at this, those add to 11, which means in particular, okay, so these already add to 12, so this needs to be a 2. Otherwise, this won't work, is the point. So these are 1s. Okay, I will silently admit that I don't think the coloring helped, other than that it let me finish there. But that's the point, is that blue has to be bigger than pink. And so now we hope it works, because now this adds to 13, and these are 7 and 6 is 13. Nice little puzzle. I would like to see I'd like to see more with these sorts of lines. They're sort of they're not so different from double arrows, actually, but they're sort of like even more generalized double arrows. Okay. Next up, we have a Whispers puzzle by Amber Dot. I do not know Amber Dot, but I do like Whispers puzzles. So let's start by getting rid of those. Okay, what are these digits? Oops. These digits are a 4 and a 5. Now, remember that in a German Whispers puzzle of this sort, in a 6x6, we have to make sure that the difference is at least 3 along consecutive digits along the line. Okay. So there is a high digit among these two cells. That high digit must be a 6. So these digits are low. They're from 1, 2, 3. Sorry to hear your son got COVID on his birthday. That is no fun. Let's see. We have another person posting links. I successfully deleted one. I think that might be my first ever. I know that the 2 and the 3 go here in this row. They can't both go over here, so this is always a 2 or a 3. So I can actually color this line. That's low, that's low. That's high, that's high. So that's a 1, 2, or a 3. Oh, it can't be a 3, because if it were a 3, it would put a double 6 in those two cells. These are a 4, 5, 6, and that one can't be a 4, because if it was a 4, it would need to put a double 1 there, and it can't. You can place pi on the line as long as you place it next to digits that are at least 3 away. So you have to smuggle in a 7 from a different puzzle, but if you smuggle in a 7 from a different puzzle, it's A-okay. Let's see. Bye, Friar. Have a good night. Glad you got to see us do your puzzle. Okay, there's going to be 2 of something here, but I don't know what it is yet. Let's see. Oddly, I know that's a 3 or that's a 3. One of these two is the 3, because I can't put the 3 in the middle. Which means this cell... Oh, this can't be a 3. No, this is never a 3. Sorry, I made this more complicated than it needs to be. The 3 only goes next to a 6, so I can't place the 3 in either of these cells. So in fact, actually, this cell's a 3, which means that cell's a 6, which means this is not a 6. Which means this isn't a 6, which means this is a 6. Okay, that was much less complicated than I was trying my darndest to make it. Is it possible we're the same person, Tall Cat? Is that possible? Okay, so now... in this column, there's an orange up here somewhere, because this is a blue and an orange. So that cell's blue, that cell's orange. This column already has 3 blues in it, so that cell's orange. Also, while I'm at it, I probably should color these cells are orange, and these cells are blue, just recreationally. Slightly Less Tall Cat. That sounds like a good brand, right? People would watch Slightly Less Tall Cat streams. I think that's true. Row 5, column 4 is not a 4. Yes, I agree this is not a 4. So therefore it is a 5. Because there's only 3 high digits, and it's not a 4, because that would put 1s in both of these. So that's the 4, that's the 5, that's the 4. These 2 digits, I actually know they are a 5 and a 2. Let's see, if this were a 5, then that would have to be a 2. That would be a 1. That unfortunately seems okay. Well, here's the thing. I know that that's a 1 or a 2. So I know the 3 in this box is over here. And so as a result, I actually know that this is a 3. Because I need a 3 in this column, and the only place it can go now is here. So that's a 6. And so now that's a 6, because I need to put a 6 in this box somewhere, and that's become the only place to put it. So that's a 2, that's a 5. And we can do some coloring. Can blue that in. This is a 1. This is a very nice puzzle. I'm enjoying this a great deal. To the surprise of none who know me and know my love of line puzzles. So this is a 1 or a 2. But this is also a 1 or a 2, and it's not a 1. So this one's a 2, and that's a 1. So that's a 2, and that's a 1. This is probably a 4. So that's a 5. Can go ahead and do our bluing. It's important not to get behind on your bluing. This is a 2 or a 3. This is not a 1 or a 2, so therefore it is a 3, and therefore that's a 2, and therefore that's a 1. the bluing is just for fun now, because now we're done with the whisper part. We're now just going to do sudoku. So the 2 in this row goes here. So the remaining digit is a 4. The 6 in this row goes here. The remaining digit for the box is a 5. Let's see. There needs to be a 1 in this column. It goes here. There needs to be a 4 in this column, and it goes here. There needs to be a 5 in this column, and it goes here, and that's a 3. So that's a 3. And that is a 4. And that's the puzzle. And I will go ahead, because I really like this puzzle, and finish the coloring. Hopefully the setter will will know that I appreciate the puzzle, because I finished coloring it. Very nice. I wonder, so I was talking to Clover a little bit, and I know that some of the people who I did not know are famous speed solvers who also did set puzzles. And I wonder if that's possibly what happened here. I'm not sure, but I do not know them. But if they have more puzzles, by all means, please let me know, because that was fun. Okay, we have a Lucy puzzle next, but we need to relocate the zeta before we do this. Lucy is a regular chatter and submitter on Rank's stream. By the way, Rank's is streaming tonight in a little under 3 hours. So if you are enjoying this and you want even more Sudoku in your life, than that. Oh, Clover's here. Amber Dot is a newer setter. Well, very nice puzzle. I will have to hunt down more puzzles by them. Let's see. Okay, so these are... I'm going to uncolor these. Maybe, possibly. There we go. Yes, if 80 was not enough. Clover heart are 1, 3 up here. So if this were a 3, this would be a 6. If this were a 1, this would be a 2. So this digit's always a 2 or a 6. Periodically wandering off to fix bicycles. Very nice. These digits are all from 3, 4, 5, 6. Oh, and they're not 3. That was the whole reason I started writing that. Okay. 5 does not go on a black dot, so there is a 5 over here. 5 does not go on a black dot, so there is a 5 here. 5 goes in one of these 2 cells. That petered out somewhat quickly. Oh, actually, no, I can do better. 5 is in one of these 2 cells. So, in fact, 5 is in one of these 2 cells. One of these arrows is a 5. Let's see. I know one of these 2 cells is a 6. Does that help somehow? Yes, this is a very epic endeavor as these things go. 6. Epic is the perfect word, I feel like, to describe the caterpillar. So I know these are from 1, 2, 3, for whatever that's for. I need to observe something that I have not yet observed. That is my my plan. Observe something I've not yet observed. Well, thank you, Casey. I'm glad that you are enjoying this. This has been a lot of fun for me. So I am glad that you are also enjoying it. Okay. So these digits are from 1, 3, and 6. This one's not 3. So this is a 1 or a 6. So this is a 2 or a 3. Does that do it? Maybe not. Yeah, the timer is counting down until ranked stream starts, and we're trying to finish it in the time before then. Row 2, column 4 equals 3. Breaks box 1. If this is a 3, now that's a 2, that's a 1. Ah, right. Beautiful. Okay. That's really clever. Okay. If this is a 3, now that goes 2 and 1, except that's also a 1. So we've put 2 1s in row 1. So this can't be a 3. It is a 1. So 1, that's a 3. This is not a 3. These digits are... Oh, even better. That's a 2 now. So this is a 4, 5, or a 6, and it's not a 5. So this is a 4 or a 6. 4 and 6 are only adjacent to 2 and 3, so this is a 2 or a 3. These digits are a 2, 3, and 4. Oh, that's a good point. That's a good way to think about it, Jay. Unlike in 9 by 9, there's only actually a length 3 string of dots and a length 2 string of dots because we've lost 8. It's probably off with 5 somewhere. So one of these dots is always a 3, 6. I don't know which. So there's no 6 here. So the 6 in this box is here. Which means that the 6 in this box is in one of these 2 cells. That is very nice. And I know one of these is a 3, 6 as well for the same reason. So I could go ahead and fill in that these are not 3, 6, or 2. So in fact, actually, let's just note these 4 cells are not 3, 6, or 2. So what are the numbers that are not 3, 6, or 2? They are 1, 4, and 5 is what these digits have to come from. Because 3, 6, and 2 have to go there on the dots. Well, this digit is at most 4. I don't really want to pencil mark that, though. That seems a little desperate even by my standards. Oh, here's the thing. The 2 is definitely on this arrow. Because the 2 just gets placed over here, because the 2 can't go here. And so because of that, this arrow can no longer sum to 4. That's really cute. Because if this arrow summed to 4, it would need 2 2s. So this is either a 5 or a 6, and so this is a 2, 3, or 4. Depending. So right, and this can't be a 4, because if this is a 4, now this is a 2, and this is a 1, and that doesn't work. So in fact, actually, just because of this black dot, we actually get that this actually is a 5. Let's say 4 or a 6. Let's see. So these are a 1, 4, 5, 6 is what's coming out from these. So weirdly, I have a 1, 4, 5, 6 quad in the column. So this is not a 4. So that's a 2 or a 3. That's a 2 or a 3, which tells us this is a 4. So that's not a 4. Probably there was a slicker way to do that than the way I just did it, because the way I just did it was a bit of a mess, but we're going to go ahead and fill it in anyway. 1, 4, 5, 6. This isn't a 6. That's not a 5. This isn't a 4 either for Sudokological reasons. Let's see. Oh, I have a leftward looking 5 somewhere. I do have a leftward looking 5. Thank you, SPQ. So that 5 puts a 5 here. It means that's not a 5 either. Let's see. Is there any way, could this be a 5 if that's a 1? 5, 1, 6. Sadly, still doesn't look like it breaks as far as I'm able to discern it. I also have a downward looking 5. The 5s are doing some yoga. Okay, so we have the downward 5. So one of these two cells is a 5. I suppose I already even had a pencil mark that one of these was a 5, but that did not do me any good. It did not stop me from pencil marking 5s all over the place. So 2 is placed in column 5. Right. Okay, 2 is placed in column 5, right. I can't put a 2 in either of those two places because there's already one in the box, and I can't put one here because I can't make 4 or 6 with a 2. So this is a 2. So that's not a 2. This is a 1 or a 3. Which interestingly means there's always a 1 on this arrow. Is that interesting that there's always a 1 on this arrow? Because if there was not a 1 on this arrow, now, of course, it would sum to 8, which would be bad. It's either 3 here, 1 here, or 1 here, 5 here. Okay, so what are this? This digit only has 2 options. So it's not a 1, a 2. It could be a 3 or a 5. Those are the options for this cell. It's a 3 or a 5. Let's see. A 4 in row 5, column 1, or row 6, column 1, makes row 1, column 3 a 1, and that breaks box 5. Okay, so if there's a 4 anywhere to be found on one of these, then it makes this a 3, 6, which makes that a 1, which now means that I need to put my 1 here, but I can't because by putting a 4 over here, I've made this a 6. Can we shortcut that and just say this has to be a 3, 6? Is that true? Maybe not. But there can't be a 4 over here. I am inclined to agree with that. Okay, so let's try and dissect that. Can we get to a more concise version of this? So if this were any sort of thing with a 2 on it, then this will be a 3, 6. That'll be a 1. This will be a 3, 6. Okay, so we're just saying the 1 is either here or here. That is the point. Okay. So anyway, I do believe I cannot put 4s over here. This cannot be a 2, 4. And so, therefore, the 4 is locked into these, which tells me that that's not a 4, which gives me a 1, 6 pair, which tells me that these aren't 1, which gives us a 4, 5 pair here. Now, does that do us any good? Let's see. Maybe I should write I should look at this over here. So this is now not a 1, 2, or a 6. So this is a 3, 4, or a 5, and it's not a 5, owing to that. So this is a 3 or a 4. Oh, we have 1, 6 pair in column 3. Ah, got it. Okay. That got us a 1, 6 pair in column 3. I was looking at the one in row 3. But that gets us, this digit's a 4. Which now, if you squint carefully, means that one of these has to be a 1, 2. And one of them has to be a 3, 6. 4 is placed in column 3. Yep, we got the 4 in column 3. Row 3, column 5 is a 4. How are we getting that? Row 5, column 3. Row 5, column 3 is a 4. Yep, we got that. So the 4 is now there or there in this box. Okay, so if this were a 1, 2, it would make this a 3, 6. It would make this a 3, 6. Okay. So I think the point is we're always roped, because whatever this black dot is, it's identically repeated here. So there's an invisible black dot over between these two digits. So these are either a 1 and a 2 or a 3 and a 6. And likewise, there's an invisible black dot between these two digits for reasons that I suppose are more clear. Does that help at all? Oh, yes, it does. Because that means these two digits are the same digit. No, it doesn't, because it could go 1, 2, 4. Darn. Row 4, column 6 is not a 1. Let's see, if this were a 1, be a 5, 4, a 6, a 3, a 2. I don't think I see what goes wrong yet if this is a 1. I would like to, because it would be useful. So if this is a 1, then that becomes a 5, that becomes a 4, that becomes a 6. But also the arrow is a 6. Okay, so this is complicated. This is the slightly long reasoning, but the seeing this is really impressive. So if this is a 1, then this becomes a 5, which makes this a 6 right away. But also, more indirectly, this being a 5 makes that a 4, which makes that a 6. And so in particular, those two things both end up being 6. That doesn't work. So this is not a 1. Not a 1. So that's a 4, 6 pair. So that makes that a 5, that a 4, that a 3, that a 5, that a 1, that a 3. So that's a 4, that's a 6, that's a 3, that's a 2. That 3 makes that a 2, which makes that a 3, and that a 6, and that a 1. This now needs to be a 1, 2 pair, and it needs to go in that order. This now needs to be a 3, 6 pair, and it needs to go in that order. So that's a 1, that's a 6. That's a 4, that's a 1, and that's a 6. That was a beautiful, beautiful spot. Naverio had a different way of seeing it that involved roping as a way of thinking about what was going on. But there we go. We got through that one. Nice puzzle, Lucy. I really love black dots. I don't know why, but black dots just make really, really good puzzles generally. Okay, so next up, we have a puzzle by Conflux, which is an ordinary thermo puzzle. So I bet I know which way these digits go. So they are a 4 and a 5. And the best part is, because of the thermo, we immediately get to fill in a 4 and a 5. So this is now a 1, 2, or a 3, but it's not a 1 or a 3, so it's a 2. So we get to start by sort of just throwing down lots of pencil marks. That's a 5 and a 6. These are a 1, 3, and a 4. Okay. These can't be 2 or 3, which means that this is at least 4. But this can't be 5 either, because if this were 5, it would make this 6. So this is a 4. So that's a 5. Now this has to be less than 4, and so it has to be 1 again. We have a little mini theme going on with the things having to be 4 and 5, and that doing work for us. Yep, looks like Quinlex next. Yeah, that's right. I'm going to pretend that I'm going to finish before 8, but then at some point I'm going to get to Glipperl's puzzle, which I know is going to take an entire stream. So I should not get too excited. So that's a 6. That's a 5 because of the box. These are a 1, 2, 3 to finish the box. That's not a 1. These are... I don't know that I want to write those out just yet. We might wait just a smidge to do that. These aren't 1, 4, 5, so these are 2, 3, 4. Sorry, 2, 3, 6. Well, that one's not a 6. It's a 2 or a 3. Okay, so the absolute minimum, this could be 2, 3, 4. Or this could go 4, 5, 5, 6. Just to good lift all of that. This can't be a 5 because there's a 5 over there. Let's see. 6 in box 5. Yes, 6 in box 5 is placed there. Thank you. Which actually strikes a pencil mark from this cell as well. Good spot. Good spot, SPQ. Now, I need to put a 4 and a 5 in this row. But if I put either of them there, the puzzle immediately breaks, because I would need to put a 5 down here. So in fact, this is a 4-5 pair. I like that a lot. This is a 4-5 hidden pair. I don't know why the theme is hidden pairs today, but that's not a 4. That 4-5 also says that's not a 4. So in fact, that's a 3, that's a 2, that's a 1. That's a 6 for the column, just as a present. And now we know the entire contents of this thermo and their order. It goes 1, 2, 3. So that's a 1. That's a 4. That's a 1. These two digits are they're from 2, 3, 4. So that one's a 4 because it's from 2, 3, 4. This one's a 3. I could have just asked where the 3 was. Something doesn't look right. What did I do? 2 1s in box. Yeah, let's fix that. Okay, let's try again. This still goes 1, 2, 3. So that's a 4. That's a 3. Yeah, I don't know how, put lots of extra digits that didn't exist in this puzzle. This isn't a puzzle by. This isn't a Cogito puzzle. This is a 3. That's a 2. So I can still ask where 3 goes in this box, and it still has to go there. That has to be the 4. Now this row needs a 2. It has to go there. And then that's 4. And then this column needs a 1. And this box needs a 6. There we go. Alrighty, and so we're on to the last puzzle of part 5. So there's only one more part of this after this. Okay, so I have to now drag my scene over like that. Oops. Sorry, I wanted to move the zeta, not move the grid. Okay, so go ahead and do that. Okay, and let's look at the rules for Quinlux's puzzle. So we are on number 60 something. Okay, 67. Each cage in the grid is labeled with either times or plus. Treat the digits in the cage as three numbers A, B, and C. The three numbers must comprise a valid arithmetic equation A times B equals C for times cages, or A plus B equals C for plus cages. A, B, and C may appear in any order in their cage. Digits may repeat within a cage. For instance, a multiplication cage could contain 1, 3, and 3 because 1 times 3 equals 3. Okay, this looks fun. This is an immediately appealing rule set to me. So let's see. So we've got a 3 and a 5 here. Let's see. I do know that there has to be an even digit in one of these, or in this cage at least. Can't be 5. Oh, also each cage must contain a distinct equation. That was at the very end. Yes, okay. So, important to note, we aren't allowed to repeat equations. Okay, so what are these digits? These digits are 1, 2, 3, 4, 5, 6. Okay. I think this is a really minuscule deduction, but I don't think this digit can be a 4. Oh, no, it could be a 4 if it went 1, 4, 1. Darn it. I definitely can't put 1 in that cage, though, because I would be saying that something times 1 is itself. That won't work. Here, unfortunately, I could double the 1. But I can't make this a 1. Because then I couldn't double the 1. So in this cage, this isn't a 1 either. For similar reasons. But 5 could be the sum, and so it could be 1 and 4, or 2 and 3, or 3 could be the sum, and so it could be 2 and 3 adding to 5, or all sorts of things. Wrong? What did I do? Row 4, column 3. I think this really can't be a 1. You could, for example, do 4, 1, 4. Oh, 414 does work. You're right. Sorry, I could repeat. I don't have to repeat the 1. I just have to repeat either the 1 or the other digit. No, I can't repeat the 1. Sorry, repeating the 1 will not improve things. I have to repeat the none 1 digit in order to make this work. Okay, but it can't be in row 5, column 3 yet. If this is the 1, then these two would have to be the same digit. That's the correct way to look at this. Okay. Oh, yeah, that's probably a good idea to think about, okay, what can this be? And it probably can't be anything other than 2, 3, 6. That is Kurabon's contention, and I believe Kurabon that this has to be 2, 3, 6, because we agreed none of these numbers are 1. Because if one of these numbers was 1, then we would be in trouble. And so, what are the smallest greater than 1 numbers I could multiply? They are 2 and 3, which already give me 6. So this is a 2, 3, 6. This is not 2 or 6. This is not 3. This is not 6. This is not 2. These numbers are 1, 4, 5. That one's not 1. Okay, beautiful start. Okay, so that means this cage definitely does have a 1 in it, is the point. And the only place the 1 can go is here, because the only times equation I can make without a 1 is 2 times 3 is 6, and I've already made the equation 2 times 3 is 6, so this digit has to be a 1, and these two are the same. Those two are the same digit. Okay, that is a really cool break-in for this puzzle. I am very happy. So now that is a 4, that's a 5, that's a 1. This isn't a 4 anymore. Oh, 2 times 2 equals 4. No, I could make 2 times 2 equals 4. Darn it. You're right. 2 times 2 equals 4 is a valid equation. Let's see. So if that were 2 and that were 2, that could be 4. Oh, well. This isn't a 4, though. I can tell you that much. Oh, but the cage can never have a 6 in it. Why can't it be 616, Tall Cat? So row 6, column 3. Yeah, so the point is I need a repeated digit. So it is true to say these two are the same digit. I need a repeated digit no matter what I do. But my way of repeating the digit, I have 2 of them. I could repeat 2 2s with a 4, or I could repeat any digit with a 1. And so this digit is either a 1 or a 4. It's not a 2 or a 6, which gives us a 1-4 pair, which means that's not a 4 and that's not a 4 because they're clones. And so 1 would work with anything. 4 here would only work if these are both 2. Good night, Daniel. Okay. Okay. Kurbon suggesting we gratuitously pencil mark things. I am all in favor of gratuitously pencil marking things. So these are a 1, 4, and a 5. Let's see. So so one of these cages has a 1 and is a string of 1 and 2 consecutive digits. This is actually interesting. How many ways are there to make this work? Are there any where this is a 6? I guess this could be... no, if this is a 6, the only way I could make this work is 1 and 5, and that's not going to work, because, spoiler, 6 is the sum. Okay, so 6 is the sum, and so that means this is a cage with a 6 as the sum, and so it can't have a 3 in it. No, it could have a 3 in it. Darn it, it could have a 3 in it if it's double 3. But 6 is the sum of this cage. So this is either 6 with 2 and 4, so this would have to be a 4, or it's 6 as double 3. Those are the only options. So this cell's always a 3 or a 4. Okay. 6 and double 3 breaks. Night, Thomas. Thanks for stopping by. Okay, if this is 6 with double 3, that breaks the other cage. Because now this can't have any 3s in it. And so this would be a 5 with a 1 and a 4. And it would have to go 4 and 1. How far do I have to go? You end up with 2 and 5. Oh, right, because of this digit. This digit ends up being a 2. Right, okay, got it. Right, okay. If this is a 6 with 2 3s, then this digit becomes a 5, and this digit becomes a 2, and then what does this have to be? This has to be a number that it can't be. Okay, so this is not 6 with 2 3s. This is a 6 with a 2 and a 4. So that's a 4. That's a 3. This can't also be a 3, because if it was also a 3, not because I can't repeat in the cages, because I can repeat in the cages, but this can't be a 3, because then this would have to be 3 plus 3 equals 6, and it can't be. So that's a 5, and that's a 2. And then we get that this last digit is a 3. That's a 3. These are a 1, 6, 5. This 2 looks down and fixes for us that the repeated digit's actually a 6, which only worked with this being a 1. So that's a 4, 5, 1. That 6 fixes that that's a 2, that's a 3, and that's a 6. Okay, we're making some headway all of a sudden. Now let's fill in what these cells can be. These are a 3, 4. These are a 3, 4. Oops. These are a 2, 5. That's not a 6 anymore. That's not a 4 anymore. This is not 2, 3, or 6, so it is 1, 4, or 5. So this cage definitely has a 4 in it, is what we've learned. And so the sums that have 4s in them, well, it either is summing to 4, or it either is summing to 4, or it has 4 in the sum. Okay, let's figure out which it is. If it has 4 in the sum, then it has to be 4 is 5 plus 1, because I can't use 6. If it's summing to 4, then it would have to be either 4 is 2 plus 2, which it can't be because 2 is ruled out of the whole cage, or it would have to be 4 is 3 plus 1, which it can't be because 3 is ruled out of the whole cage. So in fact, this is a 1, 4, 5 triple, which means that's not a 4. It is the equation. 5 is 1 plus 4. In some order. Now, this can no longer be a 5, because if this was a 5, there is nothing this cage could be we've not already done. Because I cannot do 5 as 2 plus 3. I can't do 5 as 1 plus 4. I can't do 6 as 1 plus 5. So this now has to be the 1. So that's a 5. That's a 5. These aren't 5. That's not a 1 or a 5, so that's a 6. That's a 1. That makes that a 2, and that a 6. That a 4. That a 1. So this is 1 plus something is something, as of yet to be determined. Why not 5, 2, 3? We already have 5, 2, 3. It's up here. And we're not allowed to repeat equations, SPQ. 2, 4, 3, and 5. By the way, I appreciate you asking, because I can't have the rules on the screen for this. There's just not a really nice way to do it. So I appreciate you asking. But yeah, the reason why is because we can't repeat it. So now we look at this. I need two consecutive numbers here, but those two consecutive numbers cannot possibly involve a 5 because they would have to be 5 and 4, and we've already done that one. Or 5 and 6, and we can't do that. So that's a 3. And now, so we either have 4 is 1 plus 3, or 3 is 1 plus 2, and I think either is okay. Tallcat claims they're not. But we'll know in a second, because if I look across at this 3, that's a 5. The 3 looks over here and says that's a 4. The 4 bounces back and says that's a 2, and that's a 4. So I think Tallcat looked ahead one more step and saw how that was going to break further than I did. Woohoo! We got a pop-up message. I think that's 3 of 5 we've gotten a pop-up message on. So I think that... yeah, I really liked that one. That one was really cool. I think this is another one I'd like to see in a bigger puzzle. Alrighty, so now for the hard part again. We have to look at how does Quinlux's puzzle fit into Magnaduo's puzzle, and so it's the top right of Quinlux's puzzle goes in the bottom left of Magnaduo's puzzle. Okay, so top left of this puzzle was 1, 6, 3, 4. Wait. Sorry, top right is 1, 6, 3, 4, and I need to put the top right into the bottom left. 1, 6, 3, 4 need to go in over in Magnaduo's puzzle. Magnaduo's puzzle down here. Okay, and it was, again, 1, 6, 3, 4. So this is 1, 6, 3, 4, I believe, in Magnaduo's puzzle. Okay, so let me move the zeta now that we have this puzzle all set up. Okay, reminder... because I forgot, but I've remembered now. Orange lines are palindromes. So this is a palindrome puzzle. Okay. So these two digits are a 2 and a 5. Oops. We're on the last piece, by the way. These are a 2 and a 5. So these at the ends of the palindrome are also a 2 and a 5. Let's see. So what is that going to do for us? Okay. I think I might need to color. Let's do that. I didn't last time, but I kind of regretted it. Okay, so 5. These two are the same. 6. These two are the same. And those two I'm just going to leave uncolored because I don't think... Actually, maybe if I do there... Okay, yes, I can color them if I remember that I can double-click. Okay, so... the green cells can be neither 2 nor 5 nor 1 nor 6. So these are 3 or 4, which is, I think, exactly what Tallcat was telling me. But I think we just have to do this one at a time. Okay. The blue cells can't be 2 or 5 either. And these can't be 2 or 5 or 3 or 4. So these are 1 or 6. I suppose I could color the 2 5s if I have to. Those two are the same. I don't think I have any colors I can go to for the last one. The purple is... I think this can be anything as the moment currently sits. So 1, 3, 4, 6. Yellow can be neither 4 or 6 or 2 or 5. So yellow is 1 or 3. And brown seems to see 1 and 6. So 2, 3, 4, 5. Okay. So at least naively, that is the start of this. Purple. Brown is 2 or 5 in box 2. Yeah, note I have not at all colored these with the idea that they're different. Probably lots of them are the same. So a good question that is being asked is, where is yellow in column 4? And so yellow can't be purple because yellow is in a box with purple. And so yellow can only go in one of these two cells. So, and yellow's not green either. So in fact, this cell is yellow. It's a 1 or a 3. And it's not a 3, so it's a 1. So that's yellow, and I can just delete yellow now. And blue is 6, and I can just delete blue now. So this is not 1 or 6. Okay, so let's clear out our coloring now. Okay, so that's gone, that's gone, that's gone, that's gone. Okay, and now this isn't 1 or 6. It is 3 or 4. Got it. Okay. So that did good amounts of damage. So this is 2 or 5. This is the uncolored 2 or 5, as some people were calling it. It's that 2 or 5. This is the purple 3 or 4. Which now means, in particular, because this is a 3 or a 4... Wait, how do I know this is a 3 or a 4? Maybe I don't know this is a 3 or 4. Don't listen to me. How did I know this is a 3 or a 4? I don't know. I will now just use Carl's point and pretend that I didn't. Which is that brown is obviously 2 or 5, because brown up there has to go up on top of one of the flavors of 2, 5. Of course, it does not help if I type the wrong digits. So now this is a 3 or a 4. Okay, so... right. So now gray has to be brown. Good point. Because now where does gray go in this box? It can only go here. So let's find our gray and gray those. Then we have one less thing to keep track of. And I suppose we can actually go back now and we can actually use... we can actually color these now that we have freed up some color real estate. Where is 6 in column 3? In column 3. I don't see how I know 6 isn't in one of those. Gray in box 1. Okay, great. Gray in box 1 has now been pushed onto the tip of the thermo, which means that gray is 5, and so we can decolor it. And red is 2, so we can decolor it. So we're now done with that. Okay, so now 6 in this box now can only go here. So this is a 3 or a 4 to finish up the column. Let's see. So, this is a 2. How about that? Might as well fill that in. 6 in row 1. Great point, Medi. 6 in row 1 goes there. This cell can't be 3 or 4 because it sees both flavors of 3, 4 that we still have colored for some reason. And so this is not this could be a 1. It's not 2, 3, 4, or 5, or 6. So this is a 1. It's just a naked single in a weird way. And now this column is missing a 2, so that's the 2. Let's see. This is now a 3 or a 4, of course. Let's see. So what is left in this row? We need a 1, a 2. We've got a 3, 4, 5, and we need a 6. Okay, that's not a 2 or a 6, so it's a 1. This is not a 1 or a 6, so it's a 2, and so that's the 6. These digits are a 3, 4, 5. This one's not a 5, so it's the other 3, 4. I suppose we know it's green if we want. This one's not a 4. This one's not a 3. These are 2, 3, 4 to finish off the row. But this one's neither 2 nor 4. So it's a 3, which makes purple 4. Makes green 3. This is now a 2. That's a 5. That's a 4. That's a 3. Nice puzzle. I really like palindrome puzzles are a nice palate cleanser between whatever else is happening. So that was a really nice palindrome puzzle. Okay. Uh-oh, I see Glip Rolls is not the next one, but the one after the next one. There is much fear. Okay, let's move. Let's move the zeta. Oh, did I enter a digit wrong? Row 3, column 6. It is a 3, not a 4. Okay. So these rules are odd even sweepers. So an odd digit in a circle tells you how many of the surrounding up to 8 cells are odd. An even digit in a circle tells you how many of the up to 8 surrounding cells are even. Okay. Easy enough. So note it does not count itself. So I think the most important thing with these puzzles is always, do they count themselves? The answer here is no, they do not count themselves. These are a 2, 5 pair. Okay. So let's think about this cell, because this cell sees the entirety of its box. So it sees 3 evens and 3 odds except for itself. So one of those breaks. Which is it that breaks? So if this is an odd sweeper clue, then it would only see odd. So this is an even sweeper clue. And it sees 2 evens. That's the only way that works. If this were an odd sweeper clue, it would see... it would actually only see 2 odds, and it would be a 3. Okay, one of these is a 1. This one can't be a 1, because for exactly the same reason, it needs to see... It sees the entire box's worth of stuff, plus then some. So this is actually bigger than 1. Let's see. These are 3, 4, 6. Let's see. Can I rule any of those out? If this were a 6, I would be seeing 2 evens over here, and then I would need to see 4 more evens in these 2 cells. That's not going to work. So this is never 6. If this is a 4, then I see 2 evens over here, and I would need to see 2 evens over here. If this is a 3, then I see an odd there. Or sorry, I see 2 odds there, 3 odds there. So that is 3 odds already. So is the upshot that these 2 are always even? I think the upshot is these 2 are always even. Right, because if this is a 4, then I'm counting I need 2 evens there. If this is a 3, then I can't have any more odds, and then it doesn't work. Oh, look at the 1. Right. Okay. The 1 tells us which it is. Okay. Well, I was pleased with the argument about how these are even either way, but it is completely irrelevant because the 1 sees a 5, and so it can't see any more odds. So therefore, that's a 4. These aren't 4. That's not 4. Nor is it 2, so it is actually a 6. That's not a 6. Okay. Yeah, the deduction was cool. It was unnecessary, but it was cool. And well, we are at the end of the day doing this to have fun anyway, so I won't complain too much about having extra fun. We have a 2-5 hidden pair over in these 2 cells, just because 2-5 get pushed into there. So therefore, this is a 3 or a 6. Let's see. These are a 1, 3, 5. That one's not a 1. That one's not a 1 either. So in fact, that one's a 1. Let's see. Okay, so if this is counting odds, it already sees 1 odd there. Okay, this can't be counting odds, because how many odds would it have to be counting? It would have to be counting 5 odds, and I can't make all of these digits odd because one of them's a 2. So this digit's even, not odd. And so it has to be a 2. It can only be a 2. It can't be a 4 because there's a 4 in the row, and it can't be a 6 because there aren't even 6 cells for it to count. So that's a 5. That's a 2. Now, this 2, again, needs to see 1 more even digit. So this digit needs to be even, and therefore it's a 4, because 4 is the only even digit that it could be. So this is a 3 or a 5, and it's not a 5, so it's a 3, and that's a 5, and that's a 3. This digit is a 6. In order to make that work, we've got all the odds, so this is a 2 or a 4. This box is missing the 5, so that's a 5. Let's see. Okay, so how many filler words can I use in a short period? That was the effort we were doing, apparently. Do I know anything about this? Let's see. Row 3, column 1 has to be even, says Garion. Okay, so what's wrong if this is odd? If this is odd, it's a 5. And then that immediately breaks because of the same 2-5 pair. Right. Because of the 1 and the 3 given. Again, great use of givens to Ashish Kumar. This would have to be a 5, and it can't be because it's on a border. So this is even. So this is a 2 or a 4. Immediately. So where does the 5 go in column 1? It can't go there. It can't go there. So this is a 5. So that's a 5. That's a 2. Now, if this wanted to be a 4, I would need all of these cells to be even, but that would put 4 evens into this box. That's too many evens. So this is a 2. That's a 4. That's a 2. In fact, actually, if I paid close attention, I would have realized I was out of real estate for evens in the row already. This is a 1, 4, 6. That's not a 1. This is a 1 because it's not a 4 or a 6. So this is not a 1. That's my last even for this 2, but that doesn't actually get me anything immediately. Let's see. There's a 5 looking up at this 3, 5. That's the point. So that's a 3. That's a 5. That's a 6. That's a 3. That's a 6. That 6 looks down and sees that that's a 4. And that's a 6. That's a 1. That's a 3. And that's a 4. There's a 5 in column 3 already. Oh, sorry. I thought you were saying I repeated a 5 like last time, but I did not. Okay. So I think originally the bet was going to be, can you finish the caterpillar before ranks start streaming, which is in a little less than 2 hours. Uh, but I think the answer to that is now definitely no. I don't think we've made enough progress to do that. So now the bet is ranks stream starts in a little under 2 hours. Can we solve Glipperl's puzzle before we get to the end of the time before ranks start streaming? That's the goal. If we can do that, I'll be happy. Okay, so we can start with these two are a 1 and a. These are a 1 and a 6. Oh boy. Oh, I'm cutting off clues. I'm sorry. I can absolutely move stuff around. Sorry. Oops. Ah. I can shrink myself. Oops. Shrink the zeta. There we go. Okay. Is that better? I think that's probably better. You probably want to be able to see the clues. Wow, it goes Glipperl into totally normal cat. That is a terrifying combination of things. Oh, there's a bottom clue? Oh, I also couldn't see the bottom clue and was not aware that one existed. Okay, so I have to zoom out a smidge, so this is going to take just a second. Yep, it is normal little killer. All right, so sorry, I had to zoom out a smidge to make that work, just to fit this. Is that good? I think that's probably good. I feel I'm now using way more screen real estate than I should, but we'll make do with this for now. Okay, yes, this is just normal little killer. So the sum along the indicated diagonals is given by the numbers on the thing. So how on earth do we start this? Okay. Are any of these restricted? Because that's nowhere near a min or max. The longest solve on stream so far was a pure little killer puzzle by 2 to 10th called Carousel. So we, yeah, let's see. So this could be as high as 6, 6, and a 1 and a 2. Oh boy, yeah, that's not helpful, unfortunately. Okay, am I supposed to start coloring, like combined? Yeah, I'm afraid I'm going to want to be using multicolor, and I'm not going to be able to. Okay, let's highlight all the clued cells in yellow. So it's those, it's these, it's those, it's these, and it's those. Oh, the 11 and the 12 together look at least the tiniest bit appealing. Maybe not. Okay, let's try just the 11 and the 12 together. Wait, no, the 11 comes down over there. Okay, so this is an 11 and a 12. Okay, maybe that's not useful. Okay, I'm going to go with ranks instead. And look at the 14 and the 15 combined. Okay, so yeah, so the this 1 and 6 are definitely in here. Okay, so and I could maybe use a 5 and a 4. So is that exciting? Maybe that's not exciting. So 15 plus 14 is 29. At most, these now sum to what? At most, these now sum to 1 and 6 is 7, plus 5 and 4 is 16. So at most, these sum to 16. So I need these to sum to at least 11. Ugh, that's unfortunately not useful. Let's see. So am I supposed to be saying I know these sum to 29 and then move this around, and so... oh, well, that's not even useful, because I know that these two sum to 21 minus these, but I don't actually have any idea what these sum to, so that's not immediately helpful either. If this is a 6, is that too big for the 11 clue? Because I'm noticing the 11 clue is also sort of dangling into here. And so one of these two has a 6 on it. Okay, so let's green in, for lack of better things to do. Let's green in this. What number is green? There we go. So yeah, so if this was a 6, I would need these digits to add up to 5, which seems hard. Center mark the cells in box 4. Oh, interesting. Okay, so Tallcat has a point, which is that the 1 and 6 can't both be on this on one of these diagonals. Well, sorry, they can't both be on this diagonal. Maybe they can both be on this diagonal, as far as I can tell. But they can't both be on this diagonal, because then that would total to 7. And then in order to do this, I would need this to also be... Actually, maybe that could be 1, 6. Maybe I do not know. Let's see. We can, of course, center mark everything. So these aren't 4, 5. These aren't 2, 3. Have fun. You know the 14 cannot start with a 1 or a 6. I don't know that the 14 can't start with a 1 or a 6. How should I know the 14 can't start with a 1 or a 6? Like, this cell could be 1 or 6, right? It could just be that 1 or 6 again. Okay, so if this started with 2 1s or 2 6s, is that a problem? So 2 6s would mean these would have to be double 1. 2 1s would mean these would have to sum to 12. Ah, okay, okay. So this is not a 1 or a 6. Okay, so the... So I agree with Andrew's deduction. This is not a 1 or a 6. This is a 2, 3, 4, or 5, and it is not a 2 or a 5 either, actually, because there's a given 2 and 5 there. So this digit is a 3 or a 4. Okay. Does that help with anything? I mean, we've got a 12 here looking at the 3 or the 4, but that doesn't really seem to do anything. Let's see. We could try and look at the 11 and the 12 together now. Does that help? See, but currently he's working, so it doesn't count as time. Means the 14 diagonal has a 1-6 pair. Okay, why could these not be the 1-6 pair? I saw why these two couldn't be the 1-6 pair, although I couldn't remember that before. Why can't these be a 1-6 pair? Row 5, column 3 is a 1, 2, or 5. Where is Andrew's logic? Let's see. You know the 14 can't start with... Oh, it's the same. It's just mirrored what we did here, right? Or is it? If this was a 1 or a 6, I would be doubling this 1 or 6. And so I certainly couldn't be a 6. I'd have to be a double 1. But these could add to 9. Yes, it can't be 6. I agree. Oh, yay, Clover. Oh, here I was trying to figure out how you were getting rid of 3 and 4. But actually, the only thing we were really getting rid of was the 6. I had completely missed the given digits. Okay, good point. So this is 1, 2, or 5. Exciting. I hope we get there. I may need aggressive nudging to get through this this little killer puzzle. Let's see. Yeah, I'm not 100% confident in our ability to get through this. Okay, so this is only 1 if this is also 1. And so then these would need to add to 9, but that's very doable. Something to do with coloring 1s and 6s. Oh, Lord. Perhaps in the interest of time, I will just... Because if I scroll to the back of this, I can just copy the solution code out of this, right? And then I can go on and do other people's puzzles and then, quote-unquote, come back to this later. So I would prefer a humanable puzzle. Let's see. So, let's see. Okay, so the clue for... okay, we are in grid number... we're in grid number 70. So 2615 is the digits. Okay. 2615. I'm assuming that the digits listed under puzzle 70 are for puzzle 70, right? Mostly, I just want to get to Worlpian's puzzle before the end of the end of the chat, or before the end of today's stream, if possible. So I'm going to skip this one for now. Oh, scroll down and find out. That is a really smart idea. I can actually look at number 69 and then see if 69 agrees. 4352? 4352 is right. Okay, so we read this correctly. Okay. So yeah, we read this correctly, and Clover also confirms we read it correctly. So we will look at these. So 1, 2, let's see. These are a 3 and a 4. Let's see. Okay, so okay, so totally normal cats puzzle now. Oh, I need to adjust the zeta. Okay. Oh boy, you solved this all 3 times? Oh lord. Uh, that is a lot of times. Uh, Zeta needs to move. I think I moved the Zeta. I moved the Zeta. Uh, okay. Now, I am noticing that the givens are putting pressure on this end of the thermo. So we go 4, 3, 2 is the absolute max. So 3, 2, 1 is the that. Now this 3, 4 is looking at this, so this actually can't be a 3. This is a 2. So that's a 1. Just along the thermo. So these are a 1, 2, 3, 4, 5, 6. For now in strong air quotes. Let's see. So now this is beautiful because this 1 now looks at this arrow, which now can only be 2, 3, or 4 because this needs to come to at most 5. Let's see. So we got that. That 5 or that 6. Let's see. So there's definitely a 2 in these digits. Oh, well, how about I do a little bit of Sudoku and note that this is in fact not a 2, so it's a 3, 4 pair. So these digits are in fact a 1 something pair. A 1 what pair? A 1 and a 5. They're a 1, 5 pair. Got it. Okay. You can't say a favorite. They're all your children. I can't say. They're all my children. Also, it was the Between Lines puzzle by Edouard, which was indeed at least my favorite of the puzzles so far, as well. That one was really standout. Oh, there had to be a 2 on here, so this has to be a 2. That's the point. This has to be a 2. I can follow through on the basic reasoning that I say out loud and then don't actually act on in any way, shape, or form. 1, 2, 5. So this is a 3, 4, and a 6. Let's see. So this is at least 2. This is at least 3. Knowing this is at least 3 does not seem all that helpful, I'm going to be honest. I know there's a 1 or a 2 on this, but yeah, 2 in box 4. Ooh, nice. Okay, great. That is gorgeous. Okay, Ambrose has nailed it. 2 in box 4 is now placed here. Now, this arrow needs a 1 or a 2. It can't have a 2 at all, and it can only have a 1 exactly there. So this digit is a 1. And so this digit is a 4 or a 5. However, I'm about to know what it is because this 1 actually looks down and sees that 5. So this is a 4, and that's a 5, and that's a 1. And now that's a 3. And now this is neither a 3 nor a 4, so it's a 6. This is neither a 3 nor a 6, so it's a 4. And the tip of our thermo is a 3, which is super helpful because it means that's a 2. The 5 in this box goes here. The 6 goes here, so that's a 5. The grid border color is telling you whether you should read the rules or not. So if the grid color is black, and this is, I think, one of the smartest things that Clover did for this. If the border is black, it's saying if you think you know what the rules mean, you're right. And if the grid is red, it's saying if you think you know what the rules mean, you're wrong. That is my translation. Okay, so these are 3, 4, 6. That one's not a 6 or a 4. Oh, I guess that one probably I should have written in to start. These are a 4 or a 6. And also things like, I would never have guessed that orange was a palindrome, but orange in a very early puzzle was in a black box and told me it was a palindrome. So then I knew for every subsequent puzzle where there were orange lines that those orange lines meant palindrome if they were in a black border. That's a 4, that's a 6, that's a 5. So that's a 4. Oh, that 4 looks over there and sees that that's a 3, and that's a 4. Let's see. I need a 1 in one of these cells. I don't know where yet. Okay, let's fill these 2 digits in. I need a 2. It has to go there. So that's a 3. Let's see. This column needs a 1 and a 3. The 3 in this column needs to go there. So the 1 goes there. So that's a 6 and that's a 1. And so now 1, 2, 3, 4, 5. That's a 6. 1, 2, 3. That's a 4. That was a very approachable, totally normal cat puzzle. Awesome. Very pleasant, and I love the little reward. Like, you don't get much more of a reward and a dopamine hit in life than putting a 3 on the third space along a thermo. Like, that is definitely a big, like, yes, we did it sort of moment. Oh, we have an Afraid Not puzzle. Okay, so let me move the zeta around so that we can see the Afraid Not grid. Okay, and see, so to elaborate a little bit on the Totally Normal Cat, by the way, also frequent appearer on our stream, both in the chat, and we have often done their puzzles. Okay, so we're going to look up rules for number 72. We're back up here. Odd even sweeper. An odd digit tells you how many of the surrounding up to 8 cells are odd. An even digit in the circle tells you how many of the surrounding up to 8 cells are even. Did we enter a time loop? I feel like we entered a time loop and we're now going backwards through the puzzles, but we'll do it. So this is a 5 or a 6. Let's see. By the way, Afraid Not in chat. Hello, Afraid Not. Okay. We did this math before, and I think the upshot was this cell has to be a 2. Because if this cell was a 3, it would only see 2 odd digits. So this cell has to be a 2. I'm glad at least it turned out that it was the same odd even sweepers, and not that one of you counted the central digit and one of you didn't count the central digit. Okay, this one now, what is it counting? Is it counting evens or odds? Well, if it were counting evens, it would have to be a 2 because it can't see enough. So it's counting odds, but it can't be a 3 because that digit's already not odd, and lots of other reasons. So this is a 1, which means that this is a 4-6 pair. Which means that this is a... no, it does not mean it's a 4-6 pair. Zeta, count correctly. I just literally failed at counting to 1. That is a new low, I feel like. I feel like I can't go lower than failing to count to 1. But that's what happened. One of these is odd. One of these is even. Alrighty. There is a 2 over here. Oh, in fact, there's a 1-2 pair in these 2 cells. That's gorgeous. This could never be a 1. Because if this is a 1, it would be somehow saying there's only 1 odd digit across these, which means you broke the Sudoku somehow. So that's a 2 and that's a 1. Now this 2 already sees 2 even digits up here. And so as a result, all of these digits are odd. So these are 1, 3, 5. These are 2, 4, 6. This time I think I counted to 2 correctly. I think there's already 2 evens around there. So now this is a 6. Lots of cleanup to be done. That's not a 1. Counts odds or evens of the same parity as itself around itself, not counting itself. Correct. That's a 4. That's a 2. Yeah, we always exclude itself. So lucky that we happen to get the same rule about counting yourself or not as the other puzzle. Okay, this is a 1. Let's see. 2, 3, 4. This is a 5. Let's see. So these 3. You almost could have put these in black boxes and taught people what a circle means as a quote-unquote standard rule that happened to show up more than once somehow. The amount of times that it happened that the same rule set came up very close to each other in the packet is also really interesting. The 4 here goes up there by Sudoku. This is now a 5 because of the 3, 5 there. So that's a 3. Yes, it would have been... and I feel like about half the time I've encountered it, it's either or. So it does seem like just a delightful... But yeah, if they'd been different and been 2 puzzles apart like they were here, that would have been, oh boy. So here's a fun fact, because those are 2, 4, 6, these are 2, 4, 6, and these are 1, 3, 5. Now this one's not a 1, which is very interesting because this is odd, and so it needs to count. It can't count up to 5 because these are both even. So this has to be a 3, but this being a 3 actually means it needs to see only odds in these 3 cells. So these cells are all a 1, 3, 5. Now notice this one can only be a 5. So this is a 3. So this is not a 3. It's a 1 or a 5. At a certain point, you had to request no more renbans. I am sorry if I contributed to the problem of there being too many renbans. I thought I was helping by not making up some ridiculous Zeta rule set and not using an inordinate number of different constraints in the same puzzle. Let's see. I only used 3. 3 isn't that inordinate, is it? Okay, 3 is actually pretty inordinate for a 6x6. This is a 6. That's a 5. This is a 2. So that's not a 2. Let's see. These are 1, 4, and 6. There's a 4, 6 pair. So that's a 2. So these aren't 2. This is a 4 or a 6. Okay. It can't be a 6 because it already sees 3 odds. So this has to be a 4. And that's a 6. That 4 sees down, I suppose. The 6 also sees down. Giving us our perfect chocolate teapot triple, as I think Mark likes to call them. The 6, though, does look up there and see that that's a 3 and that's a 6 and that's a 3. Okay, and so these are a 4, 5, and 6. This is not a 4. This is not a 6. Okay, and so now I think to resolve this, I think we now have to look at the right circle. So this circle looks appealing to me. So this circle needs to see 3 odds. Those are the 3 odds. This is a really nice puzzle, by the way. This is very smooth. So this 3 already sees 3 odds, so this has to be even, and that's going to hopefully do the rest of it. But very nice, Afraid Not, and glad that you could be here for the solving of it. 4 and a 1. Very nice. Super smooth, and I like that just a few circles. Yeah, very pleasant, very smooth. Nice. Okay. Next we have Swaroop's puzzle. Swaroop is the creator of Penpa, and we like Penpa around here because Penpa lets us do things like this thing we're doing literally right now. I should double check. This is the Swaroop who made Penpa and not a different Swaroop by a coincidence, right? I assume so, but correct me if I'm wrong. Let's do that. Okay, that looks pretty good. but it does have a red border, so I need to make sure that 73. I need to make sure I read the rules. Okay. This is an ordering Sudoku. Treat the contents of each cage as a 2-digit... Wait, what? Cage? Wait, that's 75. Oh, I can't read. We already failed at counting to 1 today, so my ability to match numbers should not surprise you. I'm reading 75. I want to be reading 73, which is up here, the previous page? No, there's 72, 75, 74. Let's see. Okay, where is 73? 73, got it. Okay, 73 is above 72 because we're now going up the caterpillar. I feel like this would have been easier for me to track if I was doing this on the one giant grid, although I'm pretty glad I didn't because then the lag would have been bad. Okay, maximum arrows. The digit in the circle has the same value as the largest, not necessarily unique digit for the attached arrow. For instance, if an arrow's line contains 2 and 4, then its bulb contains a 4. If you loaded the puzzle in Penpa before this time, the given 5 is missing. Please add it. Okay, but we do have the 5. Okay, so maximum arrows. So we're going to put in the circle the maximum digit that occurs along the arrow. Okay. So that's very interesting. So let's start by filling in these. 1, 2, 3, 4. Let's note that this has to be the same as that digit. Just because, well, if it were the same as this digit, that would be a problem. And similarly... Okay, I'm going to start with actually doing the same thing, but on this arrow, because I actually know something about this arrow. These two have to be the same digit. Okay. This digit is a 2, a 3, a 5, or a 6. Well, it's not a 6 because it's not the maximum. So this is a 1, a 2, 4, or 5. Okay, well, it's not a 1 because it is the maximum. It's not a 2 because that can't be 1. This can't be 5 because that can't be 6. And so, but this digit is the same as this digit. So it's not a 5, it's a 4. So we get 2 digits in the grid. And even better, we get to reclaim our coloring. So that 4 actually gives us, that's a 1 and that's a 4. These 2 digits are a 2 and a 3? Oh, interesting. So these digits are all from 1 or 2. These digits are all from 1 or 2 because the biggest digit on this is a 2 or a 3. But this is not a 1, so this is a 2. Wait, I did that wrong. Don't listen to me. This still is, it's still true to say that these are a 2, 3. But that only means that these are from 1, 2, 3. They don't have to be less. Sorry, I started somehow turning this into a thermo. They're from 1, 2, 3. That one's still not a 1. So that's a 2, 3 pair. So this is a 5, 6 pair, and the given 5 sorts that out for us. So this is a 6. This is a 6. That's a 5. So one of these 2 digits has to be a 6, and the other has to be less than 6. Thank you. Thank you for jumping on that grenade to tell me, Clover, before I really screwed that up, as is my tradition on this stream. Let's see. So, I don't actually have any idea where this digit repeats. I know one of these 2 is a 6. So therefore I know this isn't a 6. And I also know it's not a 5. Okay, let's think about what this digit can be. It can't be 6. It can't be 5, because the 5 couldn't repeat anywhere along this arrow. In fact, actually, let's go back to my coloring from before, and let's note that these two have to be the same. So we select these. Okay, so what can they be? They can't be 5 or 6. It can't be 4 either, because that side sees a 4. And it can't be 1. So this is actually 2 or 3. So that's very interesting. Okay, so this is 2 or 3. So this is also from 1, 2, 3. And that means we have a 4, 5, 6 triple across the row. That one's not 6 or 4, so that one is 5. Sweet. So that's a 6. That's a 4. And now because this is not a 6, this has to be a 6. By magic. So now this has to be a 1 just by sudoku. Something sudoku is magic. This is a 1 or a 2. These are a 3, 4. Let's see. Row 3, column 5 cannot be a 3. Right. Because if it were a 3, then it would be higher than this digit, and that's not allowed. So that is a 1 or a 2 only. And it's not a 1 either. So it is a 2. So that makes that a 3 and that a 3. So that makes this a 1. Makes that a 2, that a 3. Now this arrow has to have a max of 3 to work. Okay, this is a 2 now. Okay, this column now needs a 2, and the 2 can only go there. So that's the 5. That 2 comes over here and sorts this stuff out for us. That 3 is sorting that out for us. That's a 1. This box has a suspicious missing digit, which is probably a 5. 6 goes in one of these two, but I don't actually know which. What else is missing? A 4. 4 needs to go in this column. It can only... Uh-oh, I broke the puzzle. 3 is backwards. You have repeated 3s. Where did I repeat the 3s? I entered the wrong digits over here. That's a 4. That's a 3. So now that is a 1. Okay, so now this still is a 5. Okay, so I need a 4 in one of these cells. That's the 4. Puzzle is less broken now. That's a 6. This is a 1. And this is a 6. Very nice puzzle, Swaroop. No! I have to go back and start the caterpillar over at the beginning. I do wonder what the longest, if you screwed up a 2x2, what the most puzzles down the line it could be before you realized that you had broken it. That is what my weird brain wonders. Okay. Okay. So the typo was in the one place that would have messed up the next puzzle. Yeah, that is also true. Okay. So 74. We found 74 previously. Red or black circles appear at some intersections of 4 cells in this grid. A red circle indicates that the 2 pairs of digits diagonally opposite each other have different ratios. Okay. So if this were a 4 and this were a 2, it could not be the case that this was a 2 and this was a 1, because those have the same ratio. A black circle indicates that the 2 pairs of digits diagonally opposite each other do have the same ratio. If an X appears in a circle, then both pairs of diagonally opposite digits around the circle, neither digit is divisible by the other. So, for example, 4, 3, and 2, 5. If no X appears in the circle, then in both pairs of diagonally opposite digits, one digit divides the other evenly. Whew, okay. A lot to take in there. So we have red means different ratio, black means same ratio, and then we have X means don't divide each other. No X means do divide each other, right? No X, right. They do both evenly divide each other. Okay. So let's try to make this. That's pretty bad luck as these things go, Clover. They broke they broke puzzle 12 and then didn't find it until they got to number 15. That's unfortunate. Okay, so if everything is going to divide everything, I guess I could have a 1 and any digit. Could I possibly not have a 1 if everything's going to divide everything? Oh, well, I literally know by Sudoku that there is a 1 on this. Because there's a 1 down here. So literally there's a 1 up here for sure. Okay, now the 1... So the X means neither. Does the X mean neither divides or one of them doesn't? Neither, for both, neither is divisible. Okay, so because of that, this digit can't be a 1 because a 1 would evenly divide anything. So this is not a 1. Uh-oh. My, oh, nope, there we go. My keypad was trying to give way. There's also a 2. Mysterious. Yes, there's a 2 as well, just by Sudoku. So here, everything divides everything. Or sorry, everything divides its opposite, and they have the same ratio. Okay, so what could that ratio be? It has to be an integer, so it could be 2 to 1, or it could be 3 to 1. I think those are the options. So I think it is 2 to 1 or 3 to 1. I think those are the only options. Because I can't do 2 different ways. There are not 2 different ways of making 4 to 1, but there are 2 different ways of making 2 to 1 and 2 different ways of making 3 to 1. Now, let's see. I can maybe do the same trick over here. The 1 has to go here because the X, again, can't have a 1 on it. Oh, Kurobon has a good point. It can't actually be 2 to 1. 2 to 1 is not possible because if I wanted to make the common ratio 2 to 1, I'd have to repeat the 2. And the way that this dot is dispositioned, I can't repeat a 2. So, in fact, it actually has to be a ratio of 1 to 3. And a ratio of no, it could be 2 to 1. It could be 6 and 3. Is fine. Oh, but is it always okay. So it's not the case that it's always 1 to 2 and 3 to 6 or 1 to 3 and 2 to 6. It's the case that always the digits involved are 1, 3, 2, and 6 because, and this is the other way to look at it, I can't use 4 or 5. So this is always 1, 2, 3, 6. There's a 3 over here. I guess I can center mark this, but this is not going to be useful center marking. These aren't 3. Sorry, these aren't 3. These aren't 6. For the moment, that will be useful later. It is not useful now, I do not believe. Okay. So the 4 in this box is over here for whatever that's worth. This can't be a 1, remember? 2, 4, 3, 6 does not have a 1 on it, is the problem. These two digits I know exactly. These two digits are a 3 and a 6. However, this digit can't be a 6, because if this digit was a 6, then this digit would make an integer ratio with it, namely 1 to 1 is an integer ratio. So this is not a 6. This is a 3. And now this can't be a 6, because that would make an integer ratio, so that's a 2. So that's a 6. I think I understood these rules correctly. Someone will correct me vehemently if I am incorrect. So none of those are a 2. So therefore, that's the 6. So 2 is to what as 6 is to what? Does it actually work either way? 6 is to... I think it works either way. 6 is to 3 is 2 is to 1. No. 6 can't... no. It has to be 6 is to 3 is 2 is to 1. Does not work both ways. Can confirm. I just tried the same way twice, and it worked both times. And then I concluded it worked both ways, but it turns out that that's not actually how any of that works. This is a 2 or a 4. This is a 1 and a 5. So this can't ever be the 1. So that's a 5 and that's a 1. Because if this were a 1, again, that would not work. So now 5 can't be across from 5. It has to be across from 4. And so now we're done with this puzzle, and we can move on to the next puzzle if we want to. We won't, but we could. These digits are a 2, 3, 4. These are a 1, 5, 6. Neither of these is a 1. Wait. I did that badly. These digits are a 2, 3, 4. These are a 1, 5, 6. That one's not a 1. I did that better that time. Let's see. So, got a whole lot of stuff. Okay, so here the ratio is the same, but the ratio is not an integer. No, I said that exactly the opposite. Here the ratios are integers, but they're different integers. And here the ratios are the same, but the ratios are not an integer. Okay. Now this can't have a 1 on it anymore, which is actually pretty big, because here I need to have this... I need to have integer ratios without using a 1. Which means that if I want to have integer ratios without using a 1, I can use 4 and 2, or 6 and 2. Oh, I guess I could repeat any digit. I could do 5 and 5, and that would... No. Yeah, I could do 5 and 5. That would be fine. 5 and 5 would be okay. Okay. So let's look at this one instead. So this needs to be non-integer ratios that are non-integer ratios that are the same ratio. So there is a 2 up here somewhere. If I put a 2 on this, what am I putting below it? So if I put a 2 here, I'd need to put something that 2 does not divide. So I could do, say, 2 to 3 would be fine. Something non-even, something oddish would work. Okay, let's write in these candidates. So these are a 3, a 5, and a 6. Okay, I don't think 5 can possibly be involved, can it? There's no way I can make a ratio that involves a 5 twice. So there's no 5 here. So this is a 5. And that's a 6. Okay, good. We're making progress. So now these digits are a 2, 4, 5. Okay. This also can't have a 5 for exactly the same reason. So that's a 5. Okay, so this is 2 to 3 and 4 to 6, which is what I would have guessed, but I wasn't sure. Now, this 5 needs to make an integer ratio with something. Well, the only thing 5 is making an integer ratio with is 5. This digit needs to make an integer ratio with 2 or 4. And that means this digit needs to be an even number that is a 2, 4, or 6. Now, this digit just can't be a 6. Now, what actually has happened now is that this is a 2-4 pair, because they have to be different, but I don't know which way they go as of yet. But that does tell me, just by Sudoku, that's a 6, that's a 1, that's a 5. So these 2 4s are the same. Where does that 2 4 go in box 1? It goes here. So this digit is not a 3. Oops. So this digit is not a 3. Let me, in fact, color that real quick. Okay, just to keep track of that. While I'm at it, I might as well color that one because I can. And coloring makes me feel happy. This digit's now known. This digit now has to be a 3 because 3 is the only digit left in the row. So that's a 6 and that's a 3. Now, if I put a 4 here, that will not work. Because then I will have 3 is to 4 as 6 is to 2, which is not true. So I need to have 3 is to 2 as 6 is to 4. So that's a 2, that's a 2, that's a 2. This digit is a something. This digit's a 6. That digit's a 1. That's a 4. That's a 4. That's a 3. That's a 4. Very nice puzzle. That was very nice. I didn't find that too crunchy. That I just had to keep repeating the rules over and over again to myself for the first couple minutes I was thinking about it. It was like, what does it mean to be on a dot? What does it mean to be on this color dot? What does it mean to have an X? What does it mean to not have an X? But overall, very doable. Oh, that was Garlic's puzzle. Sorry, I didn't even read this. I need to be better about reading the doers. But that was Garlic's puzzle. I'm going to be right back. I'm going to take a quick break just to stretch my legs, but I'll be right back. And hopefully we'll be on the home front. I was just wondering if Clover asked people to do this in order of anticipated difficulty. So I was just imagining if the Glip Roll puzzle was like third, what that would have done to this puzzle collection. Would certainly have been terrifying if it was. Okay, so we have Eric's puzzle. I'm glad Eric made a puzzle. I know Eric doesn't make Sudokus very often these days. Eric is the original innovator of F puzzles, which has had a whole bunch of stuff based off of it. Eric now mostly makes really awesome pencil puzzles, including a lot of pencil puzzle genres that have been made that have really cool puzzles. And so if you've done many of the Gap puzzles, you've probably done a bunch of puzzles that Eric either set, because he is one of the Gap setters, or invented the genre. So Eric is a very impressive guy. Also, he will happily congratulate you if you get a feature on Cracking the Cryptic, so you can look forward to that. So we have some cages. We have a cage here that adds to 1. I am concerned. I'm going to skim here and see what it tells me about cages that add to 1. This is, what number was this? This should have been read. Okay. 75. Oh, this is the one I started reading before. This is an ordering Sudoku. Treat the contents of each cage as a 2-digit number, reading from left to right. The value in the top left corner of the cage tells you the rank of that 2-digit number when compared to the others, from lowest to highest. So the cage marked with a 1 must contain the lowest 2-digit number out of any of the 10 cages, and the one marked with 10 must contain the highest. No problem, Clover. It was definitely pretty clear as I started to contemplate what my options were for a 1 cage and 2 that something had gone wrong. Okay, so this is like this is an interesting twist on full rank that I really like this idea of a twist on full rank, because I think full rank can be a bit trying when it gets to the middle. So ranking just 2-digit numbers instead is a little easier. I think this is a really good idea. Okay, so these are a 1 and a 3. Now, 1 is less than 3, you may be surprised to know. So that has to be the 1, and that has to be the 3. Okay, so we can immediately say, since the second lowest number starts with a 1, the lowest number has to start with a 1. Now, the fourth lowest number starts with a 3, so the third lowest number needs to start with a 1, 2, or 3. And let's see. So now, because the fourth number starts with a 3, that means everyone after that, the 5th, the 6th, the 7th, the 8th, the 9th, and the 10th, those all need to start with 3, 4, 5, or 6. Now, this one can't be 4 or 5. Neither of these can be 6. Okay, and so the ninth digit can't start with, the ninth number can't start with a 6. So the 6th number also can't start with a 6, nor can the 5th or the 8th. So there is no 6 in any of those places. There's literally no way the 10th one starts with a 3, right? If the 10th one started with a 3 and also the 4th one started with a 3, they would have to go 31, 32, 33, 34, 35, 36. And that's not going to work. That's too many numbers, right? 4th, 5th, 6th, 7th, 8th, 9th, 10th. Yeah, that would be 7 numbers. I don't have 7 numbers. So this has to be a 6. It can't be anything else. But that now means this is automatically satisfied. These digits are 1, 2, 3. That one's not a 1. Right, okay. That is a good point that Garion has, which is that when I look at, for example, the 8th, it is in the same box as the 5th. And so these can't both start with 3, and if one of them is going to start with 3, it's definitely this one. So I know that the 8th one never starts with a 3, and so neither does the 9th one. And the same argument actually works with the 6th and the 7th. The 6th and the 7th can't both start with 3, but the 7th, if one of them is going to start with 3, it's got to be the 6th. So the 7th can't start with 3. And so we actually have a 4-5 pair here, which gives us a 1-3 pair here, which is awesome because it gives us this digit is a 2. I love this puzzle. This is a banger, as Clover is fond of saying. That's a 3. That's a 1. So these two digits are a 4, 5. So these are a 1, 3, 6. That one's not a 1. Let's see. Okay, so these are a 2 and a 6 in some order. Okay, so the third digit starts with a 2. Okay, so it goes second. The first and the second start with a 1. Then the third starts with a 2. The fourth starts with a 3. And then in this box, Carl is pointing out we can use the fact that 4 is less than 5. And if we apply the fact that 4 is less than 5, then we'll know that this has to go like that. Now, in fact, the 6th digit has to be less than the 7th. So, in fact, this has to start with a 3. So that makes that a 6. Now, the 9th digit starts with a 5. And 56 is the highest possible digit that starts with a 5. So this has to be a 4. That's a 5. That's a 4. Let's see. So this is not a 6. It is a 1 or a 3. Okay. The 6th number starts with a 3. So the 5th number also has to start with a 3. Yeah, this is awesome. I would do more puzzles like this on either a 9x9 or if it was offered more 6x6s with this exact rule set, I would do more 6x6s with this rule set. Such is my level of liking of this puzzle. These are a 2 and a 5. Okay. The 5th one being 32 would be suspicious. That would make this one have to be 31, but I guess it could be. Oh, in fact, it is 31. Not just that it could be. 1 is placed here. So we've got that there. Let's see. Okay, so 31. So the 5th number. Let's see. If this were 35, this would have to be 36, but that seems okay. The second number. What's the second number? It's got to be bigger than the first, so it's got to be at least 1, 3, but it can't be 1, 3 or 1, 4. So this has got to be 1, 5 or 1, 6. This number over here can't be 1, 1, so it's at least 1, 2. Can't be 1, 3. Could be 1, 4. Yeah, Eric's puzzle is supposed to be red border. It just isn't. This one's awesome, though. I really like this one. Okay, now that's a 2-6 pair, which makes that a 4, which means as Tallcat foretold it, the first digit is 14. I believe Tallcat had a vision that told him that that was going to happen. So that's a 4 by Sudoku. So this is a 2 or a 5 for the column, and it's not a 2, so it's a 5, and that's a 6, and that's a 2, and that's a 5. Let's see. Yes, just use the unique rectangle. That is that is always an option. Let's see. This row has a 2 missing. This is a 3. That's a 6. That's a 2, a 6, a 2, and that's a 5. Really nice. That's definitely one of my favorites out of a batch of absolutely excellent puzzles. This is among the very, very best of those. I really loved that one. Everything flowed so nicely, and just the idea of this. I mean, I bet you could even do a 9x9 with 2-digit numbers. Why bother polluting it by going into 3-digit numbers? But yeah, I feel like this is like the quote-unquote right way to do full rank Sudoku. Not that there's anything wrong with full rank Sudoku, but it gets a little grindy trying to, when you get to the like 5th decimal place that you have to look at. I feel like this is a really innovative idea to do something similar. Yeah, it is very rare that I do a puzzle and think, hey, this rule set could be like a whole thing, but this rule set could be a whole thing. Okay. We'll make move the zeta. Okay, we have Super Rabbit's puzzle next. 76. I know Clover was just getting into setting full ranks, I believe, but I have not done Clover's full ranks yet. I did a really awesome Jovi full rank on stream a while ago. I think that might be the only full rank puzzle I have done. Okay, if the digit X appears in a cell containing an arrow, then there must be exactly X digits greater than X along the path indicated by that arrow. For example, if a 3 appears in row 1, column 6, there must be exactly 3 digits with value higher than 3 along that diagonal. I don't know why, but 2-digit thermos pain me immensely. I don't know why I love this, but 2-digit thermos I don't like. That does not really make a whole lot of sense, but it is what it is. Okay. Well, here's a place to start. If I look at this arrow, there are 2 things here. So this is at most a 2. And it can't be a 1, because if it was a 1, it would be saying only... Wait, what happens if they're equal? Sorry, maybe this could be a 1. Okay, it does not say if it means greater, if greater means strictly greater, but I'm going to assume if you don't say that you mean strictly greater. So I think this could actually be a 1. So this is a 1 or a 2. Okay. This, though, I should be able to figure out with the power of maths. Because if this were a 1, it would be wrong. If this were a 2, it would be wrong. If this were a 3, it would be right. And if this were a 4, it would be wrong. So this is just a 3. It just is a 3. This digit, likewise, it can never be a 4. Oh, I'm spending a while debating if this could really be a 4. I should fill in these 2 digits. Still not remembering. If this digit were a 2, there are 4 numbers bigger than 2, and I can't hide 2 of them beyond here. So this is at least a 3, but it can't be bigger than a 3, because it can't be 4 or 5 right away. So this is a 3. So there are 3 numbers bigger than 3 over here, which means that this digit has to be a 1 or a 2, and it can't be a 1, so it's a 2. This is a really clever puzzle, too. Okay, so we've got a 4, 5, 6 up here. Okay, spoiler, this is not a 6. There are not 6 numbers along this diagonal that are bigger than 6. If there were 5 numbers along this diagonal that were bigger than 5, that would mean all of these digits were 6, which goes really well until we get here. And so this needs to be a 4. And so these numbers... Oh, no, sorry, I can't say anything about all the numbers, but... These are 5, 6. Yeah, people really stepped up and set really sweet stuff for this. It is because, and don't tell Clover I said this, everyone loves Clover. Let's see, this is a 1, 2, or a 6. That is not a 2. Let's see. What about these digits? 1, 3, 4, 5. But they're not 3. If you find the time code at which I quote-unquote did Glipperl's puzzle, you will see me looking at it and thinking about it for about 2 minutes and then looking up the code so I could skip it. So sadly, you do not have any fantastic videos of me doing Glipperl's puzzle to find. Sorry, Chip. I know someone was watching who wanted me to get to puzzle number 80, and if I had have done Glipperl's puzzle, I would not have finished Glipperl's puzzle in the time that it took me to do this. 3 is just placed in this box. It goes here. Okay. Okay, so this is 1, 2, 5, or 6. Okay. These are 1, 2, 5, 6. This one's not a 6 or a 2 by the column. So it is a 1 or a 5. Okay. This is not 1, 3, or 4. Maybe I should look at that. This is not 1, 3, or 4. So it is 2, 5, or 6. This being a 6 would be really interesting because it would force this diagonal almost entirely. Because remember, along this diagonal, I only get one number that's not a 5 or a 6 in total. So I have to think carefully about where the number that's not a 5 or a 6 is going to go. Here's a good point. This number has to be a 5 or a 6. Because if this number is not a 5 or a 6, then I put both 5 and 6 in this row, which means this number is also not a 5 or a 6. So this number actually has to be a 5. That's really cool. Because if this wasn't a 5, I would actually immediately get a second place where I had not put a number bigger than 4, and I need 4 numbers bigger than 4 down this diagonal. That's sweet. Like that a lot. So in fact, that's a 1, that's a 4, that's a 6, that's a 1. Although anytime I find something really cool like that, I immediately worry that Chad is going to tell me I was wrong and explain to me how I screwed something up. But so far, so good on that. Okay, got a 5 here. Okay, so 2 or a 6 there. Okay, let's fill in these digits. These are a 1, 4, 6. These are a 2, 3, 5. That one's not a 3 either. It is a 2 or a 5. Let's see. Okay. Well, this digit's definitely bigger than 1. Wait, sorry. I'm still trying to figure out this 1 or 2 clue. So if this is 1, then this would have to go... this would have to be a 1, and then this could be anything it wanted. If this was a 2, then this would have to be a 5. I really like this, too, as a sort of variation on the idea of a little killer puzzle. Like, I think as a general rule, anytime you can replace adding with counting, you should. And I think this does a good job of taking the spirit of a little killer puzzle and exactly the kinds of deduction that you could have. I don't know what you mean by you could have 2 2s. I don't know where you're saying you could have 2 2s. This can't be a 2 and that be a 2. Those can't both be 2. Because then this 2 is wrong. Unless I misunderstand the rules, which is always possible. Okay, so this diagonal, let me go back to highlighting diagonals. This diagonal only gets one number that is not 5 or 6. Let's see. Could this be a 6-5 pair, as I guess the question? And I think this could be a 5-6 pair, unfortunately. I think that is very plausible. Of course, if it is, this is a 6, that's a 5, and that's a 2. 6, 5, 2, 6, 5, 2. And that's a 2. No, they don't all have to be greater than 4. Only 4 of them have to be bigger than 4. Let's see. Carl says if row 2, column 3 is a 1, it makes row 6, column 1 a 1. Wait. Sorry. Row 2, column 3. If this is a 1, it makes this a 1, but maybe doesn't quite break. I got to row 2, column 3 eventually. I don't know why my brain just sort of like confidently grabs a random cell and thinks it's the cell being talked about, and then is continually surprised when it turns out not to be. Let's see. If this is a 2, it does make this a 1. So if this is a 2, then we go 1, 1. Row 4, column 3 has to be 5 either way. Okay, so why does this have to be 5 either way? Row 2, column 3. Yeah, so if this is a 2, that's a 5, of course. And if this is a 1, then that's a 1. I don't see why this has to be a 5 if this is a 2. See you there, Kurabon. Okay, let's see. So there was some suggestion, and I don't think this is a bad idea, to just good lift this box. These aren't 3 or 5. These aren't 1 or 4. Just to look at options along here. Row 3, column 2 can't be a 1. Okay. Can you explain why this can't be a 1? Because if this can't be a 1, then this can't be a 1 either. Now, one thing I'm noticing is that if this is a 2, it immediately makes this a 5, which rules this out of being high enough. But unfortunately, that's only one place. And I need 2 places to break it. Row 2, column 5 equals 2 breaks via row 2, column 3. Okay, so if this is a 2, then that's a 1. So that's a 1. I don't see it. Row 2, column 5 can't be a 2. If this is a 2, it's 1, that's a 1. Ah, got it. Okay. Whew. Okay, I can explain this. If this is a 2, this is a 1, and this is a 1. And now where does the 1 go in column 1? It goes there. And that's a problem because it puts 2 low digits on the 4 diagonal. Okay, that took a while for me to follow, but I agree. That does not work. So at the very least, we can say this is a 6 and that's a 2. So this is a 5-6 pair. So these are a 1, a 2, and a 4 in some order. This cell can't be a 2, I can say. I don't know if this is useful, but this cell can't be a 2 because it would make that a 5, which would make this cell not high enough. Same point. Row 4, column 3 is not a 2. Ah, yes. If this were a 2, it would make that a 5. Wait, does that do the same thing? If this is a 2... if this is a 2, it does the whole 1 deal again. If this is a 2, then we go 1, 1, 1, and then we get 2 low digits. So that's not a 2. This cell can't be a 5, because if this cell was a 5, it would rule 5 out. It would rule both of these digits out of being high, because it would put a 5-6 pair in this column, and a 5-6 pair in this row. So this cell can't be a 5. For the same reason, this digit can't be a 6, because if this digit is a 6, I put a 5-6 pair in the column, and also remove the ability of this to work, so that's not a 6. For the same reason, if this is a 5, I can't put both 5 and 6 in these anymore, and I also make this unable to be high, so that's not a 5. Okay, this is a really cool puzzle. Oh, that's a good point. Okay. Jay points out, if this digit's a 3, where am I putting the 3 in box 6? And the answer is very unfortunate, or fortunate, depending on your point of view. The answer is there. So this can't possibly be a 3 because it reproduces. It makes a second 3. Okay, so that can't. So that's a 5. So that's a 6, and that's a 5. I think that probably negated the need for a lot of the cool logic that we did along the way if we had have done that. But that's cool. I'm happy to have done all this. So now, so now neither of these is a 5. Interestingly enough, the 5 in this box is now placed here. Don't quite understand how that worked, but whatever. So this is a 2. That's a 3. So this is not a 2. It is a 1, and that's a 1, and that's a 1, and so that's a 6. It's a 2 and a 6. Yep. Surprise twist ending. Okay, this is a 2, 6, 3. Let's see. Yeah, this is a very cool setting job. Okay, so this is not a 1. That's not a 1. That's not a 1 or a 6. That's a 2, 4 pair. This 1 diagonal is handled. That 1, 2 looks up and sees that that's a 4. So that's a 2. That's a 4. That's a 2. This is not a 1 or a 6. So it's a 4. So that's a 6. And that puzzle's done. That was a really cool one. I enjoyed that one a lot. I'm going to move on because I still hold hopes out that we will somehow finish this, but we'll see. It's getting very tight to finish this. Okay, we're going to look at Jay Dyer, who has set one of my favorite puzzles of this year with the find the boxes puzzle that Simon did on Cracking the Cryptic. That then inspired some Math Pesto puzzles that I also really liked. So let's see what Jay has for us now. So these are a 1, 3 pair in some order. These digits can't be 4 or 5 for whatever that is worth. So these digits are from 1, 2, 3. I guess the one thing that I get from these digits being 1, 2, 3 is that this is at most a 5. 3, 4, 5. Okay, that's not... Oh, but it's not a 3. Okay. It's not a 3 because I have a 3 here, which means that there has to be a 3 on this arrow. If there's not a 3 on this arrow, then it would sum to 3 and that would break. So the 3 in this box goes up here. Let's see. Okay, so these are from 1, 2, 3, 4, 5 is all that's left for that. Both 5 and 6. Ooh, good point. Okay, so both 5 and 6 go in row 5 in box 6. So let's think about what that means. Could this cell ever be... Well, this cell's never a 6. Could this cell be a 5? Well, if this were a 5, that would have to be a 1, and that would make that a 6, which seems okay, except I put a 6 in the row. So that's actually never a 5. So per Rank's point, these are a 5-6 pair, which is sweet. So this is a 1 or a 3 as well. So these digits are... So that's actually interesting because that means these are from 1, 2, 3, 4. This could never possibly be a 1. I deleted the 1, 3 in box 5. Ooh, so I did. That is a 1, 3. Okay, so this is either 2 or 4. It can't be 3 anymore because this is either these are both 1, or 1 is a 1 and 1's a 3. Oh, they can't be a 1 and a 3 because it would break this cell. That's awesome. This can't be a 4 because if it was a 4, these would be a 1, 3 pair and this cell would have no value. I love that. Okay, so that's a 2. It's a 1, that's a 1, that's a 3. This is not 1 or 2 anymore. It's also probably not 4, as that would make 7. So this is 3 and 3 making 6 and 5. Okay, 1, 2, 3. Very nice break in for this this puzzle. Okay. Now, 1 and 3 go over here somewhere. So I know the 1 is in one of these two cells. Is it possible that there's a 3 in a circle here? If there's a 3 in a circle up here, the 3 would have to go... No, sorry, the 3 would have to go there with a 3, 1, 2, which is maybe possible. That's a little bit sad. Okay, this circle now, I guess it does have lots of options. It's 6, or it could be 2 or 3. Now this one could be 3, 4, or 5. I think I could prove that these two circles have to be different digits. The 1 over in this box I know goes in one of these two cells. The 6 in this column I know goes in one of these two cells. So the 6 in this column goes in one of these two cells. Pencil mark soup. Well, no way around it but through. Let's pencil mark these. I don't love that, I've got to admit. Okay. Where is the 5? Could I put a 5 here? No. Could I put a 5 here? No. So the 5 in this row actually can't go in. Neither of these two cells is able to be a 5, which is interesting. So the candidates for these look something like this. Oh, interestingly. Okay, so if this was a 1, it would make that a 2, which is okay. If this was a 1, it would make this a 2, which is not okay. So this is a 3 or a 4. Ah, there we go. This cell is a 3 or a 4, because if it was a 1, it would put a second one there. And so now once this is a 3 or a 4, now this is certainly not a 3. And now this has to be a 1 or a 2. So that feels progress-ish. Now this can't be a 2 anymore, because if this were a 2, those would both be 1s, which would break this cell. So now this is a 3 or a 6. Oh, but this can't be 3 either, because if this were a 3, these would be 1 and a 2 and break both these cells. Gorgeous. So this is a 6, which means that's a 6. Love it. Love it. These aren't 6. Okay. So if this is 1, 2, or 3, and it needs to add to 6, this certainly isn't a 1 anymore. So therefore, that's a 1. And so this digit needs to be either a 3, 4, or 5, which gives us a 3, 4, 5 triple in the column, which makes that a 1. Which means this isn't a 1. That's not a 1 either. This isn't a 1 either, which means that's not a 5, which means this is a 3, 4 pair, which means that is a 5, which means that's a 4, which means that's a 3, which means that's a 3, which means that's a 3. So this is not a 3. Sweet. So yeah, so this is 3 with 1 or 2, adding up to there. These aren't 5 anymore. So they're a 2, 4 pair. So these are not 2 or 4. These are 5 and 6. This digit has a value of some determination. It's a 2. Okay, 1, 2, 3. So this is 4, 5, or 6. This 4 sees over there, sees that's not 4. Let's see. I know one of these 2 is 2, I suppose. What is this? Could be 2. It's not 3 or 4. It could be 5 or 6. It is 2, 5, or 6. It is one of those. 3, 1 in box 1. Ah, right. 3 in box 1 gets placed here. Gets placed here just by Sudoku. And then 1 gets placed there. And now we have to place a... Let's see. So what are these? These digits are 2, 3, 4, 5. There are 2, 4, 5. That one's not a 5. It is a 2 or a 4. It's 2, 4 pair. It's a 2, 4, 5. It's not a 2 either. Okay. So the 2 in this box actually is here. That's a 4. That's a 2. This 1 looks down and gives me that that's a 2, which tells me that's a 5. That's a 4. These are not 5. That one's not 2 either, so that's a 6 and a 4 and a 5 and a 6. And that 5 goes over here. That's a 1. That's a 5. Da 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 da. Excellent puzzle. Nice little arrow puzzle. All right, we've got 3 more to do in 21 minutes. We're not going to finish, but we're going to try our best. Okay, so we've got some green squares to do June's puzzle. John's puzzle? 78. Green cells are friendly. That is the same number as their row, column, or box. We use their usual box numbering. And that's it. Yep. Friendly cells. So friendly cells are cells where their row, column, or box works out. Okay. I mean, I'm quitting in the middle of a puzzle no matter what, so I'm not super. I don't super care about where I am. Okay, these are a 2 and a 5. Oh, was there a negative constraint? I should have asked that. There appears to be no negative constraint on the existence of friendly cells. So these are a 1 or a 6. Okay, I should probably go ahead and pencil mark all the green cells. So this is friendly. So it is in box 1, it is in row 1, it is in column 2. So this is a 1 or a 2. In box 1, column 1, row 2. So this is a 1 or a 2. So those are a 1-2 pair. This is in box 3, row 3, column 2. Box 3, row 4, but it can't be a 4, column 1. This is box 5, row 5, column 2. And this is box 5, row 6, but it can't be a 6, and column 1. Okay, so I think that's what we get out of pencil marking the friendly stuff. So these digits are a 4 and a 6. These digits are a 3, 4, 5, 6. These aren't 3 because of that. Let's see. Yeah, that's a 4, 6 pair. Okay, what am I looking at here? This is a Y-wing, isn't it? So one of these is always a 1 by the Y-wing. So if this is a 2, it makes that a 1. If this is a 3, it makes this a 1. Either way, this is never a 1. It's a 2. And that's a 1. Which unfortunately was the way of resolving that didn't actually get us anything, I believe. Let's see. Well, it does play... Oh, no, it does not place 1 down there. Okay, row 6, column 1... makes that a 1 via the green cells. I'm not sure what we're talking about. Oh, well, we got the same place, I think, as the end of the day. The 1 sees right. So that's a 6. That's a 1. Good point. So yeah, one of these two is a 1, but I don't know which one. Okay. Well, that's a 1 just by sudoku. So let's go ahead and fill in the rest of this. This is a 2, 4, 5. That one's not a 2. And I know the 4 for the column has to be up here. So this can't be a 4. Let's see. These are a 2, 5, 6 is all that's left. In column 2, you can place the 4, 6 pair. Right. I have a hidden 4, 6 pair in column 2 because I can't put a 4 or a 6 here, and I can't put them anywhere else than these. So that's a 5, that's a 4 or a 6, and even better, this is a 4. This 4 tells me that that's a 6 and that's a 4. So these aren't 4, that's not 4, these aren't 6. They're a 3, 5 pair, so that is 6. So that's 4. So that's 6. Let's see. So we have a 1, 3, 5 triple in column 1. So as a result, this digit is just the 4 that we're missing. To finish off that, let's see. That 4 looks over and sees that that's a 5. So that's a 2. That's a 4. These are a 5, 6 pair. So these are a 2, 3 pair. We now have a 2, 3 pair in the row. So this is a 5 or a 6, and it's not a 6. So that's a 5. And that's a 6, and that's a 5. This is a 1, 2, or a 3. Oh, that 5 looks up there and sees that that's a 3 and that's a 5. That 5, that's going to do it. That 5 looks down and says that's a 1, that's a 3, that's a 2, that's a 1. That 2 looks down and says that's a 5. That's a 3. That's a 2. That's a 5. That's a 2. 3 looks over and says that's a 2. That's a 3. Nice. Oh, we've got a Scott puzzle. Friend of the stream, Scott Strassal. We also have a 5-list Scott Strassal to do soon. But for the moment, we're going to look at Scott's puzzle. We are almost at the end. So close. So this is Renbon Whisper Arrow. Let's see. These digits are a 3 and a 6. That was, by the way, that was a nice friendly puzzle. I'm only not talking about it because I am trying to get as much done of this as I can. So this arrow needs to sum to, at a minimum, 1 plus 1 plus 2, which would be 4. So this is a 4 or a 5. This digit has to be low, because if this digit were a 4, for example, on the whisper line, that would already make this arrow add to 6, which is too many. So this is 1, 2, or 3. So these are 4, 5, or 6, just by whisper logic. Let's see. So if this were a 3, these would both be 6. I don't think that's an immediate problem. Oh, maybe the question to ask is, I need to put a 6 somewhere in this box. No, that's not going to do it, is it? Whispers differ by 3 in a 6 by 6. 1 degree of freedom on the arrow. If I make 1, 1, 2 is 4. Oh, yeah, that's true. Okay, so these are always 1 or 2. I should fill that in. And I know there's never a 1 on either of these Renbons. So one of these two is a 1. For sure. Oh, this could be a 3. Sorry, this could be a 3 if that's the 1. You're right. There is a 1 or 2 on there is a 1 or 2 on this Renbon, but there's not both a 1 and a 2 on this Renbon. So this is a 2, 3 Renbon, and that's a 1. I love that. That's a 1. So these are the other digits. These are a 4, 5, 6. The 3, 6 even resolves the order. That's a 2. That's a 3. Now, this is a 4, 5, 6. I love that. That is sweet. Okay. This is a 4, 5, or a 6. So this is a 3, 4, 5, or 6. At the very least, these two digits are a 2 and a 6. Let's see. I think row 3, column 3 is a 4 or 5. let's see. Okay, so all right. Yeah, I know the 6 is up here somewhere. Let's see. Do I even still believe that one of these has to be a 1? I don't know that I still believe that one of these has to be a 1. Oh, yeah, one of them has to be a 1 just by considerations of the arrow. Because if otherwise they'd be a 2, 3, which would be too big. So this can't possibly be a 2, 3. This could be 3, 4, I think. Or 4, 5, or 5, 6. Unfortunately. Alrighty, what am I now missing? This isn't 1, 2, or 4. This is 3, 5, or 6. 2 in box 2. It's in the 2, 6 pair. Oh, sorry, in box 2. Right, I couldn't put 2 on any of these. So 2 is on the arrow and 1 is on the arrow. Okay, that's the point. I can't put 2 on any of these Renbon. Because then I would put 2, 3, and I'd make my arrow at least too big. So, in fact, actually, this is a 1, 2 hidden pair. Beautiful spot, which makes that a 4. Makes these a 5, 6. Makes these a 1, 5. Makes these a 3, 4. So this isn't 3, 4 anymore. So it's not 1, 2, 2, 3, 3, 4. So this is 4, 5, or 6, which means it definitely has a 5 on it, which means that this is a 1. That's a 5. This 1 makes that a 2, which makes that a 1. This is a really nifty puzzle, by the way, Scott, if you were watching this at some point in the future. This is not a 5. This doesn't have a 5 there anymore, at least. 3 only goes here in this box. So that's a 3, and therefore this is only a 4. This is not a 5, of course, because of that being there. This can't be 3, 4 because of the 3, 4 up here, SPQ. 1 in box 6 is down here. Thank you. This column is missing a 5 and a 6, which we can fill in, which says that's a 6 and that's a 5. So this is a 6. Okay, this is not a 6 anymore. That fills in, actually, that's a 3 and that's a 6. These two digits are a 2 and a 3 to finish the box. So this is never a 5. This is a 3, which means that's a 2, which means that's a 3. This 6 looks up here and says that's not a 6. This is a 4, 5, or a 6, except it's not a 5 or a 6, so it's a 4. It's a 6. That's a 5. That's a 4. That 2 looks over and sees that's a 6 and that's a 2. The 4 looks over and sees that's a 3 and that's a 4. 2, 3, 4. That's a 5 and that's a 2. Very nice. Okay. Can we, in 5 minutes, do a palindrome quadruple puzzle? So good luck. Let's go. So let's move the zeta. Yes, we can. Okay, so this digit has to be a 5 or a 6. These digits are a 1 and a 2, 3, 4, 5. They're a 1 and a 5. 5. A 5. These digits are a 3 or a 4. Sorry, this digit's a 3 or a 4. Uh, lines are palindromes, so these digits are actually both 3 or 4 because they see the entirety of 1, 2, 5, 6. So that gives me a 3, 4 pair in the row, which means that these digits are 1, 2, 5, 6. I need to have a 1, 5 inside this quad, and so the 1, 5 has to go there. I need to have a 2, 6 inside this quad, so the 2, 6 has to go there. I need to finish this column, so I need a 3 and a 4 to finish it, so this is a 3 or a 4, and it's the opposite 3, 4 of that. I will note there's a diagonal constraint, so that becomes a 4. This isn't a 2. These are a 1, 5, 6. Also, horrible apologies to WorldPN for rushing through your puzzle, but also I wanted to finish this today, which is not really a great excuse, but it is what it is. So there's a 4 in one of these two cells. Let's see, what else can we do? This 3, 4 goes here, just by sudoku. Oops. This 3, 4 goes there. This 4 actually looks up and tells me that that's a 3 and that this is a 3, and that's a 3, and that's a 4, and that's a 4. So that's the 4. So that 4 gives me a 3 inside this box, like that. The 4 on the diagonal sees up. We got that. Okay, so we've got a 1, 2, 3 triple to put here somehow. 5 or 6 to put here. Yeah, the chase music, the whatever. Okay, so the 3 and the 6 go over there. That's not helpful. One more 4 left. That sounds good. Okay, I bet I can handle the existence of 1, 4, which is going to go there. Okay, 3 and the 1, 2, 3 quad. The 3 and the 1, 2, 3 quad goes there. So these are not 3. They are 1, 2. Let's see. What else? 3 is placed by sudoku in the 1, 2, 3, 4 box. Got that. Okay. Row 1, column 3 is a 2. How do we know that? Let's see. Okay, there's only 1 3 left, I'm being told. The 3 needs to go here. 1, 5 pair in row 2. Row 2. I don't... got it, because of these digits. These digits are a 1, 5, which gives us a 1, 5 pair in the row, which means that that's a 6, which means that that's a 2, that's a 6. That 6 means neither of these is a 6. This 1, 5 pair gives us this digit's a 2. This digit is a 1, 2, 3, 4, 5. So this digit's 6. The 1, 5, 6 on the diagonal and 3, 4 in the box. Let's see. Okay, so these are a 1, 5, 1, 2, 5, 1, 2, 5. That gives me a 1, 2, 5 triple in the column. So that's the 6 for the column. Now, this is a 1, 2, or a 5. This is a... this 2 sees over here and sees that that's a 1. So that's a 5, that's a 1, that's a 5, that's a 1. That 1 sees that that's a 5, that's a 2, that's a 1, that's a 5. That 1 sees that that's a 2. Let's see, this is not a 2. What is left? Okay, 1, 5. What's left in the row? 1, 5, 6. This is the 2 for the row. This is the 6 for the cage. 1, 2, that's a 5. That's a 1. That's a 1. And that's a 5. And that's a 1. And we did it! I think we did it. Please don't point out that there's 2 5s in box 2. Don't look at it. I was just filling it in. This is a really nice puzzle, by the way. Sorry that I rushed through this. I could have given more commentary about how many cool design things there were in here. But this was a lot of fun. Thank you again, Clover, so much for making this. I'm going to go ahead and sign off right now because Ranks is starting in seconds only. And so you should go hang out with Ranks. Tristan will put a link in the chat over to Ranks, and I will see you there. Have a great day. Bye bye.